In the Azure cloud, Azure AD serves as a central network repository for things like user accounts, enterprise applications, groups, devices that are registered with Azure AD, and so on. What we can do with Azure AD Connect is we can link our Azure AD tenant to an on-premises installation of Active Directory. You might wonder why you would do that. Well, the first thing you have to consider is that there would be no user account duplication when you link these two directory services together. The benefit would be that users that are already familiar with using their on-premises credentials to authenticate can continue to use those to access cloud-based apps. So this is a great way to enable that kind of hybrid cloud environment. With Azure AD Connect, there is an on-premises AD Connect agent that you need to install on one of your on-premises domain servers. That would establish the link with Azure AD in the cloud. And you can reconfigure that AD Connect agent at any time on that device to support different options. Some of which would include things like password hash sync. This option synchronizes a hash of the on-premises Active Directory user password into the cloud. We've got pass-through authentication. This means we aren't syncing a copy of the password in any form to the cloud. Instead, the authentication is truly happening on-premises. Then there's federation integration. If you want to use Azure AD Connect with an ADFS or Active Directory Federation Services type of environment, we can enable single sign-on or SSO. We can even enable domain filtering so that we only synchronize, for example, users in a specific organizational unit from on-premises into the Azure cloud. When I say synchronize, as an example, we might only synchronize the password hash sync if that's the option that we've selected. Here in the Azure portal, I've navigated to my Azure AD tenant. It is called Quick24x7, and it automatically has the .onmicrosoft.com DNS suffix. What I want to do is create a custom DNS domain name so we don't have to use .onmicrosoft.com. So I'm going to scroll down in the left-hand navigator and select Custom Domain Names. On the right, we're going to have a listing for the existing DNS domain names. We've only got one, the default. I'm going to click the Add Custom Domain button up at the top. And I want to call this Quick24x7 test.info. Now, I already own that DNS domain outside of Microsoft Azure, and I'm going to have to prove that ownership. That's why we're going to have to validate it by adding a DNS record. I'm going to click Add Domain, and that will take me into the screen where I can specify whether I want to create a TXT or an MX record, so TXT record with the specified values, or MX record with the specified values. I create that in my external DNS domain to prove that I own it. After which, I can then specify these details and click the Verify button down at the bottom. Here in my external DNS registrar management tool, I've got my tool opened up so that I can add records to that domain, Quick24x7 test.info, to prove ownership. So down at the bottom, I'm going to go ahead and click the Add button to add a new DNS record. And this is where I can specify the type, such as a TXT record. I'll specify the host and TXT values and TTL that was specified in the Azure portal, and I'll save that record. So I've created that to prove that I own this DNS domain. Otherwise, how would that exist in there with that specified value? Back here in the portal, now what I want to do is verify that that record was created, which proves that I own that DNS domain. So to do that, I'm going to go down and click Verify in the bottom left. And after a moment, we'll have a message about the verification having succeeded. So now we can actually use this custom DNS domain name. So now that we've got two DNS domains available here for my Azure AD tenant, when I go to work with user accounts, so for example, I'm going to go to the users view and I'm going to click the new user button up at the top, I will have a drop-down list that I can select from to choose the appropriate DNS domain suffix I want to assign for the user account. And that would be part of what makes up the overall user principal name, or UPN. To link my Azure AD with my on-premises Active Directory, here on premises I've opened Active Directory users and computers. I've got a domain called quick24x7test.info. I've already got a custom DNS domain name for that in Azure. I've got the standard administrator user account. I've got a couple of OUs here I've created with users. I've got an East OU with a couple of user accounts, and West. In West, we have a couple of users like Maria and Nikki. Now we can sync those into our Azure AD environment in various ways. So here in the portal, I've navigated to my Azure AD tenant. And if I look at the roles and administrators in the left-hand navigator, just going to scroll down this list, and I'm going to open up the Global Administrator role. Here I've got Cody Blackwell, one of my Azure AD users, assigned to this role. Now this is going to be important because I'm going to have to sign in with an account that has this role as part of installing Azure AD Connect on premises. Here in my custom domain names, I've got quick24x7test.info, which matches my on-premises Active Directory domain name. So I've already created that custom DNS domain and verified ownership for it. The next thing I'll do in the left-hand navigator is click Azure AD Connect. Now currently, it's not installed as shown over on the right-hand side of the screen. However, we have no synchronization yet because nothing's been installed and synchronized, but it will be soon. So we've got a link here to download the Azure AD Connect agent that we need to install on an on-premises domain server. Once it's downloaded, I'm going to go ahead and install Azure AD Connect. So I'm doing this on an on-premises domain server. On the welcome screen, I will agree to the license terms and privacy notice, and then I'll click Continue. The default is do an express settings type of installation. So we have a listing of some of the options like configuring password hash synchronization, and the current forest we're logged into on premises is what we're going to sync with. All of those options are shown here for express settings. However, we can further control the installation by clicking Customize and specifying a different install location. We can specify to use an existing SQL server and so on. So I'm going to go down and click Previous. We're going to stick with our Express settings. I'll click the Use Express settings in the bottom right to get this started. So I'll need to connect to Azure AD with a user account that has the Global Administrator role that we mentioned earlier. So here I'm going to sign in as user Cody Blackwell. Then I've got to authenticate to my on-premises Active Directory domain services, so I'll fill in those credentials. And on the Ready to Configure screen, I'm going to click the Install button. And after a few moments, the configuration will be complete. So I'm going to go ahead and click Exit. Here in my Azure AD tenant, Quick24x7, we will have user accounts that exist on premises that have been synchronized or that show up here. We'll see Windows Server AD under the source column for users like Maria Martinez as an example. So that's an on-prem AD user that's showing up here now. We've also got user Matt Foster and so on. So these on-prem credentials can be used to sign in the cloud. Back here on premises, indeed, there's Maria Martinez, and in the east, we've got Matt Foster, Julio Chavez. So we've got these users on premises that were now made available in Azure AD, which allows those users to sign in and authenticate to Azure AD apps. Now, on my on-premises domain server, I've got an Azure AD Connect icon that's placed there after the installation, and I can run that at any point in time to change my configuration. So it says, Welcome to Azure AD Connect. I can click the Configure button, and I can make a number of different changes if I want to change the configuration over time. Here in my on-premises Active Directory environment, I've got some users in a West OU, so Maria Martinez, Nikki Flores. I've also got an East OU with Julio Chavez and Matt Foster. What we can do is configure Azure AD Connect to filter based on organizational units or OUs. In our case, we're going to make sure only the West OU gets synced to Azure. So here in my on-premises domain server where I've already got the Azure AD Connect agent installed, I can perform this reconfiguration. These are options that I could have specified initially when I installed and configured the Azure AD Connect agent, but you can change it at any time thereafter too. So I'm going to go ahead and open up the Azure AD Connect agent from the icon on my desktop. And then I'm going to click the Configure button. Here I can select the specific aspect of configuration that I want to change, such as customizing synchronization options. I'm going to select that and click Next. So I'm going to have to log in or authenticate to my Azure AD tenant with an account that has the global administrator role. Then I'll click Next. And here in the domain and OU filtering, it's currently syncing all domains and OUs. I'm going to turn on Sync Selected Domains and OUs, and I'll uncheck everything. And down below, I can select, for example, the West OU or East. In this case, I really only want West, so I'm going to uncheck East. I only want to synchronize user accounts in the West. In this case, the way that will happen is with password hash synchronization. So a hash of the on-prem password is what will be synchronized into the cloud. And only the users in that OU, the West OU, will show up in Azure AD. So I'm going to go ahead and click Next. And after a moment, the update is ready to be put in place, and the synchronization process will commence after the configuration is put in place. So I'll click the Configure button in the bottom right. And before you know it, the configuration is complete. So I'm going to go ahead and exit out of that. Now here in Azure AD, I'm looking at my All Users view, where I've got a collection of both Azure AD and Windows Server AD users. We've got Maria Martinez and Nikki Flores. Those are the users in the West OU from on-prem that are now showing up here in Azure AD. After you've configured Azure AD Connect, it's important to monitor its health over time to make sure that things are synchronizing correctly. Here in the Azure portal, I'm in my Azure AD tenant, and I've already gone to Azure AD Connect over on the left. On the right, I have some details about Azure AD Connect Sync, such as the fact that sync is enabled. I can see when the last sync occurred, in my case less than an hour ago, and the fact that password hash sync is enabled. In the top center bar, I'm going to go ahead and search for Azure AD Connect, and I'm going to choose Azure AD Connect Health. That opens up a new area here for Azure Active Directory Connect Health, where I can download the Azure AD Connect Health agent. I'm going to go ahead and click on that. That's designed to run on premises on your domain server for the on-premises domain that you've linked to Azure AD. So here I've downloaded it. I'm going to go ahead and right-click on the installer, and I'm going to choose Run as Administrator to run the install with elevated privileges. Now, after I've continued with that, I'll be prompted to sign in. It's fired up a PowerShell prompt in the background to run some commands. So I'm going to go ahead and sign in to Azure AD to let that continue installation. After it's completed, here in my services on my on-premises domain server, I will have a number of Azure AD Connect Health services that are up and running. That happens by default automatically when you install it. So now back here in the portal in the AD Connect Health, if I click on Sync Errors on the left, I'll get some sync errors by type shown over on the right. We don't have any synchronization errors, which is good. Otherwise, we'd have to troubleshoot further. If I click Sync Services on the left, I'll have the name of my Azure AD Active Directory domain tenant shown on the right, with no alerts and the status being shown as healthy. If I click on it to open up some details, it'll show me that I've got one DC on premises called DC1, and its current state is that it's healthy from the Azure AD Connect synchronization status viewpoint, that is. If I click ADDS Services over on the left, I can click and get some details on my on-premises domain as well. I can see when it was last updated, there are no alerts, and the status is that it's currently healthy. If I open that up, I'll see I've got one domain and one site on premises that I'm linking to here into Azure AD. There are no DCs with errors, there are 0 alerts, so we don't have any problems here, but you're not going to know this unless you have a way of monitoring the health and the synchronization status. Microsoft Azure AD Domain Services is not the same thing as Azure AD. Azure Domain Services for AD is a little bit more flexible. It allows you, for example, to work with organizational units and group policy and so on. It's still a managed service like Azure AD is. You don't have to worry about setting up the servers, but the great thing about it is that it gives you more flexibility than you would get with just simple Azure AD, which does not support things like group policy and organizational units. So to get started here in the portal, I'm going to click Create a resource. I'm going to search for domain service, and there's Azure AD Domain Services, so I'll select that. And then I'll click Create. I'll have to deploy this into a resource group, so I'll select one that I already have from the list. Down below, the DNS domain name here is for quick24x7test.onmicrosoft.com. That's my DNS domain name for my existing Azure AD tenant. However, I'm going to change that to quick24x7test.info. I've already configured a custom DNS domain name. Next thing I'm going to do is scroll down, and I'm going to leave a lot of these settings as they are. So it's going to be a user type of forest type, where there's going to be user accounts in Active Directory. That's going to be managed by another virtual machine that I join to Azure AD Domain Services. So I'm going to go ahead and click on Next. Here it wants me to specify or create a new virtual network and subnet. So I'm going to let it build a new VNet and subnet that will be used to host the underlying VMs for Azure AD Domain Services. But remember, this is a managed service. You won't have direct access to those underlying VMs. So I'll go ahead and click Next. On the Administration tab, we could change group membership for the Azure AD Domain Services group. I'll leave that. And on the synchronization page, I could synchronize all items, or I could choose scoped, and I could select certain groups from Azure AD that I want synced here into Azure AD Domain Services. So on Review and Create, it's currently running the validation. And once that passes, we'll be able to actually deploy our instance of Azure AD Domain Services by clicking Create. And I'll just click OK. After a few moments, the deployment is complete. So I'm going to click the Go to Resource button, which will take me into. So back here in my All Resources view here in Azure, here in the All Resources view, I'm going to filter by type. I'm going to deselect everything, and I'm going to choose only Azure AD Domain Services. So it's its own type of Azure resource, and maybe virtual networks too, because it made a VNet for it. And when I do that, I have a filtered list of only virtual networks and my Azure AD Domain Services item. So those two items are shown here in the All Resources view. So I'm going to click on my Azure AD Domain Services resource to open up its properties, its navigation bar. In the Overview blade, it says the domain is being provisioned and it might take a while. After a few minutes, the new Active Directory managed domain will have been provisioned, and we have a health listing here that states that it is up and running. Down below, under required configuration steps, we need to make sure we plug in these IP addresses for DNS servers into our VNet, because Active Directory requires pointing to a DNS server where there are service location records for domain controller servers. And so it's giving us the IPs here. So I'm going to go ahead and click on Configure to make that happen. In the upper right in our notification area, it has saved the virtual network setting. So it actually made that change for us. But let's go ahead and check this out. So I'm going to go back to the All Resources view and maybe filter it by type again. And maybe this time what I'll do is just filter it only for virtual networks, since that's what we really want to look at. We want to double check the DNS settings. So I'll open up the appropriate virtual network. In the navigation bar for it, I want to scroll down and go down to my DNS servers option. So I'll click DNS servers. And sure enough, on the right, we're not using the default Azure provided DNS, but instead 2 custom IP addresses for our Azure AD Domain Services managed instances. After you've deployed Azure AD Domain Services, you need a virtual machine to manage it. So I've got Azure AD Domain Services here in the portal that I've already configured for a domain called quick24x7test.info. So the next thing I'll do is click on the name of that domain services resource to open up its properties. If I go to the properties in the navigation bar on the right, the location is Canada East, and we have a virtual network and subnet that this was deployed into. That's important because when I deploy a virtual machine, it's got to be in that same VNet. That's because the VNet points to the DNS server IP addresses for my Active Directory domain services in the cloud. So I'm going to go back home and I'm going to choose Create a Resource here in the portal because I want to deploy a new virtual machine. I'll just choose Windows Server 2016 Data Center. That'll work just fine for what I want to do, which is join the domain and then be able to manage the domain using standard tools like Microsoft Active Directory users and computers. So I'm going to deploy this into a resource group. I'm going to call this virtual machine WinServe 2016-1. And the next thing I have to do is make sure I deploy this in the appropriate region where that VNet is for Azure AD Domain Services. In this particular case, that happens to be Canada East. And then I'll have to specify the username and password credentials for signing in to the Windows OS within the VM. Once I've done that, I'll click Next for disks. Not really going to make any changes to the disk subsystem. I'll click Next for networking. I need to make sure that this VM is being deployed into my Azure AD Domain Services VNet. So that is selected here. It's the only one in that region, that and the subnet. It's going to make a public IP for the VM. That's fine. Then I can manage directly from the internet. So I'm going to click Review and Create because I'm not going to change anything else about this VM deployment. Validation is passed, so I'll click Create in the bottom left to deploy this VM. After a moment, the deployment is complete. I'll click the Go to Resource button to open up the properties of that virtual machine. And the public IP address I will copy, shown over on the right, so I can remote into it using RDP. So I've got the public IP address in here, so I'll click Connect. I'll specify the appropriate credentials to sign into the OS. That's what I specify when I deployed the VM. I'll click OK. It'll ask me if I want to trust the identity. I'll just go ahead and say, don't ask me again. And then we will have RDP'd now into our server. Now, back here in the portal, I need to make sure I know the name of the domain I want to join, quick24x7test.info. So here in my virtual machine that I've deployed to manage Azure AD Domain Services, just going to go into the control panel, search for join, and then I'll choose join a domain in the system category. So I'm just joining a virtual machine to an Active Directory domain. So I'm just going to go ahead and click on domain and specify the domain name that we took note of a moment ago, quick24x7test.info. And then I'm going to go ahead and click OK. And I'll specify some credentials that will allow me to join this machine to the Azure AD Domain Services domain. After I've done that, it says welcome to the domain. That's great. So I'm going to go ahead and click OK. And I'm going to go through and just close out of here and restart now. Back here in the portal, in my Azure AD tenant, which is named Quick24x7, if I were to scroll down and look at custom domain names, that's where we'll see the name of the domain we just joined, quick24x7test.info. If I click on groups over on the left, we've got an AADDC administrators group that was built by Azure AD Domain Services. If I click to open up that group and look at the members, I've got a couple of users here. I've added Cody Blackwell and Lucas Brenner. These are Azure AD users that I already had created previously. So back here on my domain joined system that has now restarted, we're going to go ahead and start to administer our Azure AD Domain Services environment. Before we do that, we're going to need to add the tool. So I'm going to go into Server Manager. There are many ways to do this. And I'll click Add Roles and Features. I'll just proceed through the wizard by clicking Next, 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 until we get to Features, where I'm going to scroll all the way down and choose Remote Server Administration Tools, Role Administration Tools. I'm interested in Active Directory stuff, so I'll select the checkbox for ADDS and ADLDS tools, and I'll just continue through and install those, just like you would normally, even on premises. So now that I've done that, if I open up the Start menu on that same host and go down under Windows Administrative Tools, I'll see my AD tools. So I'm going to go into Active Directory Users and Computers. Now we are joined to the domain, so the domain shows up automatically in the Explorer navigation bar on the left. And we've got a number of entries that already exist for things like AADDC computers. I can see the computer that was joined. I can see the users. Now these are users that actually existed already previously in Azure AD. They were synchronized to my Azure AD Domain Services installation. So users and groups. So users like Cody Blackwell, Jen Hill, Marcia Lynn, Maria Martinez, and so on. So if we go back into our Azure AD tenant here in the portal to check that out in the All Users view, indeed, those are the user accounts that show up here in Azure AD that were synced to Azure AD Domain Services. In the same way, if I go to groups, even groups like the Group 1 Off 365 group and Team 1, they show up also within the domain. If we go to the Domain Controllers organizational unit on the left, we'll see that Microsoft Azure on the right has deployed 2 virtual machine domain controllers for us. We don't have direct access to them, but that's part of why this is a managed service. We don't have to worry about setting up the VMs ourselves. You can define Azure Files within a storage account, where really Azure Files is just a shared folder hosted in the storage account within the Azure cloud. But then you can also link it to your Azure AD Domain Services instance so you can set file-level permissions to files and directories in that shared folder. So here in my storage account, if I were to scroll down and click on the configuration item on the left, so I can see my configuration settings for the storage account, one thing that's of interest for us on the right, if we scroll down just a little bit, is linking the storage account to Azure AD Domain Services. So identity-based access for file shares, which is disabled by default, by the way. So what we want to do is make sure that we enable that. Now, this is not Azure AD. We're talking about Azure Active Directory Domain Services, which is different. So we want to make sure that we enable this. So there's an enable switch that we can just click here to make that happen. So I'm going to go ahead and click on Enabled and Save. Now, if we don't have an Azure AD Domain Services deployment, it won't work. But this worked fine. It saved that configuration setting. So now I'm going to click on Access Control IAM on the left because there are some roles that are specific to working with shared folder content or Azure Files SMB shared folder content. So on the right, I've clicked Add Role Assignment, and in the role drop-down list, I'm just going to filter it so we can see what's relevant here. So we'll just scroll down maybe. In the S's, we'll see Storage File Data SMB Share Contributor to add items to a share. We've also got some other roles related to that, besides just allowing for reading, writing, and deleting in Azure Storage File Shares. We've also got some reader options to provide read-only access, and so on. So these roles then are specific to Azure Files within an Azure storage account. So I'm going to choose the Storage File Data SMB Shared Elevated Contributor. So this allows setting permissions as well as working with the content within the shared folder in the cloud. And down below, I can then select users that I want to have that. So I've selected Cody Blackwell. He will have that role. So we can check on the role assignment here for Cody to make sure it applies to this storage account. So on the right, I'll click on Role Assignments. Once that updates, I'll just kind of scroll over a bit here to the right and then down so we can view all the entries. And sure enough, for Storage File Data SMB Share Elevated Contributor, Cody Blackwell is listed. So he's got that privilege for the storage account and any shared folders within it. So I'm going to flip over to the All Resources view, and I'm going to filter it by type. I'm going to deselect everything. Just going to turn on Azure AD Domain Services. There is our Azure AD domain, quick24x7 test.info, that we have linked to for setting permissions. So any users and groups available there, we can assign permissions to at the file system level. So back in my storage account, I'm just going to scroll all the way down to File Shares just to see what we've got here. So we've already got one defined in this storage account. It's called Budgets. If I open that up, there's some sample content here. We've got a future folder and a couple of project budget files. So we've got some content is the point. If I go to Properties on the left, this is the URL that we can use to make a connection from a computer, essentially to map a connection to this shared folder in the cloud. So we're talking specifically about budgets within the storage account. So on a virtual machine joined to that Azure AD Domain Services domain, we have a connection to the quick24x7 test.info domain. So this is how I can manage and work with user accounts and so on here that we might want to assign permissions to. So let's go into the file system on this host, where in the address bar in Windows Explorer, I've already put in the path, /UNC path, to the storage account and ultimately to the budget's shared folder. Now, down below, we can see the contents of that Azure Files shared folder, the project budget files, the future sample folder, and so on. I'm going to right-click on something in here to set permissions. I'm going to right-click and choose Properties, go to Security, just like you would normally to set NTFS permissions. I'll click Edit, and I'll click Add to add a new entry. Now, I'm adding an entry from Azure AD Domain Services. So I can browse through that and select users, groups, and so on. So our domain is shown up above underneath from this location. I'm going to click Advanced at the bottom and Find Now on the right. So within our domain, down at the bottom, we have a listing of all of the Active Directory entities, the service principals that we can use here. So I'm going to scroll all the way down. Notice, for example, we've got a user, let's say Jen Hill, that we want to assign permissions to here at the file system level. So I'm going to select Jen Hill and click OK. So at this point, we can set specific permissions for user Jen Hill that would apply to the shared folder stored within the storage account. Azure AD supports fraud alerts. This is designed so that when we have multi-factor authentication users that would receive, for example, a phone call as part of the two-step verification, if that wasn't initiated by the user trying to sign in, then it's probably someone trying to sign into their account. And that's when fraud alerts kick in. What would happen is if the user, say, got a phone call as part of that MFA two-step verification, if they want to report that as being a fraudulent attempt to sign in, they could type in 0. 0 is the default code they would enter in to report fraud, followed by a hashtag. You can change that code, but that's what it is unless you change it otherwise. However, Azure AD fraud alerts are not turned on by default. So let's take a look at where to do that here in the portal. So first things first, I need to navigate to my Azure AD tenant, and in the navigation bar, I need to scroll down and choose Security. Within that, I then need to click MFA for multi-factor authentication on the left. That will then allow me to click Fraud Alert in the left-hand navigator. And this is where I just have a couple of options. So the first is allow users to submit fraud alerts. It's off. So I'm going to go ahead and turn that on. Now, when I do that, the option below it becomes available to automatically block users who report fraud. So I can turn that off, but I can turn that on so the account is temporarily locked until we figure out what's happening. And the default code to report fraud is 0 down at the bottom, but we could change that to be something different if we wanted to. I'm going to leave that as a default, and to save these Azure AD fraud alert settings, I'm going to go ahead and click Save. And that's it. It is now in effect. Azure AD Conditional Access allows you to configure policies to control access to resources, such as apps. And that could be dependent on whether users are signing in with multi-factor authentication, or if they have a device joined to Azure AD, which type of device it is, many different possibilities. So to get started with this, I'm going to navigate here in the portal to my Azure AD tenant. I want to configure a conditional access policy. Within Azure AD, in the navigation bar on the left, I'm going to scroll all the way down to Security. And within that, I'm then going to click Conditional Access over on the left. That puts me in the conditional access area where in the left-hand navigator, Policies is automatically selected. And any policies that might exist already are shown on the right. So I'm going to go ahead and click the New Policy button up at the top. So the first thing I'm going to do is allow Sample 1 app access. That's what I'm going to call this. I want to allow access to an enterprise app that I've registered with Azure AD, and that app's called Sample App 1, actually, not Sample 1 app. So let me just change that name. There we go. Now the assignment can be for users or groups in Azure AD. So I'm going to go ahead and click on that to make a selection. It could be none, which is the default, all users, or selected users, and groups. I can also add exclusions. So for example, if I want this available to all users in Azure AD, I could choose all users. Now down below, I can click on Cloud Apps or Actions. So I'm going to select specific cloud apps. Now from here, I can click select and start browsing through Azure AD apps. So if I filter, let's say for sample, there's the one I was talking about, Sample App 1, which I'll select, and I'll click the select button at the bottom. So I want to allow access to Sample App 1 potentially for everyone in Azure AD, but we haven't specified the conditions yet. So let's do that on the left. I'm going to go ahead and click on conditions, and there are many different types of conditions we can specify, one of which is device platforms. I'm going to click on device platforms, and I'm going to choose yes for configure, and I'm going to choose select device platforms, and let's say I only want to allow it for the Windows platform, so people that might have joined their Windows laptops or desktops, for example, to the Azure AD tenant. And I'm going to go ahead and click on done. I just as well could have selected, if I go back in there, instead Android or iOS, Windows Phone, Mac OS, any combination thereof. I'll leave it on what I've got there for one device platform. So we can go ahead and do that. I'm going to scroll down for access controls under grant. Over on the right, I'm going to require multi-factor authentication. So I'll click select. And the enable policy option down below is set to report only mode, which is kind of like an audit mode, so you can track what might happen. I actually want this policy to be effective, so I'm going to go ahead and turn it on. We can also turn it off. And I'm going to click save. So after a moment, we've got a new policy shown in the list called Allow Sample App 1 Access. It will apply to all users in Azure AD and allow them access to that app if they are using a Windows device and signing in using multi-factor authentication. In this demonstration, I'm going to enable MFA, or multi-factor authentication, for an Azure AD user. Now this will enhance sign-in security so that instead of having knowledge of just a username and a password, in addition to that, an additional factor is going to be required to sign in, such as a call made to a phone that the user must answer, or it could be a text message. Either way, it would be a unique code that has to be entered through that device to enable the user to sign in successfully. So to get this done here in the portal, to enable MFA, I'm going to start by navigating into my Azure AD tenant, and I'm going to go into my users. Then I'm going to click the multi-factor authentication button up at the top. Now that opens up a new web browser window where I will see the current status of multi-factor authentication. Now for all of my Azure AD users, it's currently disabled, but we can go ahead and turn it on for any of these users. So as an example, I'm going to turn on multi-factor authentication for user Cody Blackwell. Turn on the check mark for that account, and then over on the right under Quick Steps, I'll choose Enable. Then I'll click Enable Multi-Factor Auth, and then it says the update was successful. I'll close. So for user Cody Blackwell, the multi-factor authentication status is now showing as enabled. Once Cody Blackwell signs in the next time, and after his account is set up for MFA, instead of enabled, it will say enforced. We're going to go ahead and check that. But first, let's sign in as user Cody Blackwell. So I'm connecting to myapps.microsoft.com to test this out, and I'm going to sign in with the user principal name, or the UPN, for user C. Blackwell from my Azure AD tenant. I'll click Next, and then of course I'll enter the password. Now after I sign in successfully with the correct username and password, I get this message about more information required. That was triggered by the fact that MFA is now enabled for this user account. So I'm going to go ahead and click Next. So we have to specify how we can be contacted, whether it's an authentication phone, an office phone, or a mobile app. So for example, I'll leave it on authentication phone, and I'm going to go ahead and I'm going to specify a country, and then I will enter in the phone number. I can either have it call and provide a unique code, or send me a code by text message, which I will choose here. So after I've specified that information, I'll go ahead and click Next. And it will have sent a text message to the phone number that I specified. So I'm just going to go ahead and check my text messages, and I'm going to enter in that code. In my case, it's 752464. Then I'll click the Verify button. Then we're in. So now I'm going to click Done. And I'm not going to stay signed in. I'll just choose No. But it's going to take me to the My Apps or myapplications.microsoft.com web page. Now let's just try sign in again to see what happens now that MFA has been set up for Cody Blackwell. So in the upper right, I'm going to click on the user icon and I'm going to sign out. And then we're just going to go ahead and sign right back in as that same user. I still have to specify the password for the account. That doesn't go away just because you've enabled MFA. So as long as you have a valid username and password, it'll then send another code to the phone number. After a moment, I will receive that code. So I'm going to go ahead and enter it in here. And I'll click verify. And I'm not going to stay signed in, and it will sign me in. So I've now performed an MFA sign-in for user Cody Blackwell. Now back here where I was in the portal looking at the multi-factor authentication, the next time I go in and check that out for user Cody Blackwell, it will have changed from enabled to enforced. Besides specifying things like passwords for Azure AD users and enabling multi-factor authentication or MFA, there are some additional Azure AD authentication details you can specify related to things like the location that a user is authenticating from in terms of an IP address range or a specific country, but also the fact that you might want to bypass things like MFA if the user is coming in from a trusted location, let's say through a VPN. So to go ahead and enable this type of authentication detail, we need here in the portal to first navigate to our Azure AD tenant. As you might imagine, in the properties bar for the Azure AD tenant, I need to go down to security. We're talking about security options. Then I'm going to go into conditional access. On the left, I'm then going to click named locations. You can create one or more named locations. So I'm going to click the new location button at the top. Let's say, for example, HQ for headquarters. It can either be an IP address range insider format, so there's an IP range field below we can populate. We can also specify countries or regions. And from the drop-down list, for instance, I might choose Canada or other countries, any variation on that. We've also got the include unknown areas option. If we turn that check mark on, it's for any IP address ranges that can't be mapped to a geographical location. So I'm going to leave that as it is. I'm not going to turn that on. I'm going to click create. So you can create multiple named locations. At the same time, you can also click configure MFA trusted IPs at the top. So as an example, we might say skip multi-factor authentication for requests from federated users on my intranet, so internally, or we could specify down below some MFA bypass IP address trust lists. So for example, I might specify a location from where we might start getting requests that we want to trust. In other words, we don't want to require MFA from these locations. And maybe that's an IP address range that is only available when coming through an authenticated VPN tunnel. So at the bottom, I can then click the Save button to save any of these settings. Now we had also, let's just close out that MFA screen, we had also just configured a new location called HQ. You might wonder, well, how does that play in? Where do you use that? You use that type of thing with conditional access policies. So I'm going to click security in my breadcrumb trail up at the top, and I'm going to click conditional access. Now, we've got some existing policies. You could build a new one with the new policy button at the top. However, I'm going to go down into an existing one. It's called Allow Sample App 1 Access. So it must allow access to a sample app. I'm going to click to open up that existing conditional access policy. So what we can do then is start specifying conditions. If I click conditions on the left, one of the options that show up on the right are locations. And if I take a look at that, I'll just scroll up here. I'm going to configure it, so I'll choose yes. And I'm going to choose selected locations. And then from the selected location list, we've either got our MFA trusted IPs that we just configured or our HQ or headquarters location. So I can select that, choose select. And what we're doing here is adding a condition to an existing policy which applies to all users in Azure AD to allow access to an app. So they have to be coming in from the HQ location, and then access is granted to use an application. I'm going to go ahead and save that change. So that's how you might use some of those additional details for controlling how users are authenticated, in this case from where, to give them access to an app through a conditional access policy. Another option that can help with hardening your Azure AD environment is a banned password list. Like the name implies, it's a list of passwords that users cannot use. The great thing about it is you don't have to put in every possible variation of a password. If you type it in lowercase letters and you use letter O's instead of zeros, it doesn't matter because all the variations on that password will automatically be accounted for. So let's see how this works. Here in the portal, I'm going to start by going to Azure Active Directory. As you might guess, the next thing I would do is scroll down in the navigation bar for my tenant and click Security. Next thing I want to do is go into Authentication Methods, click on that on the left, and finally on the left, I'll click Password Protection. So in the middle of the screen, the panel on the right, the Enforce Custom List option for banned passwords is set to No. I'm going to choose Yes. And from here, I can then specify any banned passwords. So for example, I have ABC123, lowercase letters. Well, even uppercase or mixed case variations of that will automatically be banned. Now, the mode down below is currently set to Audit, where you could basically trace the fact that it logs any attempts to use these passwords, but it won't stop it. Well, if you want it enforced, you'd have to turn on Enforced, which I will do down at the bottom, and then I'm going to go ahead and click on Save. So at this point, any variation on the passwords in our custom banned password list will not be allowed if users try to change their passwords to any of those values. So here in my browser, I've signed into the myapps.microsoft.com website as user Cody Blackwell. We might also be logged into something else related to Azure AD, such as portal.azure.com. So it really doesn't matter, but in this case, I'm going to try to reset the password for Cody. So I'm going to click on Cody's name in the upper right. I'm going to choose Profile, and I'm going to choose Change Password. So naturally, the first thing I'll have to do is specify the old password. I want to change the new password to this variation of the text, "My dog has fleas." Now, we just entered in the raw text and lowercase letters in our configuration in Azure AD for "My dog has fleas," but we said it will look at all variations, and it will. So it should prevent us from using this. I'm going to go ahead and copy that password, and we're going to go ahead and try to use that to reset it. So I've pasted in that variation on that password here in the Create New Password and Confirm New Password fields. It says it's a strong password, which indeed it is, but when I click Submit, it should say that it's not allowed, and it does. It says, unfortunately, you can't use that password because it contains words, characters that have been blocked by your administrator. Please try again with a different password. So the result is that our custom banned password list is working. One great way to harden user sign-in security for Azure AD is to require MFA or multi-factor authentication. And we can do this as part of our Azure AD identity protection by enforcing an MFA registration policy. So to get started here, I'm going to go to Azure Active Directory in the portal. And naturally, in the navigation bar, we're going to go down under Security because this is a security thing, Identity Protection. And I'm going to click Identity Protection in the left-hand navigator. What I'm interested in specifically is the MFA or multi-factor authentication registration policy. So I'm going to click that over on the left. Now we have to determine which users this should apply to. So I can click on the user assignment section to control that. So I can click on that and I can leave it on all users, or I could select individuals and groups from Azure AD. So for example, we might only want to require an MFA registration policy for administrative accounts that are essentially powerful accounts. However, generally speaking, it's a good idea to enforce an MFA registration policy for all users when possible. We can also add exclusions. If we add all users, we can go to exclude and exclude individuals that we might not want to have that put in effect for. However, I just want to include all users. I'll click on Done. Then for controls, we are requiring Azure MFA registration. That's the only option there. So I'm going to go ahead and click Select. The other thing to watch out for is whether the policy is enforced or not. So we can turn policy enforcement on and then click Save. In Microsoft Azure, besides Azure AD users and groups, we have this notion of service principals as well as of managed identities. The real difference is that a service principal is like a dummy user account that you would create in Azure AD that requires access to resources. Could be a piece of code that requires access to resources. The difference is that you, as the Azure technician, control Azure AD service principals, but Azure AD handles managed identities automatically. That's why they're called managed identities. You do have some indirect control though. As an example, we're going to deploy a new virtual machine. So here in the portal, I'm going to click Create a Resource, and I'm going to select a virtual machine. Now, we're not actually going to deploy it, but there's a certain point in the wizard that I want to get to when it comes to managed identities. Now, let's imagine that we're going to be running some custom code in this virtual machine that is going to require specialized permissions to other Azure resources. Well, when you're working with a virtual machine, if we were to jump ahead, let's say, to the Management tab up at the top, this is where one of the options that we get to specify is whether a managed identity will be created. So down under Identity, we've got this option called System Assigned Managed Identity. I then can have the option of turning that on. Now we can also configure managed identities for resources after the fact. For example, here I've gone into an existing virtual machine, and I'm going to scroll down in the navigation bar and select Identity. Now, in the right-hand panel, we then have two options, system-assigned identities versus user-assigned. A system-assigned identity is tied to this resource, in this case, to this specific virtual machine, where a user-assigned managed identity is not. And so you could use it across multiple resources, and you have an Add button to add one here. So I'm going to use system-assigned here. So this is where we could turn that on or off. So I'm going to turn it on and save the change. I get a message to the fact that my virtual machine name will be registered with Azure AD and then granted permissions to resources. So that's fine, or it could be potentially granted permissions to resources. I'm going to choose yes. Once that's done, down below, we are given the object ID for the new managed identity, and we can go down under permissions and click Azure Role Permissions down at the bottom. Now, this is used for you to essentially check on this managed identity, in this case within this virtual machine, to see if there are any role assignments. There currently aren't. But let's say that we're going to have code in here, and we don't want to write the credentials into the code. That's why we're doing what we're doing. That's why we're using a managed identity. It will have access to resources once we grant that access. How do you do that? That's done through Role-Based Access Control, or RBAC. As an example, let's say we want to navigate to our storage accounts because we want the code running in our virtual machine to have access to a storage account. So I'll open up an existing storage account. In the navigator of that storage account, left-hand navigator, I'm going to choose Access Control IAM. That's where you work with role assignments. So I'm going to click the Add button over on the right and choose Add Role Assignment. Now, instead of assigning access to an Azure AD user, group, or service principal, I can open that list. I could choose user-assigned managed identity, but that's not what we've done here. For system-assigned managed identities, we then have a classification of resource types in Azure, like app services for web apps, function apps, logic apps, and so on, including virtual machine, which is what we want. Because when I select virtual machine, I can then choose the virtual machine where we've enabled a managed identity. So I'm going to select that VM. Then I'm going to choose a role. So what kind of a role do we want to assign? So I'll just type in STOR for storage. Let's say storage account contributor. That's what's required by the code running in the VM. Then I'll click Save to save that assignment. Now, if we click on Role Assignments on the right for this storage account, we're going to see, if we scroll down far enough, for storage account contributor, that our managed identity, which is really tied to our virtual machine, so our code running in the VM, has permissions to contribute to this particular storage account. So that's how managed identities are used in an Azure environment. Azure resource groups, like the name implies, are used to organize resources together in one manageable unit. So for example, if you know you're going to be testing out a custom application, you might want to deploy all of the resources that support that application, like a virtual machine, a storage account, a load balancer, an app service, and so on. You might deploy all of those resources into the same resource group. Then you can manage them as one unit. For example, if you go to delete the resource group, you'll be deleting all of the resources within it. And that might be useful when you need just a temporary sandbox dev testing environment. So to get started here in the portal, I'm going to create a resource group by choosing Create a Resource. And I'm going to search for Resource Group, and I'll select that from the list, then I'll choose Create. So I'm going to call this one East RG1, so East Resource Group 1, and let's say for the region, I'm going to specify that I want that stored in Canada Central. Then I'll click Next for tagging. I'm not going to add tag names and values. I'll click Next, Review, and Create. We can see the validation has passed up at the top, so I'm just going to go ahead and click Create to create the resource group. Now in our notification bell icon in the upper right, if I click on it, we'll see that the resource group was created, and we can choose the Go to Resource Group button. Of course, I could also open my navigator on the left-hand side of the screen, and from there, select Resource Groups. Either way, I can now see that I've got a resource group, I'll just have to click Refresh, called East RG1. And if I click on it, in the overview blade for that resource group, I'll see things over on the right that are deployed into the resource group. Now, we don't have anything deployed into the resource group, so over on the right, there's a message stating that there are no resources to display. So at this point, when we go to deploy new resources in Azure, for example, let's say I go home, so I clicked home in the upper left, I clicked Create a Resource. Let's say that I wanted to deploy a virtual machine. I'll just choose Windows Server 2016 Data Center under Popular. It doesn't matter, I'm not actually going to deploy it. But the point is that when we deploy future Azure resources, we can deploy them into a resource group of our choosing. So we just want to make sure our resource group does show up in the list. So in the basics page of creating a virtual machine, we've got a drop-down list where we can select the resource group that we want to deploy the resource into. Within your Microsoft Azure account, you can create one or more Azure AD tenants. Think of this as being similar to having multiple Active Directory domains on premises. It is a directory service. Well, what we have here is the fact that a single Azure AD tenant can contain one or more subscriptions. Now, the subscription is kind of a billing boundary. In other words, billing occurs at the subscription level. And you need a subscription if you even want to deploy resources at all in the Azure environment. There are many different subscription types that you can select from, such as a pay-as-you-go subscription, whereby you are charged based on your monthly usage. You can get professional direct support. You can get developer support. Now, this would be a subscription type, for example, that would allow support, but only during business hours, as opposed to professional direct support types of subscriptions. You can also get standard support types of subscriptions. Of course, initially when you sign up for an Azure account, you can also sign up for a free trial subscription, so 12 months free, as well as a 30-day $260 credit to use against the services that you explore in your Azure environment. So the next thing that falls into suit is Azure management groups. The purpose of a management group is to organize multiple subscriptions. Talked about the fact that you can have multiple subscriptions and they can be tied even to a single Azure AD tenant. So the purpose here is policy assignment for compliance, so proper governance. Because what we can do is use Azure policy maybe to enforce something, such as a default tag to be applied for newly created resources, or maybe we're using Azure policy for something completely different. We just want to check to see which virtual machine disks are encrypted or not. So it's for compliance purposes. Regardless of the specific situation, the purpose of management groups is that it allows you to assign policies to a management group which flows down to all of the subscriptions that you might have moved under that management group. So it's for larger enterprises that would have multiple subscriptions. So the management group hierarchy looks kind of like this. You've got the root management group up at the top, under which you can create one or more management groups and name them appropriately. And within each of those management groups, you can then move your Azure subscriptions around. And again, if I were to assign a policy in this example, let's say to management group 1, the policy would apply for that level down. So it would apply to subscriptions 1 and 2 according to our diagram. So if we look at the flow, it starts with adding subscriptions to your Azure AD tenants, then creating a management group. Subscriptions then get moved under the appropriate management group, and then you apply governance options to the management group, which means assigning policies. Microsoft Azure management groups are used for enterprises that have multiple Azure subscriptions, in that you can organize subscriptions under management groups to facilitate the application of Azure policy. That's what it's for. So when you want to work with management groups in the portal, you start by searching for management, and eventually you'll see management groups pop up. You can click there to open it up. You've got the default tenant root group, under which you will see any subscriptions. I've currently got one, pay as you go. But what I would like to do is add a management group. Now, realistically, if you have a single subscription, there's no benefit, but we're going to step through the motions anyhow, so that if you do have to organize multiple subscriptions into management groups, you'll know how to do it. So I'm going to click the Add Management Group button, and I'm going to create a new one called MG1, Management Group 1. I'll put the same thing in for the management group display name, and I'm going to choose Save. So after a moment, our newly created management group will show up in the list. We do have a refresh button here that we could click on also as we're waiting for it to appear. And after a moment, our management group, in this case MG1, will show up in the list. The next thing you would do, you could build multiple management groups, but the next thing we would do is start moving subscriptions into the appropriate management groups. We will have planned how that makes sense, where we want to apply Azure policies that will affect the subscriptions within the management group. So I've got a pay-as-you-go subscription. So over on the far right, I'm going to click the context menu and choose Move. And in the new parent management group drop-down list, I'll choose the new management group MG1, and I'll choose Save. That'll take a moment. And again, you can go ahead and click Refresh. After you do that, the subscription will no longer be seen in the tenant root group, but if I click to open up my management group, MG1, the subscription now shows up at this level. Now, I'm going to click the Details link right next to the name of my management group, MG1, because within here, if I go to Policies, it'll take us into the Policies Compliance type of view, where we can click the Assign Policy up at the top to assign a policy at this level. When I say this level, I'm talking about at the Management Group 1 or MG1 scope. Now, you don't have to do it that way when it comes to assigning policies. So, for example, let's just search for policy here in the top center bar to go into Azure Policy, and I'm going to click Assignments over on the left. Any assignments that we currently already have will be shown here. This is the same type of screen. We can do it from here. We don't have to do it by first going through the management group. So if I were to click the Assign Policy button up at the top, we've got the same options where we can specify the scope, which could be the management group, which means any policies we assign in this config, in this assignment, will apply to all the subscriptions under the MG1 management group. So optionally, we could choose a subscription, but in this case, we would go to the Policy Definition Selector button on the right and choose whatever policy we want to apply, such as auditing virtual machines that don't have disaster recovery configured. Select, so that will apply to all the subscriptions under MG1. So that then is the purpose of configuring management groups in Azure. So in this course, we've examined the management of Azure AD security, including how to work with Azure AD Connect, domain services, Azure Files, and MFA. We did this by exploring the benefits of Azure AD Connect and how to create a custom DNS domain name for Azure AD, how to install and configure Azure AD Connect and view Azure AD Connect health statistics. We explored how to deploy managed Active Directory domain services and how to join an Azure VM to Azure AD domain services and configure share permissions for Azure files. And we looked at how to enable Azure AD fraud alerts. We then explored how to configure Azure AD conditional access and MFA for Azure AD users, as well as looking at ways to limit Azure AD authentication. We explored the use of banned password lists and how to enable Azure AD identity protection for user accounts. We explored how to configure an Azure AD managed identity, how to create and manage Azure resource groups, and finally, we explored the use of management groups and how to use the portal to work with the management group. In our next course, we'll move on to explore a number of Azure AD security mechanisms used to limit access to Azure resources, including role-based access control or RBAC, policies, and Azure blueprints. Role-based access control, or RBAC, is an important way to control resource access in Azure. One way you can use RBAC is to delegate access control. For example, if you've got assistant Azure administrators in another location, you might want to give them the ability to manage, let's say, just virtual machines in that location, such as those deployed in a resource group. And so you could control that type of thing with role-based access control. Now, a role is a collection of permissions that are related, such as to manage a virtual machine. And there are built-in roles, but you can also build your own custom roles that you will assign. Now, some examples of built-in roles, and there are plenty more than just this list, include owner. Now, the owner role is kind of generic. It provides full resource management control, whereas the contributor built-in role gives full resource control other than granting RBAC access, which you can do if you're the owner. Reader, of course, means read-only access to a resource. The CDN endpoint reader is specific to content delivery networks. It allows only the ability to read Content Distribution Network or CDN endpoints. The cost management contributor allows for the reading and writing of Azure cost configuration items, including budgets, and the virtual machine administrator login, as the name implies, allows the ability to read VMs, log in with admin credentials, but not fully manage it otherwise. So there are plenty of built-in RBAC roles that you should become familiar with so that you know what is possible. Otherwise, you could build custom roles. So speaking of custom RBAC roles, this is done in a text file. You define the role in a file using JSON syntax. Then you use that file to create the role. And you could do that from PowerShell using new-az role definition, or you could use the CLI. You could use AZ role definition create. Naturally, you would have to point to your custom RBAC role file, whether it's across the network or whether it's stored in the file system. So here's an example of what a custom RBAC role file would look like. So the name of this role at the top is custom VM role. 3 lines down, we have the isCustom attribute set to true. And a few lines below that, we've got actions, which defines what's allowed to be done with this role when it's been assigned. And we have the ability here to read storage, network, and compute items, and also start and restart virtual machines. So you can assign roles to users in Azure AD or groups, service principals, and managed identities. A service principal you can think of as being a dummy user account that exists only so you can assign permissions to software or code that requires resource access. A managed identity is a little bit different because it's managed by Azure. And as an example, it might be tied to a specific virtual machine so that you don't have to put the credentials within your code running in the VM to access resources. Instead, the permissions are granted through the managed identity associated with that virtual machine. Then there are assignment scopes where you can determine where these privileges can be exercised. You can assign RBAC roles at the subscription level, which means it flows down to everything in the subscription, like resource groups and resources within resource groups. If you were to assign an RBAC role at the resource group level, it would only apply to the resources in that resource group. If you want to, you can get very granular and assign an RBAC role to an individual resource as well. So RBAC role assignments then get inherited from above. In this example, what we have is we have a resource group called RG1 whose properties we are looking at. So this is a resource group. On the left, access control, or IAM, has been selected. That's where you set RBAC role permissions. On the right, we are viewing the assigned RBAC roles. And we've got one for network contributor, and it's for a group called Central Region Canada, and it's been assigned at this resource. We see that over on the far right. However, the next role assignment down below for the owner role was assigned to a group called Azure Admins. And over to the far right, it says it was inherited at the subscription level and has flowed down here to this particular resource group. So RBAC role assignments then can be inherited. So when you're planning how you're going to deploy this, think about your subscription or subscriptions and the resource groups within them. This might even be a driving factor for you to deploy a new resource group with specific resources in it for RBAC role assignment reasons. You can manage RBAC role assignments using the Azure portal. To get started here in the portal, in the top center search field, I'm going to search for sub and I'm going to choose subscriptions because I want to start by assigning an RBAC role at the subscription level, which will flow down to resource groups and resources. So I'm going to click to open up my subscription, and I'm going to click the Access Control IAM item on the left. Whenever you're working within the properties of an Azure resource and you want to set RBAC roles or view the role assignments, you click on Access Control IAM on the left. So on the right, I'm going to click the Add button and choose Add Role Assignment. The first thing I have to do is determine the role I want to assign. Now remember, a role is a collection of related permissions, such as for storage account management or virtual machine management or content delivery, network endpoint reading, anything. So I'm going to open up the list of roles. Now when I open up the list of roles, I can also filter it out. So for example, if I type in virtual, then I have nothing but virtual machine related types of roles. For example, the virtual machine contributor role allows the creation and management of virtual machines. I'm going to select that role, and down below I have to determine what I will assign it to. So an Azure AD user, a group, or a service principal. Service principal is like a dummy user account that you use to assign permissions that is going to be used by software or custom code. We can also open that list and choose different types of managed identities, where a managed identity, like the name implies, is managed by Azure, and it can either be a user-assigned managed identity that can be used among many resources, like multiple VMs, for example, or it could be a system-assigned managed identity tied to a certain class of resource, like an app service, container instance, function app, logic app, virtual machine, and so on. So here, I'm just going to assign this to a user. So I've got a specific user, Cody Blackwell, that I need him to have the ability to manage virtual machines throughout the subscription. So I'm going to add that user, and I'll click Save. After I've done that, it's done. So if I click Role Assignments, over on the right, I can scroll over and take a look at what's been assigned at this level. User Cody Blackwell is listed as having the virtual machine contributor role, and that assignment was made at this resource, which means at the subscription level. Let's examine that now at subordinate levels within the subscription, meaning let's start by looking at a resource group. So in the left-hand navigator, I'm going to select resource groups. I'm going to choose an existing resource group here called East RG1. To look at the RBAC assignments, we know that we have to go to Access Control IAM on the left. Let's go ahead and do that. What we should expect to see is the assignment that we just made at the subscription level will show up here as being inherited. We can verify this by clicking Role Assignments over on the right, and I'll just scroll down a little bit, and sure enough, there's Cody Blackwell with the virtual machine contributor role, but it was inherited from the subscription level, but it is applicable at this resource group. Let's take a look at a resource within a resource group. So for example, why don't we take a look at, let's say, it could be any type of resource. How about a virtual machine? So I'm going to go to my virtual machines view, open up an existing virtual machines properties. Same old thing, I'm going to click Access Control IAM on the left, where I can either manage or view role assignments. I just want to view them. So on the right, I'm going to click Role Assignments. And if we take a look, Sure enough, once again, there's Cody Blackwell with the virtual machine contributor role that was inherited from the subscription level, but it applies at this individual resource level. So you don't have to assign RBAC roles to the subscription. You could assign it specifically at the resource group level or here at an individual resource level, and you do it in the exact same manner as we've seen. You would click the Add button and choose Add Role Assignment. In this demonstration, I'm going to use the Azure CLI to set an RBAC role assignment. So I've launched the Cloud Shell here using the Cloud Shell icon at the top in the bar of the Azure portal. And within here, I can use PowerShell commandlets as well as CLI commands. So to get started with the role assignment, I'm going to use the AZ role assignment create syntax. Then I'll specify -- role, and the name of the role I want to assign here is SQL DB contributor. I have to know the name of that role. I'll then use -- assign E, and I'll specify the user principal name for an existing Azure AD user, in this case, user J. Hill. Next thing I have to do is determine the scope where this assignment should take place. I do that with -- resource - group in this case because I'm assigning this to a resource group named RG1. So let's go ahead and press Enter to assign that role to that user to that resource group. We're going to get some JSON text back, which implies that the assignment was successful, but we can verify that further here in the CLI. So to do that, I'm going to use the following syntax: AZ role assignment list -- resource - group in this case, because that's where the assignment was made, and it's called RG1. If I press Enter, I'll then get a listing of any assignments that were made at that level for resource group 1. And indeed, we're going to see the principal name for user J. Hill. And the resource group, of course, is RG1, and the role that was assigned is the SQL DB contributor. Let's take a look at the same thing in the portal. I'm going to minimize Cloud Shell, and I'm going to navigate on the left-hand side of the screen to my resource groups. We are interested in resource group RG1, so I'm going to click to open that up. And to check the assignments, I'm going to click Access Control IM on the left. And finally on the right, I'll click Role Assignments. Just scroll over and then scroll down. And indeed, we have user Jen Hill being shown here with the SQL DB contributor role that was assigned at this resource. This resource meaning RG1. But let's go back into the CLI for a moment, because the next thing that I actually want to do is delete the role assignment. You can also do that from the CLI. You completely manage all aspects of it. To do that, I'm going to run AZ role assignment delete -- assignee. Well, I want to remove Jen Hill's permissions, let's say, after a period of time. -- role is going to be the SQL DB contributor role. -- resource - group, because that's where the assignment was made, is going to be RG1. Let's go ahead and press Enter, and it will remove her from having that role in that resource group. We can verify that here by using the up arrow key to go back up through our commands to where we had AZ role assignment list. If I run that, this time user Jen Hill is not shown. There are many ways that you can manage RBAC role assignments, including using the portal, the CLI, and our current focus, PowerShell. So I've launched Cloud Shell within the portal here to work with this. To create a new assignment, I'm going to use the new -AZ role assignment commandlet. I'll use -signin name to specify the user principal name or UPN for an individual Azure AD user account, in this case user J. Hill, Jen Hill. Then I'll specify the role with -role definition name. It's going to be the SQL DB contributor role, and I want that applied only to a specific resource group as opposed to the entire subscription. So I'll specify -resource group name, and in this case, RG1. I'm going to go ahead and press Enter to complete that role assignment. Now we can verify that that took by using a different commandlet. So we can use the get -AZ role assignment commandlet. -resource group name in this case is RG1, because that's where we want to check for the role assignment. -signin name, I'll specify the user principal name for Jen Hill, and I'll press Enter. So it's returning back that user J. Hill has SQL DB contributor, and in this case, it's for our specific resource group, RG1. We can also check this out within the Azure portal. So I'm going to go ahead and minimize this. I've already got the access control IAM blade open for resource group RG1. So if I just click refresh, we now have a listing for user Jen Hill having the SQL DB contributor role for this resource group. Now that means that she will be able to manage all SQL DB instances that are deployed within RG1, but not any SQL DB instances deployed outside of this resource group. We can then remove a role assignment in the future by using the remove-az role assignment commandlet. I would specify in this case -sign-in name, specify the user principal name for our user, -role definition name, in this case SQL DB contributor, and in this case -resource group name of RG1 since that's where the user was granted that role. So I'm going to go ahead and press enter. So we can verify our work by using the get-az role assignment command that we used previously. So I'm going to go ahead and use that once again. This time we get no output because we've removed user Jen Hill, from that RBAC assignment in resource group 1, RG1. There are times when the built-in RBAC roles may not be sufficient to meet your needs. So as an example, we might create a custom RBAC role that perhaps combines some of the permissions from multiple different existing built-in roles. That way it can facilitate role assignment. Here on the screen in WordPad, I've got a custom role definition file. It's just a text file that uses JSON syntax. So here I'm going to be creating a role called Network and Storage Viewer. The isCustom flag or attribute has a value of true. I've got a description that's been specified. And what I'm allowing here is the reading of network and storage resources from those providers in Microsoft Azure. So what I need to do then is create the role from this role definition file. So because I'm going to be using PowerShell to create this new role definition in the Cloud Shell in the portal, I need to first upload that custom role JSON file. Here in the Cloud Shell, which was launched from the Cloud Shell icon in the portal, I can click the Upload and Download Files button. And what I'm going to do is choose Upload, so I can upload my role file. Once I've done that, the file will be available. So if I were to go to my home account here in the file system in Cloud Shell and do a dir, I've got the create_custom_role.json file. Creating the custom RBAC role file is the tricky part in that it uses JSON syntax that you need to make sure is correct. Actually creating a role from that file is pretty straightforward. We can use the PowerShell new-az role definition commandlet, and we're going to have to specify the file. So I can do that with -input file. And I'll just specify the name of our custom role file, which was create_custom_role.json. So we can create the role by pressing enter. And after a moment, our new role, Network and Storage Viewer, will have been created. We can check whether the role was created with get-az role definition -name and in quotes Network and Storage Viewer, close quote. So it returns some information, so we know in fact that that role does exist. We can also check that within the portal. So let's say we were going to create a role assignment. So here I'm in a resource group. It just as well could be the subscription. It could be a specific resource. It doesn't matter. But the point is that we will have gone into Access Control IAM on the left, where we can then click Add and add role assignment. We want to verify that the role shows up in the list of roles. So when I type in net to filter the list of RBAC roles, we'll have our Network and Storage Viewer custom role in the list. Microsoft Azure policy is related to Cloud Resource Control. What does that mean? Well, it allows us to control access to resources or the creation or configuration of resources, whether it's storage accounts, web applications, virtual machines, it doesn't matter what it is. Now, there are built-in policies, but you can also create your own custom policies. Now, Azure policy is more granular than role-based access control or RBAC. They are similar in that they can control resource access, but you can do so much more with Azure policy. As an example, we can determine with an Azure policy the type of resource that can be deployed, such as a virtual machine. Now, the other thing we can do to take that a step further is even determine a location or an Azure region where a resource can be deployed, such as a virtual machine. You might even limit it even from that by setting a limit on the virtual machine size. So you can't do that with RBAC. With RBAC, you can determine if someone can or cannot create virtual machines or modify them, but that's about it. You might even use Azure Policy in another example to set a default tag value when new resources are created. So with Microsoft Azure Policy, the policy itself can accept parameter values. So that's passed into the policy, and then you can assign it to a subscription. Now, when a policy is assigned to a subscription, that policy is also effective to everything in that subscription. So that means for resource groups and resources, but you can also use a management group. So a management group is a collection of subscriptions. It's really only for enterprise customers that have multiple subscriptions. By organizing multiple subscriptions into various management groups, you can facilitate the application of Azure Policy. Because when you assign Azure Policy to a management group, it would apply to the subscriptions within that management group. And of course, it would flow down in each of those subscriptions to resource groups and resources. So if you need granularity, you can assign Azure policies to a resource group. You can also make exclusions if, for example, you've assigned a policy to a subscription, but you want to exclude one resource group. You can do that. Then we have to consider policy effects. The audit policy effect is used when you want to log information. You want to check or audit Azure resources and then essentially report back on what is found. So an example might be to check compliance for whether or not virtual machine disks are encrypted. The modify effect allows properties or attributes of Azure resources to be modified, such as adding a default tag value. Deploy if not exists can check existing Azure resources and make configuration changes, such as checking for database configurations that might not be in place, but then modifying those configurations. We also have the Azure deny effect within a policy. Now, this not only applies when creating a resource, such as denying virtual machines from being deployed in a certain location, but it can also be used to deny the change being made to an existing resource. Then we have the notion of Azure policy initiatives. An initiative is really a group of related policies that you define. And so you assign this policy group or this initiative when you are working with Azure policy. Now, the idea is that instead of assigning individual policies, because they're related and organized into an initiative, you assign the initiative. So as an example, let's say that we create a policy initiative called Harden Regional Azure Resources, and it would contain a couple of policies. One would be to ensure VM disk encryption is enabled, and the second might be to ensure that endpoint protection is enabled. Those are two separate policies organized into one initiative to facilitate assignment. So you can manage Azure policy using the Azure portal, CLI, or using PowerShell commandlets. Azure policy assignments can be set within the Azure portal. The first thing we're going to do before we actually perform that task here in the portal is I'm going to open up an existing storage account. One of the options you have when you create or configure a storage account after it exists is network access. So for example, I'm going to choose firewalls and virtual networks here in the properties of the storage account. We have allowed access from all networks to the storage account. We could opt to select specific networks or client IP addresses or even just IP address ranges to limit from where connections to the storage account can be initiated from. Well, we can also check for that with Azure Policy. So I'm going to search for policy here in the top center search bar in the portal. I'm going to choose policy, and we're going to start by going to definitions over on the left. There are a lot of policy definitions. So you can either filter in the search field by what you want to look for in the name of the policy. You can also reduce that scope of policy definitions by changing the category. So currently all categories are selected. I'm going to uncheck that. We are interested in our case in storage. So I'm going to choose storage. We have a small enough list. I don't even need to filter beyond here. Just I'll expand the name column. The first policy definition here is storage accounts should restrict network access. That's perfect. That's what I want. So I'm going to go ahead and select that policy definition. Now from here, I can see the policy definition in JSON format listed down below, but I'm really here to click Assign. Now we could have also assigned it instead of clicking Assign here. I'll just click X to get out of here. We could have gone to the Assignments view over on the left and done it from that perspective by clicking Assign Policy up at the top. And from here, I'd have to select the policy definition with the selector button to the right of the policy definition field. I could filter here by part of the name. So maybe I'll just type in storage, and there it is. Storage accounts should restrict network access. So there's more than one way to do the same thing, is really what we're saying. Either way, I'm going to select that policy for assignment, and I'm going to have it assigned at the pay-as-you-go subscription level. So that means we're going to be checking for storage accounts restricting network access everywhere in the entire subscription for all storage accounts, regardless of which resource group they're in. Unless, of course, we added an exclusion for a specific resource. However, I'm not going to do that. Down at the bottom, I'm just going to click Review and Create, and I'm going to click Create. In the notification bar in the upper right, the little bell icon, the policy assignment has succeeded. Now, it can take some time before we have the ability to take a look at any compliance reports related to that. If I go to the compliance view now, for our storage account policy assignment that we just added, currently the compliance state is not started. So it can take a few minutes, and certainly the more resources you have in the subscription, the longer it will take for them to be evaluated. After a few minutes, when you open up the compliance report, you'll be able to see which resources are not compliant. I've got 2 storage accounts here that are marked as being non-compliant because they are not restricting network access. The Azure CLI can be used to assign Azure policies. Now, to get started here, the first thing I want to do is get a list of policy definition names. That can be done using the AZ policy definition list syntax. But I'm going to tell it I only want to see the display name property. So to do that, I'll run -- query, I'll add that to the end, space, open close, square brackets, because we will have multiple definitions returned. So to reference that we have multiple items in a collection or an array, I use the open and close square bracket, dot, and what I want to see for each of them is the display name property. Now, the property names here are case sensitive. So notice that display name uses a capital N for name, but a lowercase d for display. So we have to make sure we enter it in correctly. I'm going to go ahead and press enter to get my display names. Now that did work, but we have a very long list. So we can change the query to be a little bit more specific. Basically, I want to make sure that we are querying for policy definitions that contain the word encrypt in their display name. This is where the syntax gets a little bit more complex. So we still have AZ policy definition list, -- query, space, but then in double quotes, we've got our open and close square bracket, dot. Then we're telling it that we want to return the display name and the ID. What we're doing after that, now all of that is in curly braces. After that, our filter expression is in square parentheses. We've got question mark contains, and in parentheses, display name, comma, encrypt, close parentheses, close square bracket, close double quote. So now when we press enter, only those policy definitions that contain the word encrypt will be shown. And because we asked for the display name and the ID properties, that's what's being shown for each and every one of them. Here I've got one that I'm interested in. Unattached disks should be encrypted. I'm going to highlight and copy the unique ID for that policy definition because I'm going to need it in the next command. Now to create the policy assignment, I'm going to use the AZ policy assignment create syntax, -- name, and I will assign a name for the assignment. It's going to be called check for unattached disk encryption, -- policy, and this is where I've pasted in the ID of the policy that we returned with our previous command. I want this policy applied to a resource group, which is why the last parameter is -- resource - group. and the value of which is RG1. So I'm going to go ahead and press Enter to create that policy assignment. After a moment, the policy assignment is now in effect. Now we can verify our work even in the portal. So why don't we go take a look at our resource groups view in the portal. The resource group we're interested in, of course, is called RG1. So I'm going to click to open it up, and I'm interested in policies. So I'm going to click Policies on the left. On the right, we've got a policy assignment that's named Check for Unattached Disk Encryption. Policy evaluation has not yet started, but the policy assignment has been created correctly at the correct scope here in the RG1 resource group. You can use PowerShell to manage Azure policy assignments. The first thing I'm going to do is create a variable that points to a resource group named RG1. PowerShell variables are always prefixed with a $sign. So I've got $RG, that's the name of my variable, equals get-az resource group -name RG1. That's the first order of business. Now I'm going to be using that RG1 variable in a few moments. The next thing I want to do is store the definition of an existing Azure policy in a variable. To do that, I'm going to create a variable called $definition, which equals get-az policy definition. I'm going to pipe that to where-object. This is a PowerShell filtering commandlet. And my filter expression needs to exist in between or within the curly braces. So I'm going to use the $_ built-in placeholder variable. If you think about it, when you run get-az policy definition, it will return all of the policy definitions, of which there are many. We need a way to test each one. And so the way that we can loop through each one with a placeholder variable is to use the built-in placeholder variable $_. Now, for each policy definition returned, we want to test the .properties.displayName property to see if it equals -eq audit VMs that do not use managed disks. That's the policy definition I am interested in. So once that executes, which it has done, we will have that definition stored in the $definition variable. So once you've got a scope, in our case, the resource group stored in a variable, and a policy definition stored in a variable, you're ready to create the policy assignment. And you do that with new-az policy assignment. Let's just scroll back up so we can see that command a little bit. New-az policy assignment -name, and you name the assignment. Here I'm calling it VMs-managed disks. Now -display name, check for VM managed disks. That's the display name of this policy assignment. -scope, this is where I'm using our variable $RG, the resource group, and for that I am calling upon the .resourceID property within the resource group variable. Then -policy definition, and I'm referring to the $definition variable. You've got some yellow warning messages here because there could be some changes that are coming down the line. I'm just going to ignore those for now. There is a little note here that says if you want to suppress these warnings, you can go ahead and read the instructions for how to do that. So at this point, we've got that policy assignment set, but we can check our work, for example, in the portal. So what we want to do is go to our resource group 1 resource group, because that's where the policy assignment took place. So let's go to the resource groups view, and let's open that one up. So there it is, RG1. I'll click on it to open it up. I'll go to policies over on the left, and we're going to see any policy assignments over on the right. Now, if it's not up to date, we can click refresh until such time we see it. And here we've got it. Check for VM managed disks is now showing up here. Microsoft Azure consists of many built-in policies. Let's take a look at some of them. So here in the portal in the top center, I'm going to search for policy, then I'll click on policy. And then I'm going to click on the definitions view over on the left. So we have a number of built-in policies that are shown in the list. We can kind of hover over it if we want to get the full name shown up, such as auditing Windows VMs, where the administrators group contains members specified by the policy. That's just to name one. We could also filter by type. For example, we could say show any custom policy definitions. There are none yet. We're going to make one, but right now there are none. I'll go back to all types. We can also filter by category. So maybe I'm interested, scroll down a little bit, in Key Vault type of policy. So I can select that. And now the list is filtered to only show me policies related to an Azure Key Vault. We can also filter by name. So if I wanted to type in, let's say, encrypt, let's just open up all categories again. So now we are looking only at policies that contain the word encrypt in their name. But we're talking here about adding our own custom policy definition if the existing policy definitions don't meet your needs. So I'm going to click the policy definition button at the top to add a new one. First thing we have to do is define a location. So I'm going to click on the selector button over on the far right. I'm going to choose my pay-as-you-go subscription, and I'll choose select. And for this, I'm going to name this custom policy add custom cost center tag. We want to create a new policy, but we can assign it to an existing category if there is an existing category that makes sense. And there is one already here called tags, so this is just for facilitating filtering and looking at policy definitions. So the category is not necessarily required to be done that way, but I'm going to do it because it makes sense. Now down below, I've got some default sample policy definition code here, but I'm going to select it and paste in my own custom policy definition, where I'm setting the display name property to add cost center tag. The policy type is custom. And as I go further and further down through the policy definition, policy rules section has an if statement where we are testing whether or not we have a cost center tag. If that is false, if there is no cost center tag that's been specified, then the effect is to modify. And what's going to happen is the cost center tag will be added with a value of YYZ. We're going to add here for the city airport code of Toronto. So I'm going to go ahead and scroll down, and I'm going to click Save. After a moment, in our notification area in the upper right, we have a message about the policy creation having succeeded. Now, if we are looking at a filtered list of custom policy definitions, it will show up here. There it is, Add Cost Center Tag. So we can now use this for policy assignments. So I'm going to go to Assignments over on the left, and I'm going to click Assign Policy at the top. We're going to assign our newly created custom policy. Maybe we'll do it at the resource group 1 level is fine. Doesn't have to be at the subscription level. We'll leave that. We'll click the selector button to the right of policy definition, and maybe we'll just filter this here for custom policies. There's our add cost center tag policies. I'm going to select that, and I'll choose select, and I'll click review and create, So we've applied this policy assignment to add a cost center tag for a specific resource group RG1. So to test this out, what we can do is create a resource in RG1, in that resource group, to see if the cost center tag is automatically applied. So I'm going to go back home here, and let's say we're going to create a storage account there. So I'm going to create a resource. I'm going to search for storage account, and then from there, I'm going to click create. Now bear in mind, it may take a few moments sometimes for the policy to be in effect and usable, but we're going to go ahead and test it anyway. So in this case, I need to make sure I deploy this to RG1, since that's the scope where the policy is effective. And I'll put in a unique storage account name, after which really all I want to do is create the storage account. We don't have to specify anything else, but I will point out that if I look at the tags for the storage account, nothing is here by default. But our policy is going to catch that. It's going to realize there's not a cost center tag, and it should add it automatically. So let's click review and create. And let's just go ahead and click create to create a new storage account in the RG1 resource group. After a moment, our deployment is complete, and we can click Go to Resource to open up our newly created storage account. When we take a look at the overview blade, we can immediately see that the tag cost center with the value of YYZ has been added automatically as a result of our newly created custom policy. One way that Azure policy is often used is to check Azure resources for compliance to see if they're configured in a specific manner. In our case, we're going to go ahead and take a look at whether or not virtual machine disks are encrypted for compliance. The policy assignment has already been made. So I'm going to go ahead here in the portal, type into the search bar at the top, policy, and then I'm going to choose policy. This is going to open up the Azure policy navigation bar, where I have a listing on the right of overall resource compliance, in this case 50%, 1 out of 2. Then I've got non-compliant policies, 1 out of 4, non-compliant resources, 1 out of 2. As I scroll down below, I have non-compliance for the disk encryption should be applied on virtual machines policy assignment. If I scroll down a bit further, I have a bar chart for assignments by compliance over the last 7 days. Disk encryption is shown here in our specific graph. Now we can also click compliance over on the left to get more details. So I'm going to click on the disk encryption should be applied on virtual machines policy assignment because we've got something that's not compliant. So we need to find out what it is. I'm going to click on that to open up the assignment details in the compliance area. And as I scroll down further, we have the name of the server revealed. It's a virtual machine called WinServe 2019-DC1. And if I click on it, it's talking about the fact that we don't have encryption enabled for the virtual machine's disk. Now, interestingly, if I were to, well, let's actually do it this way. Let's go back home, and I'm just going to go to the virtual machines view. We can also view policy compliance at the individual resource level. We don't necessarily have to go directly into Azure policy. So as an example, let me open up my Windows virtual machine directly. And in the navigation bar for that VM, if I scroll all the way down on the left under the operations section, I'll come across policies. And when I click that, it'll show me the policy evaluation as it applies to this particular resource. We have a couple of policies shown on the right, including our non-compliant listing for disk encryption that should be enabled on the VM. As a matter of fact, we can also view the compliance at the resource group level. So let's say I got to the resource groups view, and I open up a resource group, let's say RG1. Much like we did with the individual virtual machine, I can scroll down in the navigation bar for that resource group, and under settings, I can click on policies. Here we'll have a list on the right of policies that will apply to this resource group. So for example, we have our non-compliant state being shown for our disk encryption policy assignment once again. Now, when viewing policy compliance at this level, at the resource group level, we also have a listing for the scope to which that policy assignment was applied. In this case, it was applied at the pay-as-you-go subscription level, which has flowed down to this resource group and ultimately to the virtual machines within this resource group. Azure Policy supports remediation tasks. As the name implies, a remediation task can take steps to bring resources into compliance. As an example, let's take a look at an existing policy definition, a custom one. So I'm going to click on Definitions in the left-hand navigator. I've already gone into Azure Policy. And for the type drop-down list, I'm going to choose Custom. I have one custom policy called Add Cost Center Tag. I'm going to click to open up that policy definition. One of the reasons I want to do this is because I want to look at the policy effect, which is set here to modify. So our policy rule here in this particular example is checking to see if cost center exists on a resource. If it doesn't, then it will be modified and it will be added. Further down below, we'll see that the cost center tag will be added with a value of YYZ. So the point here then is that the modify policy effect supports remediation tasks. So let's go back to Azure Policy, where on the left, I can click on Compliance. I've already assigned that custom policy, Add Cost Center Tag. So over here, we have a listing of non-compliant resources, and we do have a Create Remediation Task button up at the top. This is where we could select the resources that we want to remediate or correct that are not compliant with this particular policy assignment with our cost center tag. So I could specify the scope and even geographical regions or locations for resources, in this case in the resource group, and I could go ahead and choose to remediate them. Another way to do this would be to go to the remediation view on the left when you're within Azure Policy, It'll know which policy assignments are applicable, such as those with a modify effect, like our add cost center tag custom policy. And we'll be able to click on it in here, and it takes us to the same place to create a new remediation task. So remediation tasks then are available for some policy effects, such as modify, and they can be used to make a change that is required to bring a resource into compliance. Microsoft Azure Blueprints provide a template or a blueprint that allows for setting up an environment quickly, an Azure environment, which might be useful for sandbox testing. So an Azure Blueprint consists of what are called artifacts, items you add to the blueprint to set up your environment, like defining resource groups, role assignments, Azure policy assignments, and ARM templates, which contain the actual definitions to deploy resources, presumably into specific resource groups. So Azure Blueprint storage, when you configure it, can be set for either the subscription or the management group. So this is where we would save our blueprint definition. So the Azure Blueprint lifecycle then begins with the creation of a blueprint in what's called draft mode. And you can do this in the portal. Next, you would test it and make any required changes. You might realize, for example, it's not deploying resources into the correct resource group. So you would make that correction. Once you've tested your Azure Blueprint and it does deploy your sample environment quickly and correctly, you can then publish it. Publishing means assigning it so that it's active and then defining a version number for it. Microsoft Azure Blueprints are used to quickly deploy an environment by using definitions of artifacts like ARM templates, resource groups, RBAC, and policy assignments. So let's go ahead and create an Azure Blueprint. I'm going to search for Blueprint here in the portal in the top search bar, and I'm going to click on Blueprints. So the first thing I'm going to do here is click Create down under Create a Blueprint on the right. So creating a blueprint means that we can start with a blank blueprint, or we can choose from a pre-existing template for certain types of compliance, such as for FedRAMP high security, or HIPAA security controls, or ISO 27001 cloud security compliance. So we can select one of these, and when we do, it takes us into the Create Blueprint screen where we can assign a name, let's say BP1 for Blueprint 1. We can define the storage location, which can be a management group or a subscription within a management group. And then when we go to the artifacts page, we'll have all of the details related to what this blueprint does to set up an environment. It's important to take a look at the artifact type column where we'll have a reference to the type of artifact, such as a policy assignment. So we have a number of policy assignments here that are used to apply security controls for ISO 27001 compliance. However, I'm going to click Discard. I'm going to choose Create Blueprint, but we're going to create a blank one. So I'll choose Start with blank. I'm going to call it Blueprint 2, and I'm going to have that stored in my subscription. Then I'll click the Next Artifacts button down at the bottom. So under the subscription, I then have the option to add an artifact. So I'm going to go ahead and click on that. There are just a handful of artifact types: a policy assignment, an RBAC role assignment, an Azure Resource Manager template or an ARM template to actually deploy resources, and a resource group. I'm going to start with a resource group. Maybe when I use this blueprint to deploy a new environment, the first thing I want is a resource group to contain these specific resources. So we can set the values here by unchecking this option that states this value should be specified when the blueprint is assigned. If you uncheck that, you can hard code the name of the resource group here. But if you want this to be reusable, you could leave that default checkmark back on so that you're prompted for the resource group name and the location upon use of the blueprint. Down below, we can also add resource group tags, which I won't. I'm just going to click Add. So that adds resource group, under which we can then add artifacts. So I'm going to click Add Artifact. Now what I want to do is add a policy assignment. Here I have a custom policy called Add Cost Center Tag that will automatically tag resources deployed in this resource group because I'm adding this artifact under the resource group. So I'm going to select that custom policy and choose Add, and it shows up under the resource group, but I'm going to click Add Artifact under the resource group once again, because I can also add RBAC role assignments. So from here, I can select the role. Let's say I'll choose the virtual machine contributor role, and I can specify the user, app, or group that should have the benefits of being placed in that role when the blueprint is assigned, or I could uncheck that and specify it here. So if I wanted to, I could specify users that I have in Azure AD, or it could be groups. However, I'm just going to go back and let that be specified when the blueprint is assigned. So I'll click Add, and I'm going to click Add Artifact again. This time, I'm going to choose an Azure Resource Manager template or an ARM template. And the artifact display name, create Linux VM. And then down below, I'm going to click the selector icon to select the ARM template file. And when I do that, the JSON within that template file is shown below. So I'm happy with this. I could also go to parameters at the top if this particular ARM template had parameters to be filled in. Some of these parameters have default values. It's currently set such that the value should be specified when the blueprint is assigned, or we could uncheck that and hard code a name. I'm going to leave it on the default, and I'll click Add. So we've created a blueprint from scratch with a resource group, with a policy assignment, a role assignment, and an ARM template. So I'm going to go ahead and click Save Draft. So then in the blueprint definitions view, I'm going to make sure I'm selecting my pay-as-you-go subscription, since that's where I've specified the storage, and Blueprint 2 then shows up. It's currently in draft version. So what we can do then is click on the selector icon over on the far right of that blueprint definition and choose Publish Blueprint. When we do, we have to specify a version. I'll put in 1.0 and any potential notes, and then click Publish. Now, once we've done that, the latest version column will switch from draft to the version number that we've specified. And once you've published the blueprint, then if you go to the selector icon over on the far right, you can then assign the blueprint. So I'm going to go ahead and choose Assign. I can define the location where I want this to be assigned. I'll choose East US. I can choose the version of the blueprint, of which we have only one. And I can determine if I want to lock the assignment and prevent deletions or modifications to the assignment. I'm going to leave it on the default of Don't Lock, and I'm going to click Assign. Now, when we do that, we have a number of parameter values that we need to specify based on how we added our artifacts to the blueprint. So we would specify the values for things like the resource group name and location, details about the Linux virtual machine, which stems from our ARM template, after which, when we assign, it would deploy this environment. So the blueprint then serves as a quick and efficient way to deploy an environment which could be used for testing, or it could be used for production, such as when you launch a new project and you need to utilize Azure resources to support that project. Azure Privileged Identity Management, otherwise called PIM, is a feature whereby instead of assigning administrators or other technicians roles, which are permissions to resources, all of the time, it can be done only when they need it. Think of it as just-in-time administrative access. It's time limited. Now here in the portal, to set that up, I'm going to search in the search bar at the top for Priv, and right away, I'll select Azure AD Privileged Identity Management to open that tool. In the Privileged Identity Management landing page over on the right, I have the ability to assign eligibility. Eligibility, or an eligible role, is an Azure AD role that you assign that could potentially be used by an administrator to which it was assigned. It becomes active when they are using it. And we can even configure it such that they must request to be able to use that role, and that request must be approved before the role is activated. We can also click on the left here. For example, if I were to go to roles, we'll get a list of Azure AD roles. So let's say, for example, we want the application developer role to be assigned to a user. So I'm going to click on the application developer role, and that takes me into the assignments for it, where currently there are no results for assignments, at least for eligible roles. So I'm going to click Add Assignment, where I can select a user, for example. So down where it says select members, I'm going to click on no member selected. In this case, I have a user in mind, Cody Blackwell, an Azure AD user, that I want to have those privileges. So I'm going to select Cody Blackwell. I'll click select, and then I'll click next. The next thing I'll do is determine the assignment type, whether it's eligible or whether it's active. So what I want to do is make it eligible, and I can even set a start date and time and ending date and time where this assignment can potentially even be activated by an admin that wants to use it. Now, the maximum time you'll be able to allocate here is going to be up to 24 hours. So if I specify within up to 24 hours, we'll be able to create this configuration. So I'm going to go ahead and create an eligible assignment type. I'll click Assign. And after a moment, we'll see the assignment show up in the list for user Cody Blackwell. I could also click Role Settings over on the left, where I could click Edit at the top. And I might even want to turn on some features, such as requiring approval to activate. So I'm going to go ahead and turn that on, and I can then select an approver. So for example, I can select my own account to make that happen. Then I can just click Next, and I can view more details about assignments and notifications that we might want to configure here when it comes to roles. So we could specify some notification recipients that might want to receive notifications when these things are done, when we've got a request to approve a role that's been received, and so on. So I'm just going to click the Update button. I'm not really going to change much about that. And after that, it's done. So now to test this, what we need to do is sign into the portal as user Cody Blackwell and open up Privileged Identity Management. So I've signed into the Azure portal as user Cody Blackwell. So what I'm going to do is search for Priv in the top search bar, and we're going to go into Azure AD Privileged Identity Management from the perspective of this user. So if I were to click My Roles over on the left, that's for the user that's currently logged in, notice that the eligible role here that is applicable to user Cody Blackwell is Application Developer. And so we could click Activate over on the far right. Now we can specify a reason. Need to work with Azure AD apps. And then we could click the Activate button. Now, because of our configuration, the message at the top right states that the request is pending approval. So here I've got an email message notification about approving or denying Cody Blackwell's request to activate the application developer role. I can scroll down and read some further details, and I've got a button to approve or deny the request. So I could do that through here. Of course, I could also take a look at it in the portal in the Privileged Identity Management section. Now back in the portal, but as my original administrative account, so not user Cody Blackwell, if I'm in Privileged Identity Management and I go to Approve Requests on the left, I'll see that there is an approval request from user Cody Blackwell for Application Developer. We'll even see the reason that was entered by that user. So I could click directly on the role name to open up a new blade on the right, where I could either choose to approve or deny the request. So I'm going to go ahead and click Approve for user Cody Blackwell. After that's been done, back in the portal logged in as Cody Blackwell, if we look at the My Roles view, the application developer role is applied to Cody, and we've got an ending date and time. If Cody were to click Activate once again, there would be a message stating that it's already been validated. So it says the role assignment already exists. So Cody has that role for the specified period of time. Azure AD Access Reviews are useful in that it can give us a sense of whether users still need to be a member of a group or whether users still need to have permissions for an app. Over time, we might have users that remain in a group or users that continue to enjoy application access when really they shouldn't. And that's what we can determine using access reviews. So here in the portal, the first thing I'm going to do is search for governance, and I'm going to choose identity governance. This is where we can click on access reviews on the left to build our configuration. I'm going to click new access review up at the top. What I want to do is check some members of a group. So I'm going to call this check group members. Now, the frequency can be one time, or you can schedule it weekly, monthly, quarterly, and so on. This is going to be a one-time thing here. I'm going to scroll down, and I'm looking at the members of a group. Now, the default scope is guest users only. I want to look at everyone that's a member of a group to determine if they still really should be a member of the group. But of course, we have to select the group in question. So I'm going to click Select a Group, and I've got a group in Azure AD called Team 1. So I'm going to check Team 1, and I'll select it. Now, down below, we can also determine who are the reviewers, the group owners, or do we want to select users or members? I'm going to choose members. I want the members of the group to determine and respond as to whether they should still remain in the group or not, and why they would still need to remain in the group. Now remember, we could, in the users to review, this could be for assignments to an application, but in this case, we're just checking group membership. Down below, on completion settings, we've got a couple of options here. We can auto-apply results to the resource, or if reviewers don't even respond, we can remove access. Can't be that important if they didn't bother to respond. So that might be an option we want to look at. So I'm going to go ahead and click Start to start the access review. So I've signed into myapps.microsoft.com as user Jen Hill, and there is an Access Reviews app icon on the apps page. So I'm going to go ahead and click on it. So we've got the Check Group Members Azure AD Access Review shown here. So I'm going to go ahead and click Begin Review. It asks, do you still need to be in the group Team 1? I'm going to choose yes, provide a reason. I still need access. And then I'll go ahead and click Submit. So this is the type of thing that users will be presented with based on how we've configured our Azure AD Access Review. So if we take a look at our existing Access Review Check Group Members for the group Team 1, the status shows results applied. And if we click on that to open it up, we'll get a sense of whether users are still in the group or not. So approvals versus denials. So we've got two users, one is approved, one is denied. If we click on the results over on the left, we'll get some more fine-grained detail about that. So user Marcia Lynn was denied. User hasn't signed in, so successfully removed from the group, but user Jen Hill has been approved. And she provided a reason saying, I still need access. She still needs to be a member of this group and needs the benefits of being in the group to access resources. So that's why we've got one that's denied and one that's approved. You can control access to management ports on Azure virtual machines using just-in-time or JIT access. The idea behind this is that instead of leaving management ports open all the time, so like port 22 for Linux for SSH or port 3389 for RDP in Windows, instead, when users or administrators request that access, the ports will be opened for a period of time. So to get started with this, I'm going to, in the portal, open up the properties of an existing Linux virtual machine. It's called Ubuntu-Serve1. And I'm going to scroll down in the navigation bar and go down and click on Configuration. Now, on the right-hand side of the screen, I have a button labeled Enable Just in Time. So it's not turned on, obviously, for this virtual machine. I'm going to click the Enable Just in Time button, and when I do, it disappears. And I have an option to open the Azure Security Center, which I will do. That's going to open the Security Center and take me into the Just-in-Time VM Access section, where down below, I'll see any virtual machines that are currently configured for just-in-time access. If it's not up to date yet, just give it a moment and it will be. There it is. Our new server, Ubuntu-SRV1, now shows up here. At any point in time, I can click the selector button over on the far right, and I could choose Edit. If I wanted to edit the JIT configuration, it automatically knows it's Linux, and so it's got port 22 enabled here. Well, it would be enabled for up to 3 hours when a request is received to access that VM. So for example, if I close out of that, when we go into the Security Center and into the Just-in-Time Virtual Machine Access section, another technician could put a check mark by that virtual machine and then click the Request Access button over on the right. Now, That would toggle on, in this case, port 22 in its configuration. We could have modified that config, but that's what it picked up automatically. And we can specify the allowed source IP, which defaults to my IP, so the public IP address I am making this request from in the first place. And the time range is set for up to 3 hours. I could also enter a request justification. Need to configure app 1 settings. Maybe we've got an app running within that Linux virtual machine, and then I could click the Open Ports button. And then you'll see in the notification area in the upper right, the bell icon, that JIT network access has been initiated. The request has been initiated against that virtual machine. So, in this course, we've examined a number of Azure AD security mechanisms for limiting resource access, including role-based access control, or RBAC, policies, and Azure blueprints. We did this by exploring RBAC and how to use the portal, CLI, and PowerShell to assign a built-in Azure role. We explored how to create and assign a custom Azure role. And we looked at the use of Azure policies and how to use the portal, CLI, and PowerShell to assign a built-in Azure policy. We also examined how to create a custom policy, view Azure policy compliance, and view and apply policy remediation. We explored the purpose of Azure blueprints and how to use the portal to publish and create a blueprint. We examined how to configure Azure AD, Privileged Identity Management, or PIM, and enable identity protection notifications. We then looked at how to initiate an Azure AD Access review, and finally, how to configure Virtual Machine Just-in-Time, or JIT, administrative access. In our next course, we'll move on to explore the use of Windows Virtual Desktop for remote access to user desktops, as well as support for application workloads through the use of Azure Container Solutions. Windows Virtual Desktop, or WVD, is a virtual desktop infrastructure solution, otherwise referred to as VDI. It supports Windows 7, Windows 10, and Server 2019 desktops that run in the cloud that we access remotely. So not only do we have desktop virtualization for those listed operating systems, but you also have app virtualization in the cloud. So instead of users connecting to an entire desktop, you could also have an individual app that users need to access remotely. Now, you can use your own customized images that might be stored as a blob in a storage account for your desktop that might have customized software within it. You can configure multi-session versus dedicated desktops. One of the options you'll notice if you configure a host pool, which really defines things like the virtual machine settings that will be running under the hood to support this, is that you can configure pooled or personal. Now, a personal configuration for a host pool means that there's a one-to-one correlation between a user that signs in and they have their own personal backend VM that is for their own exclusive use. Windows Virtual Desktop requires the configuration of a host pool as we've just described. You can also configure app groups, and as the name implies, this is a collection of related applications that are then registered with the workspace so that they become available to be used by users. So the other thing to consider is bandwidth and speed. You can use an estimator tool online to determine the best region with reduced network latency where you should deploy your Windows Virtual Desktop environment. Connectivity from clients can occur from a Windows machine, from an iOS device, an Android device, or even just any HTML5 web browser. Now, bear in mind here that using the standard remote desktop connection client is not supported when you want to go through Windows Virtual Desktop. There are a few prerequisites that you will want to consider before deploying Windows Virtual Desktop, or WVD. The first thing we'll examine here in the portal is that you should determine your Azure Active Directory strategy and how it will link to another Active Directory service. So first things first, here in the portal, I'm going to navigate to Azure Active Directory. What I want to do in the navigation bar is scroll down and choose Azure AD Connect. This will give me the status as to whether or not Azure AD is linked to another directory service. The sync status is shown here as being enabled, with the last synchronization having occurred less than 1 hour ago. So let's take a look at how this works by first going into the users view, where I'm going to see users that were created directly in Azure Active Directory, but I will also have user accounts showing up as having stemmed from Windows Server AD. They were essentially synchronized from a different Active Directory service. Specifically, I've manually deployed Active Directory in a virtual machine in an Azure VNet. So speaking of VNets, let's go take a look at the VNets within the subscription. So I'm going to open up the navigation bar on the left. I'm going to choose Virtual Networks. Now you can use either your own manual virtual machines where you've deployed Active Directory, or you could use Azure AD Domain Services, which is not the same as Azure AD because it has much more configuration flexibility. And you must join a machine to the domain to be able to manage objects in the domain. So I've got a VNet here called WVD for Windows Virtual Desktop _VNet. If I click to open that up, what I'm looking for here is DNS name resolution. So if I scroll down in the navigation bar and go to DNS servers, I've changed the default Azure provided DNS to custom, and I've entered in the private IP address of my Azure virtual machine running as a domain controller. Here in my virtual machine, where I'm running a domain controller, we have an Azure AD Connect icon on the desktop, which implies that it's been installed, and it has. It's synchronized with Azure AD. Let's take a look at the command prompt on the same machine just to check out the private IP address, because it will be the same IP address that we were just viewing a moment ago when we looked at the DNS server configuration in the VNet. So I'm just going to increase the font size so we can see this a little bit more clearly, and I'm going to type ipconfig. And the private IP address happens to be 10.2.0.4, and that's what's configured for a DNS name resolution in the VNet. Now on this server also, I've already opened up Active Directory users and computers. I've got a domain called quick24x7test.info. If I take a look at the built-in users container, I've got some user accounts here. For example, I've got one for myself, De La Chance. This is an administrative account in Active Directory which can join computers to the domain. That's going to be important with WVD when you do things like deploy host pools, where you specify the name of the domain to join and some credentials for a user that has the ability to do that, join machines to the domain. Now, the other thing that we should consider is the location of where those virtual machines or session hosts that support Windows Virtual Desktop will exist in the Active Directory hierarchy. By default, they're going to go into the computers container if you specify a domain. Otherwise, you can specify any specific OU that you might want those virtual machines to go into, such as East, as we have listed here. With Windows Virtual Desktop, the host pool is the configuration related to the operating system image that will be used for remote desktops, and whether users have personal desktops or shared pooled desktop virtual machines available, that type of thing. So to get started with the host pool configuration here in the portal, I'm going to go ahead and search for Windows Virtual. Now this is in the top center bar where I can search for services, and Windows Virtual Desktop is now available. Now that was previously in preview mode for the spring 2020 update. Now it's GA, general availability. So I'm going to click Windows Virtual Desktop. That's going to give me the ability to work with, in the left-hand navigator, host pools, application groups, and workspaces. There's also a user's view I can use to view active user sessions. So the first thing we're going to do here is create a host pool. So I'm going to click Host Pools. We're going to fill in some of the details. I'll click the Add button to add a new one. I'm going to deploy this into an existing resource group, and I'm going to name the pool Host Pool 1. I'm going to put it in the East US location because that's where I've already got a VNet, a virtual network in Azure, where I've deployed a virtual machine manually running Active Directory. So that's already done. So I'm going to go ahead and choose Pooled for the host type. Now I want this to be pooled whereby we don't have a one-to-one correlation between users and a back-end virtual machine. I'm going to leave the maximum session limit to unlimited, and I'm going to also leave the load balancing algorithm to breadth first. This means it'll take the least busy backend host to take care of a new session request, whereas if I choose depth first, it's going to make sure it can connect to a backend host that hasn't yet reached its maximum connection limit. So I'm going to click on Next for virtual machines. I do want to add virtual machines, so I'll click Yes for that. Here's the resource group again, and the virtual machine location, again, East US, because way down, just if we can jump down quickly, it automatically selected the virtual network of the VNet in that area. I've already created one called WVD_VNet, and that's the one where I've deployed a domain controller already. So let's scroll back up here. We can also change the sizing here. So depending on what our requirements are for compute power, will determine whether we select a greater or a lesser size for determining the number of vCPUs and the amount of memory. Really depends on what your users are going to be running in their desktops. For the number of VMs, let's say we want 2. For the name prefix, how about we call it WVD-VM? And for the image type, it can be either gallery, or you might have a storage blob image that you want to specify you're a customized image. But in this case, I'm just going to go to gallery, and from the list, I can choose Windows 10 Enterprise Multi-Session, and I could choose multi-session with Office 365 Pro Plus, which is what I want, or I could choose Windows Server 2019 Data Center. For the OS disk type, because I don't need high disk performance, I'm just going to go with standard HDD. It's got the virtual network and subnet selected. I'm not going to turn on direct public IP access to these for management purposes. And I'll leave the defaults for things like the management group. I do want to specify a domain. I want these joined to an Active Directory domain called quick24x7test.info. That's an actual Active Directory domain I have running in the cloud that I've set up manually that is currently synchronizing with Azure AD through Azure AD Connect. You can also specify the organizational unit or the OU into which I want these virtual machines to be joined to in the domain. Otherwise, they're going to go into the computer's container by default. So I need to specify some credentials here that have the ability to join computers to that domain. And then I'll click Next for Workspace. I'm going to leave it on No. I'm not going to register the desktop app group quite yet. Or if I do choose Yes, it'll tell me whether or not I've got any available workspaces, but I'm not going to go ahead and do that now. I'm just going to choose No. I'll click Next for Tags, Next for Review and Create. And after it passes the validation, I'm going to go ahead and create the host pool by clicking the Create button. This will take a few minutes, so be patient, but monitor the screen so that you know when it's completed. Now, what normally follows the host pool once it's been deployed is creating app groups and workspaces to make desktops and also any applications that you might have configured available to users. Now that the host pool deployment is complete, why don't we check our work? So here in the portal, I'm going to search for Windows Virtual Desktop. We're going to pop up that service, click Host Pools over on the left. Sure enough, we'll see Host Pool 1 shown on the right. And if I click on it to open up its details in the navigation bar, I can click on Session Hosts. And I'll get a listing on the right of the virtual machines or the session hosts, of which there are 2 that are currently up and running to support my host pool. Notice that the prefix used in the nomenclature of each of those session hosts is what we specified when we were creating the host pool. It's WVD-VM, followed by -0 for the first session host, and followed by -1 for the second session host. If I were, let's say, to go back home here in the portal and open up the virtual machines view, what I would notice is that each of those session hosts shows up as a virtual machine along with the standard virtual machines that we would normally see in Azure. So they are manageable infrastructure as a service VMs. Not only that, but if I take a look at the Active Directory Users and Computers tool for my Active Directory domain that I've linked to Azure AD, if I go into the Computers container, I will have each of those session hosts shown here as well. For Windows Virtual Desktop, not only must you have deployed a host pool, but you can also configure application groups or app groups. Now, what we're going to do here in the portal is search for the service in the top center bar. Windows Virtual Desktop shows up, so we're going to click to open up that service navigation bar. If I click Host Pools over on the left, on the right, I've already got a host pool called Host Pool 1. But if I click Application Groups, I don't yet have a custom application group. I have the default Desktop Application Group, or DAG, for my existing host pool. Now that would be important because this is where we can allow users to access remote desktops. If I click on that default desktop access group, that was created automatically, by the way, when the host pool was deployed through the Azure portal. Well, if I click on assignments down on the left, no one is assigned. So I'm going to go ahead and click Add, and I can select either an Azure AD user or group that should have this assignment. I'm going to add just a single user in this example, Cody Blackwell, and I'll click Select. And after a moment, user Cody Blackwell is shown and is assigned to this default desktop application group. I'm going to go ahead and close that. I'm going to click the Add button to add a custom app group. You might want to organize apps for different projects or different groups of users under an umbrella, and that would be what the purpose of the app group is. So when you create an app group, you specify the resource group association for it, the host pool it's associated with. We only have one host pool called Host Pool 1. And we have already got our default desktop application group. So our selection here then is for remote app. I'm going to call this East Apps, let's say, as an example. I'll click Next for assignments. I'll click the link where I can add Azure AD users or groups. Again, in this case, I'll just add a single user for testing, user Cody Blackwell. I'll click Select. Next for apps, and I'll click Add Applications. Now from here, the application source could be the Start menu or a specific file path. Now this file path is relative to the virtual machine or the session host that would be running. So for example, you could refer to an executable that exists in the file system on the underlying virtual machine. And if you've actually created your session hosts from custom images that you might have had stored as blobs in a storage account, you can refer to anything that would exist within that virtual machine image. Here I'm going to choose Start Menu, and I can choose an application from the list. So for example, just to make things simple, why don't we just add something easy like WordPad? So I'm going to add WordPad. The display name is filled out. We can add a description. I'm going to click Save, and we've got WordPad added to our applications. I'll click Next. I'm not going to register it yet with the workspace, but I could choose to. If I choose yes, it says, well, there are no workspaces here. So I can either create the workspace first and do this, or come back and change this after the workspace is created, which is what I'll be doing. So I'm going to go ahead and click Next for tags, Next, Review, and Create. And once that's validated, I'm going to go ahead and click the Create button to create the application group. Now, once that's complete, I'm just going to go ahead and close that and go back into Windows Virtual Desktop. And I'm going to go back to application groups over on the left. So much like we did with our default desktop application group, I'll just click refresh up here. For our newly created app group, so it's a remote app group, notice that under the column here for the application group type, as opposed to a desktop type. So if I open up East Apps, we have to look at the assignments. Which users are assigned to this app, or the apps that are available within this app group? So I'm going to click the Assignments item in the left-hand navigator and make sure that user Cody Blackwell is shown up here. He is, because we added that user account as we were configuring that assignment, but you can change it at any time. I could select Cody Blackwell and remove that account, or click Add and browse for other Azure AD users or groups. I can also click on Applications on the left. I'll have a list of existing applications. We've got WordPad already added. And I can also click the Add button at any point in time, so I can keep adding applications as required over time within the application group. With Windows Virtual Desktop, you deploy a host group, which is the definition for the underlying virtual machines that will support remote desktop sessions and remote apps. You can then deploy app groups to organize apps. And finally, our focus, you can then configure workspaces. App groups need to be registered with the workspace before they become available for use by users. So to get started with this in the portal, I'm going to search the top center bar for Windows Virtual, and I'm going to choose Windows Virtual Desktop. On the left, if I click on Host Pools, I've already got a host pool called Host Pool 1. That's good. I've already got an application group. Well, you're going to have a default one anyways, called the name of the host pool, -DAG for the default desktop application group. But I've created a custom app group called East Apps. And if I go to Workspaces, we don't have any workspaces defined yet. So I need to do this to make sure that the apps are available to users. So I'm going to click Add to do that. I'm going to deploy this into an existing resource group. And then I'm also going to give it a name. I'm going to call it Workspace 1. That's also going to be the friendly name, for lack of a better name at this point. And I'm going to leave the location to East US. I'll click Next for application groups. It says, do you want to register any application groups? Well, we saw that we had one that I had configured previously called East Apps. And we know that the app group needs to be registered with the workspace for those apps to show up for users. So I'm going to go ahead and click Yes. I'm going to click Register Application Groups. We've got East Apps and, of course, our host pool default desktop application group. I'm going to select them both. Click Next for tagging. We're not going to tag it. Next, Review and Create. It's doing a validation. Of course, that's going to be a valid config. So I'm going to click the Create button to create the workspace. And it won't take long before it's finished. So I'm going to close that out, go back into Windows Virtual Desktop, go into my application groups on the left. Let's just open up the East Apps application group just for fun. So what we want to do is just point out that in the overview blade on the right, we have a reflection here of the workspace that this app group is associated or registered with. And in this case, it's called Workspace 1. Of course, we could click on the assignments to see which users or groups in Azure AD are assigned to this app group. And we can also get a list of the applications by clicking Applications on the left. One way that users of Windows devices can make a connection into Windows Virtual Desktop in the Azure cloud is using the Windows Desktop Client. This is not the same thing as the standard remote desktop client that you would use to remotely connect to the GUI of a remote Windows host. So as I scroll down, I have the option to download the 64-bit, 32-bit, or ARM 64-bit version of the Windows Desktop Client. I've already downloaded and installed the 64-bit remote desktop client, and I've launched it and signed in. So when you sign in using this remote desktop client on a Windows device, you'll have your workspace listed down at the bottom. Now, any previous workspaces may also appear in the list, but you can click Remove to remove them like I've done. So for Workspace 1, I have an option to run a remote app, WordPad, as well as connect to a remote session desktop. Let's try them both. So I'm going to double click on WordPad to start that remote app. It wants me to put in the password for the account I've signed in with for the remote desktop client. So I'll go ahead and specify that and click OK. And before you know it, the app is running as if it were running or installed locally. So the next thing we're going to do is shut that down and then try to open up a remote desktop session. So I'm going to go ahead back here in the remote desktop client. I'll just click on the session desktop to get that started. After I've clicked that, it'll once again prompt me for my credentials. So I'm going to go ahead and enter those in to establish the remote desktop connection. And after a moment, it will take us into our remote session as if we have Windows 10 running locally when really it's running in the cloud. One way that your users can access Windows Virtual Desktop is straight from an HTML5 compliant web browser running on any platform. The URL that they would connect to is https://rdweb.wvd for Windows Virtual Desktop.microsoft.com/arm/web client. So I'm going to go ahead and copy that because I want to test that connectivity. After I do that and sign in as a valid Azure AD user that has been assigned apps, so in this case, user Cody Blackwell, we'll have a listing for the workspace. There could be more than one workspace, but here we've got only a single one called Workspace 1, under which there are two options, one of which is for a remote app, WordPad. The other is called Session Desktop. So if I were to click directly on WordPad, it asks to access local resources like the clipboard and printer. Those are checked on by default. I'm okay with that. I'm just going to click Allow. And it's now connecting and launching the WordPad application for this user all through a web browser, meaning the user doesn't have to have the app installed locally. So then it's asking me for credentials. And after a moment, the WordPad remote app is now up and running. I'm just going to go ahead and close that. I could also, of course, launch a remote desktop. So back here in All Resources in the web interface, I'm going to click on Session Desktop. I get the same type of question about accessing local resources like the local clipboard and printer. I can even say, don't ask me again for connections to this computer, so I'm not always bothered with it if I always want that enabled. So I'm going to go ahead and click Allow. So it's making a connection, and again, I will authenticate. I need to specify credentials for an Azure AD user account that's been assigned to be able to use these apps and desktops. And after a moment, it's going to sign me into my remote Windows desktop. So really, the only thing that's happening is we're getting the screenshots or the live screen feed back into the browser, but everything is actually being hosted on a session host or a virtual machine running in the cloud. But to the end user, it's as if they were running a Windows 10 desktop locally, but really, they're not. Application containers are based on images. And a container image contains the software and the settings required for running a containerized app. So instead of deploying an application directly into an operating system, so it depends directly on that OS, instead we can have a logical boundary called a container. We can say that the container is a runtime instance of that container image. The benefit here is that the containerized app becomes portable. We can move it around to run on different hosts, because it doesn't depend directly on the underlying host. The Azure Container Registry, or ACR, you can think of as being a centralized repository where you can store container images. For example, for developers in your organization, you might have a container image that is used on a Linux environment that has all of the development tools required by your developers. So when they need to develop a new application, they can fire up a container based on that container image and everything is ready to go. Azure Container Instances, or ACI, are a managed service where you can quickly deploy a containerized app in the Azure environment without having to worry about the underlying infrastructure to support that. You don't have to worry about setting up servers and installing containerized software like Docker to support containers. Application containers, shown across the top in the diagram, run on top of a host operating system. In our diagram, we have a host operating system, whether it be running Windows or Linux, within which we have, in this case, the Docker engine running. The Docker engine allows for the running of containerized applications. Now, binary files and libraries can be contained within an application container, or some of those files might be called upon in the underlying host OS, but generally speaking, they're contained within the app container, which makes it portable. So because the app container does not contain an operating system, it starts up really fast. The underlying host OS is already up and running. So when we talk about having a containerized application, it's not as if an entire large app has to be within one container. So an application might consist of many different containers, each containing software components or microservices that talk amongst one another and together comprise a single application. Azure also supports the Kubernetes service, AKS. Kubernetes is an open source solution. It's an application container infrastructure that supports clustering. So you have app container clusters that support scalability, load balancing. You can configure health probes so that any failed instances in the cluster are auto-restarted. The Azure Kubernetes service can be deployed using the CLI. You can also deploy it using the Portal GUI, and you can also manage it using Azure Cloud Shell, specifically using the kubectl or control command tool. You can use the Azure portal to create an Azure Container Registry, or ACR. To get started here in the portal, I'm going to click Create a Resource, and I'm going to search for Container, and after that, I'll choose Container Registry, and then Create. You could think of a container registry as being a centralized repository to store container images. So when we deploy it, we have to specify the resource group it will be deployed into, the name of the registry. I'm going to call this ACR172. It'll check that that name is unique, and it will append the .azure CR for container registry .io DNS suffix by default. I'm going to put that in Canada East. I'm going to go ahead and enable the premium SKU because if you want to enable things like replication or private endpoints, network access, you need to enable that. So I'm going to go ahead and click Next Networking. So because I've selected the premium SKU, I have the option of a private endpoint. The default is public endpoints. So I could go down and add that to limit access to this container registry. If I click Next for encryption, again, because I've used the premium SKU, I can also specify customer managed keys to protect my container images with encryption. I'm going to click Next for tagging, not going to add tags. I'm going to review and create. And so the validation is passed. So let's create the container registry by clicking the Create button in the bottom left. It only takes a moment before we can click the Go to Resource button to take us into our container registry. One of the things that we want to take a look at in here, first of all, is Access Control IAM. There are specific RBAC roles related to the Azure Container Registry. If I were to click Add and then Add Role Assignment on the right, when I open up the list of roles in the A's, there are a number of roles that have a prefix of ACR for Azure Container Registry, like ACR Delete, ACR Image Signer, ACR Pull to be able to pull container images from the container registry, as well as ACR Push to allow pushing or populating the registry with container images. So we've got a number of these roles, and that's the first consideration when we want to delegate access for the registry. Also, if I click Access Keys over on the left, we have the registry name and the login server DNS name, but I can also enable the admin user. And when I do that, the username becomes the name of the container registry, and we have 2 passwords, and we can regenerate one while keeping the other. You can regenerate them periodically for security purposes, but if you want to use some Docker CLI commands to manipulate container images, such as pushing and pulling them into and out of this container registry, you're going to need to know the username and password to do that. If I were to click Networking over on the left, this is where we would have our options to control public access for selected networks, or to create specific private endpoints. We can also configure replication, this is geo-replication, to alternate geographical regions. This is available because we've selected the premium SKU for the container registry. Otherwise, we wouldn't be able to do that. Back in the container registry, if I scroll down under services, we also have repositories. This is where any container images that we might have brought in will show up. Now, when I say brought in, you can actually bring in or import container images from public registries like Docker Hub out on the internet, or from a private registry you might have created, or even from another Azure Container Registry. You can pull over container images from it into this container registry. You can push images into an Azure Container Registry or pull container images from it. Here I've got a Linux virtual machine I've deployed that already has Docker installed. I've called it Docker VM1. So I can issue the docker-h command for help, and I can see that the Docker command is recognized because we have a help screen that shows us the next level commands after Docker that we could use syntactically. So I'm going to clear the screen. Next, I'll run the sudo elevated privilege command with docker run-it, so we have an open input screen and we can see the result of pulling down the hello world container. So it says hello from Docker. So this was pulled down from the public Docker Hub container image repository. So we know that it's working. If I run docker ps-a, specifically sudo in front of it to run it with elevated privileges, we'll have a list of the containers. And we have one here, hello world, that we've just launched 42 seconds ago. So we know then that we were able to pull this container image from a public repository and run it locally on our Docker host. Here in the portal, in my Azure Container Registry, I need to go to the Access Keys blade so I can find out the name of the server and the username and password. So I'm going to copy the login server to my clipboard. It uses the Azure cr.io DNS suffix by default. There's the username I'm going to need to sign in with, and I can use either one of the 2 passwords. I'm going to use the first password here to authenticate. I'm going to be authenticating using the Docker command line interface. So I'm going to run sudo docker login, And I've pasted in the name of our container registry. So I'm going to press enter. If I haven't already previously authenticated with the name and password, then I'll be prompted for it. I have, so therefore the login succeeded. Back here in the portal, if I go to the Quick Start blade for my container registry, it gives me instructions on what I can do to publish any container images to my container registry. So there's the Docker login command. It's even specific to our details like the URL or the name of that container registry. So we've got the Docker tag command here that gives us an example of how to tag the specific container image that we have running on our Docker host with the name of the container registry, which is required when you want to upload to it. So back here in Linux, I'm going to run Docker tag, and hello world is the container I currently have I want to tag, and basically I'm going to add a prefix that's going to include the name of my Azure container registry. So I'm going to prefix this with sudo, again to run it with elevated privileges. The next thing we see in the Quick Start blade back in the portal is to actually publish it to the Azure Container Registry. We can use Docker push. And then we specify, of course, the newly tagged name of our container that's running on our Docker host. So I'm going to run Docker push and do just that here on my Docker host. Of course, I'm going to prefix that with sudo once again. So it is now pushing it to our Azure Container Registry, and it's completed because it's a small container image. Finally, if we ever want to pull that container image from the registry to fire up a new container instance, we can use the Docker pull command, and the syntax is shown here in the Quick Start blade. So I'm going to run that, sudo docker pull, with the name of it, and after a moment, it will have pulled it down to our local Docker host as a running container instance that we can then work with. Azure Kubernetes Service, or AKS, is essentially an orchestration solution to manage clusters of containerized applications. Now, this also supports scaling, so if you want to accommodate the workloads running within the Azure Kubernetes cluster, and also we can even configure different types of pools to run different types of workloads for containerized applications. You can also link your Kubernetes service with Azure Container Registry, where you might have already pushed some Docker images. And then you can bring those into your Kubernetes cluster to run those application workloads within those containers. So let's get started here with deploying AKS using the portal. I'm going to go ahead and click Create a Resource in the upper left, and I'm going to search for Kubernetes. Interestingly, the word Kubernetes stems from the Greek language, really focusing or meaning someone that's in control of something, like the pilot of an aircraft, for example. So I'm going to go ahead and specify Kubernetes, and I'll choose Kubernetes Service from the list, and I'll go ahead and click on Create. Okay, so I'm going to tie this to a resource group. I could create a new one, but I'll deploy it into an existing one. And I'm going to call this Kube Cluster 1. Now it's making sure that the name is valid. It checks out that it is valid. So then I specify the region, the Azure region, where I want that deployed. So I could choose from the list. I'm going to specify East US here. The Kubernetes version can be important depending on the type of containerized workloads you're running and where you might have previously tested those containers. You might find that it runs best with 1.16.9, or you might use one of the newer preview versions. If you're not sure, then you can try the last stable version. You may not want to go into the preview versions and then test it from there. So I'm going to leave it at the default selection. Otherwise, if you don't know what to use, that's probably the best choice. And then, of course, for the back-end agent nodes. Now, we're talking here about the workers that actually run the containerized workloads as opposed to the master nodes, which are managed by Azure. For these agent nodes, you get to specify the virtual machine sizing. And I can click Change Size. And of course, depending on the type of containerized application workloads you're running will determine what you need for horsepower. I'm just going to stick with the default selection. I can also control the node count within the cluster. So currently I've got 3. I'm going to leave that as it is. I'll click Next Node Pools at the bottom. So you've got a default agent pool here, a node pool. But if you want to, you can have multiple node pools. You would do that because you have completely different types of containerized application workloads that have different resource demands. So maybe one is very disk IO intensive, where another containerized application or set of applications is not. And so for that, you could spread out and have additional node pools configured. You can also enable virtual nodes. You would use this feature if you have the need to quickly scale app workloads by rapidly provisioning pods. A pod runs one or more container, and those containers share the resources within the pod. VM scale sets down below is enabled automatically to allow for scalability, so I'm going to leave that enabled. I'll click Next for authentication. I'm going to leave the default of using a service principal, which is an Azure AD identity that we can manage. Then for Kubernetes authentication and authorization, it's got role-based access control, or RBAC, enabled. There are a number of built-in Kubernetes roles that allow for the viewing or management of Kubernetes and clusters. Down below, I'll leave the default for the encryption type for the Node Pool OS disk encryption. I'll click Next for networking. And what's been selected down here is basic network configuration. We can also choose advanced if we want all of the network options available, such as specifying IP address ranges, which could be important. Let's say if you're linking to an on-premises network through site-to-site VPN, because you've got some containerized app components running in Kubernetes that might need to talk to something on premises, let's say maybe a SQL database. However, I'm just going to leave that on basic. I've got the DNS name prefix set here. And basically at this point, I'm going to click Next for integrations. I could integrate my Kubernetes cluster with an Azure Container Registry if I've pushed images to it. And at this point, I'm going to click Next for tagging. Not going to make any changes here. Then I'll go to Review and Create. And at this point, it's going to run the final validation. Everything will have passed based on our selection. And I'll deploy the cluster by clicking Create. After a moment, if we go to our All Resources view, we can see that we've got our new cluster. I'm just going to filter my list here for things that start with Kube, and we've got our Kube Cluster 1 shown here. We've also got a load balancer that was deployed as a result. So the load balancer is used for scalability purposes for your containerized workloads. So I'm going to click to open up the Kubernetes service so we can view the properties of it. One of the first things that we should probably point out is that if we click on node pools on the left, we'll see the node pool that was defined when we deployed the Kubernetes service. We can also click the Add Node Pool button if we want to add an additional node pool. Now, you might do that again if you've got completely different containerized application workloads that have different underlying resource needs. I'm going to click X to close that out. We can also choose to upgrade the version of the Kubernetes service. We saw this upon deployment initially, and if we decide that we want to switch to a different version, maybe for performance reasons or enhanced feature set reasons, then we can go ahead and do that. Here's our scaling option. Again, we saw that during deployment, but we can go ahead and change things like the node count if we need to. We can also go to the deployment center on the left. Now, this one's really neat because it makes it really easy to start deploying containerized applications from a number of different sources shown here into your Kubernetes cluster. So Azure repos or GitHub, Bitbucket, or an external Git repo, maybe one that you've customized yourself with customized container images. If I were to choose, for example, GitHub, then when I go down to the very bottom and click Next, it's going to ask me for permission to access my GitHub account. So I'd have to click Authorize to fill out those details. Once I've done that, I'll be able to go into my GitHub repositories and look for any containerized apps that I want to deploy here in my Kubernetes cluster. However, I'm not going to do that. I'm just going to go Previous, but we do have that option available. So that just gives us an easy way to get things up and running and going within our Kubernetes cluster. We can also issue some CLI commands related to our Azure Kubernetes cluster. So if I were to type here in the CLI, let's say AZ-AKS-H for help, and we can even pipe that to more to stop after the first screen full of output, we'll see the next level commands that would be available for AZ-AKS, like node pool, browse, create, delete, and so on. Press Q to get out of there and clear the screen with CLS. So as an example, let's run AZ-AKS list -- output table just to make it a little bit more legible. This is going to show us what we've got up and running. So we've got one AKS service called Kube Cluster 1 in the Eastern US region. We can see the resource group and the Kubernetes version. provisioning state is such that it succeeded. So we have some options available for managing our Kubernetes environment to a limited degree using the AZ-AKS command prefix in the CLI. Azure Container Instances are a managed service where you don't have to worry about deploying underlying virtual machines and containerized software like Docker. That's all handled automatically. Instead, you can focus on the containerized app itself. So to get started here in the portal, I'm going to choose Create a Resource. I'm going to search for Container Instance, and I'm going to choose Container Instances, then Create. So the first thing I need to do is specify a resource group into which I want this Azure Container Instance deployed, and I need a container name, which must be lowercase letters. So I'm going to call it App Container 1. I'm going to specify that I want this to be in a region, let's say East US, and I can select from Quick Start Images, which we have a drop-down list for down below. So whether it's based on Microsoft or Nginx in Linux or Microsoft IIS, so web servers as well, we could specify that. We can also gather or retrieve a container image from an Azure Container Registry or a public registry like Docker Hub. We could specify any private or public registry by specifying the image reference. However, here I'm just going to choose Quick Start Images. We'll stick with the Microsoft ACI Hello World Linux. We're going to leave that. I'm not going to change the sizing to support that. Now remember, even though the containerized application really doesn't contain an operating system, it runs on a host that runs an operating system. And we're actually also deploying the host to support that here, which is why we have sizing options. I'm going to leave the default, and I'll click Next. From here, we can control the network type. For example, public. Do we want a public IP address so that the container is accessible in that manner? It depends on the nature of the code running in the container as to whether or not you want it to be available in that manner. So if the nature of the containerized app is that it does have some kind of a web component, then we might want to make sure that we do have networking type set to public, if it should be accessible from public networks. We can also give it a DNS name label. I'm going to call it App Container 1. It's going to check that that name is valid, and it's going to add, in this case, .eastus.azurecontainer.io DNS suffix at the end of it. In this case, it's going to open up TCP port 80 based on my selection, the container image from the gallery that I selected. Next, I'm going to choose Advanced. I'm not going to set a restart policy other than the default of only on failure. I'll click Next for tagging. Not going to add any other tags. I'll just click Review and Create. After the validation is passed, I'll deploy this container instance by clicking Create. And before too long, it will have been deployed, and we can click the Go to Resource button to jump into its properties. So we can see in the overview blade on the right that we've got a couple of charts that are mapping CPU utilization and memory utilization, network bytes received versus network bytes transmitted, that type of thing. If I click on containers over on the left, we'll have a listing of the container that's currently being used, in this case, App Container 1, and the current state of it, which in this case is that it's running. We also have some events down here from when the container was started. We also have information related to logging. For example, if I go to logs, our containerized application is currently listening on port 80. If I click on Connect, then we can go ahead and we can make a connection to our containerized application. Now, depending on the command you're trying to connect with, it may or may not be allowed within that containerized application. If I go back to the overview blade, I can also test connectivity to the public IP address if the nature of that containerized app is that it will report something back to a web browser. In this case, when I pop in the IP address in my browser address bar, it comes back with a page stating Welcome to Azure Container Instances. So we know that it's up and running and that we have some kind of public connectivity because that's how we configured it when we deployed it. So if I go back into the container instance and go back down to containers, we've got one container here, and if I go down to logs, there will be some activity that was generated by us popping up that web page in our web browser. When we're in the portal looking at the containers in Azure Container Instances, the state will reflect whether it's running or whether it's been terminated. Currently, the state is listed as running. Well, the great thing about working with Azure Container Instances is we can even use the CLI to manage those containers, such as stopping it. Here I'm going to use, in the Cloud Shell environment, the AZ container stop syntax -- resource -- group of RG1 -- name. Our container name is app container 1. So I'm going to go ahead and press enter to stop that container. So if we go back into the portal, previously the state of that app container 1 was such that it was running. If we click the refresh button, it currently now says that the state is terminated. So we have some control here from the Azure CLI. So in this course, we've examined how to provide remote access to user desktops with Windows Virtual Desktop WVD, and how to provide support for application workloads using Azure Container Solutions. We did this by exploring how WVD permits cloud-based remote desktop access, how to create a WVD host pool, configure a remote app group, and also a workspace for WVD. We explored how to connect to WVD using a Windows client and a web browser, and we explored when to use Azure Kubernetes Service and Azure Container Instances. Next, we discussed how to create a container image repository in Azure, and we implemented it, and also learned how to publish container images to the repository. Finally, we explored how to manage the Azure Kubernetes Service and Azure Container Instances. In our next course, we'll move on to explore the planning and use of Azure DevOps services to facilitate the creation and running of web applications. Planning for applications and their design when hosted in Azure means talking about things such as microservices. A microservice is a task-specific chunk of code, so to speak, where we have multiple microservices working together that comprise a larger application. Now, this means that we should also be interested in decentralized reusable components. That's exactly what a microservice is. So, as an example, imagine that we've got a large web application where one aspect of that web app is to allow users to upload files. Well, we could have a specific microservice. It could even be a containerized application component, so running in a container. That microservice might be designed specifically to handle user file uploads. However, it plays a part in an overall larger application. So that's where we get into microservices, which are decentralized, reusable, task-specific components. Other things that we should consider with application design is decoupling. Decoupling means we have multiple microservices, for example, that communicate with one another, but we don't want to have a dependency on those microservices being available, up and running on the network, and ready to accept messages at any time. Instead, decoupling allows us to use storage or message queues, where one microservice that needs to talk to a second microservice can drop a message in the queue. And when the second microservice is available, it can read that message from the queue and process it. So there's no dependency on both components or microservices being up and running at the exact same time. Scalability and high availability can be achieved with application design by using features such as load balancers. For developer code commits and builds, we would consider solutions like Azure Pipelines. Pipelines is a managed cloud-based service in Azure that allows you to work with your code and test it, and also make it available to other developers. So that would also lend itself to working with automated testing and the ultimate deployment of applications. Multi-tiered applications allow planners of the application to separate or isolate different components or aspects of the app. For example, in our diagram on the left, we've got a load balancer, after which to the right of that, we have our front-end web servers. Now, that's not for every application, but if the application had a user interface that users interact with, then we could have that aspect of the application running on the front-end servers. And that might even be running within a VNet or subnet. After that, we have code or logic servers that actually run our code. Now, depending on how you do that, that might be a managed service in Azure, in other words, serverless computing, where we might be using Azure Functions or logic apps. The difference being that With Logic apps, there's no code to write. With Azure Functions, there's code to write. But either way, that's the code and logic server tier, which can then talk to backend storage. Now, we also would consider whether our components, so our code and logic servers, even our front-end components, might run as virtual machines, whether we set them up manually, whether it's managed, or it might be a containerized application component. The other thing to think about with code and logic servers is using another managed service like the Azure API Gateway, which serves as a proxy. Essentially, it sits between the API and where it might be called from, other application components. The idea is to have a centralized way to control and monitor and secure API access. Then there's the storage side of applications, which could include a storage account where we might have blobs. We might work with Azure Tables for simple key value NoSQL type storage. We could use storage or message queues for application component or microservice decoupling. Then we've got Cosmos DB. Cosmos DB is designed as a globally replicated NoSQL type of data store, or we might use Azure SQL Database for relational database storage. We might even consider the use of Azure Data Lake. Data Lake is really designed, as the name might imply, for very vast storage, very vast amounts of data storage, and also it even offers data analytics services. Planning your Azure App Service means thinking about the interrelated components that you might need, whether you're building custom code or using an ARM template with little changes to deploy items such as web apps. So a web application can be configured to use custom DNS domain names. That would be, instead of using the default DNS suffix, you might want to have a public-facing app that uses your organization's custom DNS domain name. You can also use deployment slots for testing. You always have a production deployment slot, but you can add one or more deployment slots, so when you do testing, you have a different URL that you publish code changes to and that you connect to for testing. And once that testing is deemed to have worked correctly, you can swap that out with production. So what was once a testing version of the web app is now the new updated production version of it. You can also configure TLS SSL bindings for your web app, so connectivity occurs over HTTPS instead of HTTP. For that, you'll need a certificate, whether you want to import a PKI certificate to an Azure Key Vault or generate a self-signed certificate directly in the Key Vault. You can do that too. You can also configure vertical scaling, the underlying horsepower to support your app, and horizontal scaling, the number of virtual machine nodes supporting the app, although technically those are items that exist with the app service plan, which we'll talk about in a second. You can also configure web jobs to automate some kind of task related to your application, such as maybe deleting files that might have been uploaded by users, if that's the nature of your app, after those files were processed and perhaps stored elsewhere. The app service plan is required for a web app. An app service plan determines which resources are available to the app, and that's really where we get into the horsepower. So that's the vertical and horizontal scaling that is available through the web app, but really links back to the app service plan. You can also have multiple web apps linked to one app service plan. Now, why would you do this? Well, as long as you know that when all of those apps are running concurrently, that your app service plan scaling can handle the workload, you might want to do that. But you could also have different app service plans, perhaps for different administrative units, if you have a large enterprise, or in different regions, or you might want to group web apps into a related app service plan. So there are many reasons why you might want to have multiple items of this type. In the app service plan, you can also view performance metrics related to the web apps as a whole, such as CPU utilization, memory utilization, network traffic in and out, to name just a few metrics. You can view file system usage per app as well. So what happens is you have to select an app service plan pricing tier. Now that will refer to what's called an Azure Compute Unit, or an ACU. This is really just a special way to refer to underlying virtual CPU performance available for the app service plan. So you can choose the dev or test pricing tier, production pricing tier, or isolated if you've got apps that need to be completely isolated from everything else. In other words, sandboxed, which is great for testing. You also have to consider webhooks. With Azure App Services, a webhook is an HTTP endpoint for external entities, and you can use a webhook to trigger something like an Azure function or even a background web job to do something for your web app. Another consideration when you're working with applications in Azure is working with components like a service bus. A service bus allows for messaging between different software app components. You can think of this as being one way of decoupling components from one another by using basically a centralized message broker. You can also work with Event Grid. Event Grid allows you to route messages to specific endpoints that are used by software components. This is all developer stuff that we would normally think about when we're developing code or making API calls. Now, an example of an event for Event Grid purposes might be a blob being uploaded to a storage account, or maybe being renamed, or a new container being created in a storage account, that type of thing. When you build your Azure App Service, you get to select the runtime stack support that you want to use. So whether you're running on Windows or Linux, when you choose a code-based app, it can be .NET Core, ASP.NET, Java, PHP, Node.js, to name a few. It could also be Python, could be Ruby, or you could choose to deploy a Docker image instead of specifying the code type for your runtime stack. You can manage your app service using the portal, also using an ARM template, using PowerShell or the Azure CLI, and also using development tools like Microsoft Visual Studio, where you could create and make updates to an app service, a web app, and then push that in. In Azure, an app service is essentially a web application, whether or not it's got a front end that users would interact with. So in this demonstration, I'm going to use the portal to deploy a simple app service. To get started, I'm going to click Create a Resource. If I were to type App Service, then I get options such as App Service Plan, App Service Environment, but I don't have just App Service. However, if I were to search for Web App, then I have the web app option. That's what I'm going to choose here to deploy an app service. Then I'll click Create. So I'll have to fill in a few details to deploy this, because bear in mind that in addition to the app service or the app itself, there's also going to be an app service plan which controls the pricing tier and the scaling options. So let's get started here by deploying this into a resource group. And I'm going to have to give a name to this. I'm going to call it Web App AZ-304, and it's going to use the .azurewebsites.net DNS suffix by default. You can, of course, configure after the fact a custom DNS name, especially if this will be a public-facing web application that your customers might actually see. So we can publish this as a standard web app using code or as a Docker container. Now, when we have it on code, we can select the appropriate runtime stack below, depending on what you're comfortable with or what your development team is comfortable with, whether it's .NET or whether it's Java using Tomcat, for example, or whether it's Node.js, PHP, Python, or Ruby. So, for example, I'm going to choose PHP 7.3. Let's assume that I want to build my web application using PHP server-side code. Now down below, I can select from Linux or Windows as the operating system. And when I do Docker container, I can also select Linux and Windows, but notice what disappears when you select Docker container is the runtime stack, because it's really up to the container image and what's inside it to determine what kind of code is running in that. However, I'm going to go back to just code, PHP 7.3. We'll let it run on Linux. I'll specify the region where I want this available. Let's say East US. And as I go down, I can either select an existing application service plan or app service plan ASP, or build a new one. I don't have any, so it wants to build a new app service plan. As we've mentioned, that handles the pricing tier and also controls resources. That would mean things like the scalable power that's available for the web apps. And you could have more than one web app or app service linked to an app service plan. So down below, we have the SKU and size, the compute size available for that app service plan. So depending on the workload you suspect will be running by your app service or app services, if you have more than one linked to the same app service plan will determine if you need to change that. And you can always change it after the fact anyway if you really needed to. So I'm going to go ahead and click Next for monitoring. I'm not going to do anything here or on the tag screen. I'll just click Next, Review, and Create. It will validate my selection, after which I can then click Create. So I'm going to click Create to get this web app or app service deployed. Take note that the app service will also be running by default in the same way that a newly deployed virtual machine is automatically running. After a moment, the deployment is complete, so I'm going to go to my notification area in the upper right and click Go to Resource to jump into our app service. In the overview blade for it, we'll have the default URL, and remember that it uses the default DNS suffix of azurewebsites.net, but that you can change that with the custom DNS name. I'm going to go ahead and copy that to the clipboard and open it up in another web browser tab. All we're doing here is verifying that our sample web application is up and running. This application happens to have a web page. A web app does not have to if it's maybe called upon only programmatically through other APIs. But we do know, in fact, that it is up and running. We can also verify here on the overview blade on the right the app service plan association for this app service. And there's a link here. If I click to open up that app service plan, it takes me into that object. It's a separate resource in Azure. And on the left, as I scroll down, if I click apps, I'll see the app services that are associated with this app service plan. There could be more than one, but there's only one shown here, the one we've just created. It's got a status of running. We can also scale up and scale out. So for example, if I choose scale up for the app service plan, this will let me determine the underlying horsepower. Here are the pricing tiers, such as dev test, production, or isolated, if you need complete isolation for testing purposes. So you can select the appropriate pricing tier underneath with the Azure Compute Unit listing, ACUs, which is really a combination of virtual CPU power and RAM. Naturally, more power means more cost, but if you need that to support your workload, there is no other alternative. You can also click Scale Out on the left and either use manual scaling or custom auto scaling to add nodes when things get busy. So we can go down and scale based on a metric, such as CPU utilization, for example, or we can scale to a specific instance count as required by the application. You could also specify a schedule if you can anticipate on a predictable basis when the application workload will be higher versus lower. In order to have an app service deployed in Azure, such as a web application, you also need a corresponding app service plan. Now, an app service plan could host multiple app services, but you're going to need at least one. Here in the portal, in the All Resources view, I can filter for type. I'm going to click on Type, deselect the check mark for Select All, and I'm going to choose App Service Plan. I'll click outside of it, and I've already got an app service plan here. I'll just click on it to open up its properties, where on the left I can click on Apps, and then I get a listing of any applications, including deployment slots, that are associated with this app service plan. On the left, I can also scale up by changing the pricing tier and also the underlying horsepower to support my web application or applications, if more than one is associated with this app service plan. I can also configure horizontal scaling, scaling out, either manually scaling or auto scaling, and even scheduled scaling if we can anticipate peak workloads. But this is all in the portal. We can also work with app service plans using PowerShell. So for example, I'm going to build a new app service plan with the new -AZ app service plan commandlet. -resource group name, in this case RG1, -name. I'm going to call this new app service plan ASP YZ173. -location will be Canada East, and the -tier parameter is going to have a value of free. I'm going to go ahead and press Enter. The free tier has options that will differ from other tiers, such as the standard tier, such as the fact that the free tier is limited to 1 gig of storage, the standard tier up to 50 gig of storage. There are many other differences as well, but that's what I've got so far. So I can run get-az app service plan to get a list of app service plans that might have been deployed. And the one we've just deployed, ASPYZ173, shows up in the list. What I can also do is manage the app service plan here in PowerShell. For example, let's say I want to change the tier. I can do that with set-az app service plan -resource group name rg1 -name of the app service plan. I have to specify that. And -tier, I would simply change, let's say in this case, from free to standard. So among other enhanced features, it will give me more storage than the free app service plan tier. So I'm going to go ahead and press enter to do that. Back here in the portal in the All Resources view, if I go into my newly created app service plan, if I were to go all the way down to the properties, we'd be able to check on the pricing tier, which is currently listed as being standard. So we can use PowerShell to create and manage our app service plans. Software developers have a wide variety of tools they can use both on-premises and in the cloud to create and test their code. One such option is Microsoft Visual Studio, which I've got running here. I've downloaded and installed the free Community Edition for Visual Studio 2019. Well, what we can do is we can actually configure and make changes to a web application for Azure here in Visual Studio and then publish it or push it up into the Azure cloud. So to get started, the first thing we have to consider is that we need to be authenticated to Azure from within Visual Studio. So to do that, if we go and take a look at the Cloud Explorer, which is visible currently right here, we have a listing of Azure resources, including app service plans, app services. I can expand and see those. And if we're authenticated to Azure, we'll see these items. But how do we get authenticated in the first place? Well, we can click the little person icon here at the top of Cloud Explorer to get a list of our Microsoft accounts. If I click Manage Accounts, it's from here that we can add the appropriate account information to link us to Azure, to authenticate to Azure. So I've already done all of that. So what I'm going to do is build a new project. I'm going to go to File, New Project. At the top, I'm going to search for Azure Resource Group, because what I want to do is create an Azure Resource Group type of deployment. So I'm going to choose Azure Resource Group, and I'll accept the default local storage location, and I'll click Create. And it's at this point I get to select what I want to use to create my new configuration. It could be a blank template, it could be a virtual machine scale set, but we're really talking about web apps. So there's some templates here. We've got web app, we've got web app plus SQL. We could build an Azure Logic app. And as we go further down, we could also have some containerized options like Docker on Ubuntu server, web app plus content delivery network or CDN. So many options. We're going to go with just a basic web application. So I'll choose web app and then I'll click OK. After that's been done in the Solution Explorer window over on the right, I've got a PowerShell script for deploying my web app, but I've also got a website parameters JSON file. So let's just double click on that to take a peek at that. So here in the parameters, we've got the hosting plan name with the value of null. We could change that and put in the name of the hosting plan we want to use. Otherwise, at deployment time, when we push it or publish it from here to Azure, we'll be prompted for the hosting plan name. Also, if I go double click on the website.json file, here's the contents of my web application. And again, we could go in and make changes as we see fit to change that application. However, all I want to do is take a look at the name of the web application here. It's going to concatenate. It's going to call upon the concatenate function. And it's going to concatenate some parameters like the hosting plan name. It's going to add a dash. And then it's going to have the resource group name. So that's part of where some of the nomenclature will come from. So once we've made changes, I'm not going to make any, and we're ready to deploy this, we can go ahead and right-click on our solution, and we can choose to deploy it. So I'm going to choose Deploy, New. We'll wait for it to determine our subscription information for our Azure account. We have the option to edit parameters here. Of course, if we want to, we can also do that as we're prompted if they're required. So I'm just going to deploy this into a resource group, after which the deploy button becomes available. And of course, we knew that the hosting plan name was required here. Here in the portal, I'm going to use a specific app service plan name. I'll just copy the name of it that I've already created previously. Go ahead and paste that here into the hosting plan name field back here in Visual Studio, and I'll click Save. So in the bottom output window, we can watch to determine the progress of deploying or pushing this app up into Azure. Now down in my output window, there's something about the deployment template using PowerShell script failed. Well, depending on how up to date the templates you use are will determine if the PowerShell commandlets referenced in the PowerShell script, the PS1 file over here in the Explorer, are valid. Let's double click on that and take a look. I'm actually going to copy that out and put it in WordPad so we have just full screen of WordPad looking at that code. So when I go through that PowerShell script, it's going to be making a reference to older versions of PowerShell commandlets. Now, as I go down and down further through it, we're going to see that some of the PowerShell commandlets are using the Azure RM nomenclature, where the newer version of the PowerShell commandlets just use AZ. So there's no Azure spelled out, there's no RM for Resource Manager. So what I'm going to do then is I'm going to do a search and a replace. So I'm going to click replace up in the toolbar. We are going to replace Azure RM with simply AZ, and we're going to choose replace all, okay. And what we're going to do is then go ahead and take all of that code and put it back into Visual Studio. We could have done this directly in Visual Studio. There's no real reason you have to do this in WordPad at all. After I've pasted that into my PowerShell script, and again, we could have just edited it here. I can just go to the File menu and save that PowerShell script. It says no issues found. So then we can try to deploy this once again. I'm going to right-click, deploy, and we want to make sure we select the same resource group. We could have selected that from the list. It remembers the recent choices that were made when it comes to deploying. So there we go, our G1. We'll deploy this, and it's on its way. And before too long, we'll have a message in the output window down at the bottom center here in Visual Studio about successfully having deployed our templates. Let's check it out in Azure. So here in the portal, if I go into the app service plan that we deployed it to and take a look at the apps blade, we'll have a reference here to the fact that we've got our application shown here. There's an application tied to this app service plan. Of course, the nomenclature we talked about was created from the concat function within our file in our template. And of course, we can test the URL for that sample web application, after which it'll pull up the default page. One of the many great features when using Azure App Services is using deployment slots. Let's explore this a little bit here in the Azure portal. I'm going to open up my left-hand navigation bar where I'm then going to choose App Services. I already have an app service or a web app up and running. So I'm going to click on it to open up its properties so that in the left-hand navigator, we can scroll down and select deployment slots. There is a default deployment slot called Production. That's the one that's currently running. If I were to go up and take a look at the overview blade for this web app, we've got a URL that we would use to connect to that app. Of course, we could also have custom DNS names, so the URL might reflect our company DNS name on the internet. But at any rate, we've got a URL for that. Well, what's interesting is you're going to have a different URL for each deployment slot you create. You might only create one more deployment slot beyond the default production one for testing purposes. And then once the testing succeeds and you're happy with it, you can swap it out with production. So let's go back to deployment slots over here on the left, where we verified that we already have a production slot up and running. I'm going to click the Add Slot button up at the top, and I'm going to enter a name here. I'm going to call this Testing. We then get to determine if we want to clone settings from the original web application or app service deployment slot, the production deployment slot. I'm going to choose to clone the settings. The settings would include things like connection strings, maybe to talk to backend databases, and any web app settings like the default homepage, that type of thing. So I'm going to go ahead and click Add so we can create our new deployment slot. So after a moment, we'll have two deployment slots. We'll have the original production deployment slot, and we'll have our newly created testing deployment slot. So after a moment, it will have created the slot. I'm going to click Close, and we have both listed as running. They have a status of running, both slots, for our web application, although under the traffic percentage column, 100% traffic is currently being routed to our production version of the slot. I'm going to click on the link for our testing slot. So I'm going to click on it. That's going to open up the properties of our testing slot. And if we look at the overview blade over on the right, the URL is a little bit different because it refers to the testing version of the app. However, if I actually, well, I can just click directly on the link. If I were to visit the URL for the testing deployment slot, it's going to look just like the original, at least at this point, because no changes have yet been made. Let's see if that's true. I'm going to close out of my deployment slot. Now I'm back in the original app. So I'm going to click Overview Blade. It's got a different URL. I'll click on it. And again, it looks the same because we've not made a change. So we've got two different URLs to reach the same app. The idea is that developers can start making changes to the app version in the deployment slot using that URL. So if they're using, for example, an on-premises development tool to make changes to the web app like Microsoft Visual Studio, they would publish the changes back to the deployment slot URL. Now, once those changes have been published, the deployment slot can be swapped out. So let's, for example, go back into deployment slots from our original app service. This is where we could see we had our production and our testing deployment slots. What we could do is click swap. So because we're currently in our production slot, the source would be testing. We want to swap our testing deployment slot with production. So any changes that we've tested and that worked out to work fine in our testing slot will now become production. If there are any changes, we'll have a summary of them down below. So I'm going to close out. Let's make a change just for fun to our deployment slot. I'm going to click on testing. Now, of course, it could be a code change at the development level, but let's say we made a change just to some application settings of some kind. Let's say I go to configuration over on the left for my web application. Again, this is our testing deployment slot as evidenced by the name shown in the upper left. And from here, I might add some kind of a connection string, let's say, for a backend database. So I'll just fill in some sample values. Of course, a real connection string has something different than the word test in it. And here I'll just use custom, although we've got PostgreSQL, SQL Azure, MySQL, and so on. Now, I don't want to mark deployment slot setting unless this connection string is specifically used for testing purposes only. Otherwise, I want it to be brought over into my production environment. So I'm going to go ahead and click OK. And I'll click Save. So we happen to have made a change to a connection string. It really could have been pretty much any type of change. So now I'm going to close out of this with the X in the upper right. That puts us back in our original web application. And we're at the deployment slots blade. So on the right, I'm going to click Swap once again. Now, the difference this time is that it's going to reflect down at the bottom that we've got a change in the source. The source in this case at the top, as we know, is our testing deployment slot where we've got the connection string. And of course, we want to make sure that we have that placed into our production slot because we didn't mark it as being sticky to the specific deployment slot option. So that's fine. I'm going to go ahead and click Swap. And once that's done, I'll just go ahead and click on Close. So we're still in our original web app. Well, we've now swapped it with our testing deployment slot. But if I were to go to the configuration of the production web app, then what we're going to have is a value for a connection string. Let me just scroll over and down here because that was done in the deployment slot. Perhaps that was a configuration change, and it was brought over into our production version of our app service. An Azure function is a chunk of code, a task-specific, self-contained piece of code that is triggered to be executed. And so as a software developer, hosting Azure functions in the Azure ecosystem is a great convenient way to work with code because it's serverless. Serverless means that we don't have to worry about setting up a server and configuring it so that it will execute the code. Instead, we just worry about the code itself. Microsoft handles the server side of things. So there are triggered events then that will execute the code. There are many different languages supported. So depending on your preference, some examples of supported languages include JavaScript, C#, PowerShell, F#, Java. There are plenty of options. Now, Azure functions don't cost anything except when they are running. So when a trigger kicks in and starts executing the code, there is a small cost associated to running or executing the function. When you build your Azure functions, you can also do what you might normally do with any environment where you write code. You can add additional functionality using NPM or NuGet packages. So examples of function triggers would include a blob upload to a storage account container that might trigger your code to run, maybe to process that uploaded blob and do something with it. Or it could be an HTTP request, or it could be a message being dropped into an Azure storage queue. It could be a message that appears in IoT Hub. You could even have a timer event as a trigger of when an Azure function should be triggered to execute. You can use the portal to create an Azure function, as pictured here in our screenshot. Now, the thing to watch out for is the trigger that will run this code. In this example, in the left-hand navigator, it is an HTTP-based trigger. We also have a run button up at the top that we can use to test a run-through of our function code. You can also use other developer tools like Microsoft Visual Studio. Here we have a screenshot of creating a new Azure Functions app or function application where we can select the trigger, whether it's a blob trigger, a Cosmos DB trigger, Event Hub trigger, HTTP trigger, and so on. As a software developer, in Azure, you can choose to create an Azure function where you write the code, which gives you maximum flexibility, that you want triggered by something like an HTTP request or a new file showing up in a storage account. Azure Logic Apps are a little bit different. Now, they share similarities with Azure Functions in that it's still considered serverless computing, which means we don't have to provision servers to accommodate storing and running our code. But what's different about a Logic app, unlike an Azure function, is you don't need to write code. Azure functions require you to write code, whether you're writing it in C# or Java, whatever the case might be. But that's not the case with Logic apps. It's a little more visual, and we can essentially get away with creating a Logic app without writing a single line of code, actually. So there are plenty of templates that we can use, or we can build our Logic app from scratch. Just like with Azure functions, there are triggers that will determine what fires off the Logic app, and then there are actions that get executed as a result of that trigger. So with Logic apps, triggers are spawned by a certain event. It could be a schedule, so a timer type of thing. It could be new data that arrives, and that data can be passed to the Logic app actions that might process that data. Now, the data can come from a multitude of different sources, and we'll hold off on that topic for just a second until we talk about the connectors for Azure Logic apps. Now, the actions themselves occur after the trigger, and they're designed to process the data in some kind of way. It can also work with HTTP connections. The action might be to send an email notification. So one very important part of a Logic app when you design it and when you implement it is a connector. A connector provides data to the Logic app that can be processed. So that could come from Azure App Services. It could come from an on-premises file system. You might bring in data from SQL Server or from an HTTP transmission or from SharePoint server. The list goes on and on and on. So the connectors then can also provide triggers or actions, or in some cases, even both of them. It's part of the connector when you build that into your Azure Logic app. An example of this is if you're using FTP as a connector, as a source for data. So whenever files are uploaded, for example, the FTP connector will detect that, and that's a trigger that would run. When you deploy an Azure App Service or a web application, by default it uses the Azure Websites.net DNS domain name suffix. And that might be fine for internal use or testing, but if you are going to be hosting a public-facing web app that customers will see, you're probably going to want to use your company's registered DNS name that you might have registered outside of Azure as part of that nomenclature. So to do that, in the properties of the web application, we need to scroll down in the navigation bar, go down to Custom Domains. This is where we would click Add Custom Domain. We've got the default domain name using the Azure Websites.net suffix, but we want to add our own thing. So I'm going to click Add Custom Domain. And here I'm going to specify www.quick24x7test.info. Let's assume that's what we want our URL to look like for this web application. So I'm going to go ahead and click on the Validate button. We need to select either CNAME or a record, and down below there are instructions on what we need to do as we go all the way down under domain ownership. For a TXT or CNAME record, what we need to add to our DNS domain. Now this would be done outside of Azure. You would have acquired and paid for a custom domain name and have tools used by that DNS registrar, by that DNS provider, where you would add a TXT or CNAME record with these values to prove that you own that domain. So I am interested then in creating a CNAME record. So I'm going to go ahead and do that. So here in my external DNS management tool for the domain in question, where I need to prove ownership, I'm going to scroll down and click Add to add a record, where I can specify various types of records. I'm going to add a CNAME record. Back here in the portal, to prove domain ownership, when creating a CNAME record, I need to specify the host as being www and the value, which is currently the DNS name of this site. So I'm going to go ahead and place that into my external DNS tool. So now that I've got that information here, I'm going to go ahead and save that record. So I've just created a CNAME or an alias record that points to another DNS name. It's got a value. It's got the host entry for www. The value is the old DNS name. Okay, so let's check that out by going back into the portal and trying to validate the domain. In other words, having Azure check that we created that record, which proves we own that domain. Back here in the portal for the domain ownership, I'm going to go back up at the top and click Validate to get it to check. And it might not work out right away. You might have to wait for that change. But luckily for us, the domain ownership now has a check mark. So we know that it's worked. So I'm going to click the Add Custom Domain now that it's been verified. And when I've done that, I have not only the original web app name, but now I've got my custom DNS name of www.quick24x7test.info. However, it does say under the SSL state column that it's not secured. And that might be true. We're not connecting over HTTPS. If we wanted to, we could add an SSL or TLS binding. But let's go back up here to the overview blade of our web application. Now that we've added our custom DNS name, the URL actually reflects it. And if I click on that to follow that link, we now have a custom name that is linking to our Azure web application, our app service. In this demonstration, I'm going to configure an SSL or TLS binding for my app service. Ideally, you want to stick with TLS configurations on web clients or web servers since the old SSL security protocol is now deprecated. Either way, though, to get started here in the portal, I'm going to create a key vault and generate a PKI certificate that I can use to secure my web application. You might already have an existing PKI certificate. You could also import that into a key vault. So I'm going to click Create a Resource here in the portal, and I'm going to search for Key Vault, and I'm going to choose Key Vault. If you already have a Key Vault resource deployed, you can use that. You don't have to create a brand new one. I'm creating one because I don't have one at all. So in creating this Key Vault then, I will deploy it to a resource group. I'm going to give it a name of KV East 172. Now, if that name is in use, it will tell me. So I'm going to put in some other characters to make it unique while trying to adhere to my organization's naming standards for Azure resources. It's going to go, let's say, in the East US region. I'm not going to change any of the other options here. I'm just going to go ahead and click Review and Create. After running the validation, it will have passed, and I'll click Create to deploy the Key Vault. And after a moment, the deployment is complete. I'll just go to my notification icon and click Go to Resource to quickly and conveniently jump into the properties of the Key Vault. What I want to do is scroll down to certificates on the left where we could generate or import PKI certificates. I want to generate one. I'm going to give the certificate a friendly name. It's going to be a self-signed certificate where the common name or CN will equal the DNS name of the subject. I'm also going to click on DNS names and put the same thing over there, and I'll click OK. I'll accept the default validity period, and I'm just going to create that certificate. Now, if I navigate to my web application where I've already created a custom domain name, I can click on Custom Domains in the navigation bar. The custom domain name that I've already created for this app is www.quick24x7test.info. However, it says it's not secure. It's not secure with HTTPS. You need a certificate to do that, and we've just generated one in a key vault. Perfect. So what we want to do then is make sure that we've got the certificate associated with this web application, which means first thing I want to do is click TLS SSL settings over on the left, and I want to click private key certificates, and I want to import a key vault certificate, so I'll click on that link. So I've got to select the key vault here. There's the key vault that we just created, and within it, I'm going to choose the Quick 24x7 website certificate, and I'm going to choose select. So that has to be done first before we can complete the binding. So it's now been added here. I'm going to go back to custom domains on the left, and to the right of our custom domain name, I'm going to click the add binding link. And that means that I have to choose the certificate that we've added previously here, and I'll just choose the server name indicator or SSL type of connection for a TLS SSL, and I'll click add binding. After we've done that, our custom domain name will now have a secure SSL state. If we go take a look at the overview blade for our web application, it is now using HTTPS along with our custom DNS domain name. If I click on that URL, I'm going to get a not secure message because it's a self-certified certificate not trusted by the web browser. This is expected behavior. If I click details, we can still go on to the web page for the app. And sure enough, our web application is now being served up over HTTPS. Web applications or app services can be deployed in Azure through using an ARM template. An ARM template is a text file that uses JSON syntax to define resources and their characteristics that you want to either deploy or manage in Azure. To get started here in the portal, I'm going to click Create a Resource, and I'm going to search for Template, and then I'll choose Template Deployment, and then I'll click on Create. So we're going to create a template deployment here through the portal, although you can deploy ARM templates using PowerShell as well as the Azure CLI. What I'm going to do is, down under Load a GitHub Quick Start template, I'm going to open that list and I want to filter it. In this example, I'll choose 101 Web App Basic Windows. And I'm going to scroll down just like we did previously. I'll choose Select, Template. I'll specify the appropriate resource group. And just like before, there's really not much else I need to specify here. So the web app name in this case is going to use the concatenate function. The web app will start with web app and then use a unique string derived from the resource group ID. All right, so at this point, I'm going to scroll down, choose I agree to the terms and conditions stated above, and we're going to try this a second time by clicking the Purchase button. This time it looks like the validation succeeded, and in my notification area in the upper right, if I open it up, the deployment is currently in progress to my resource group RG1. And after a moment, the deployment succeeds. So what we're going to do then is just go to our App Services view to check it out here in the portal. We're going to have a new web application that's running as a result of having used that template. So it's called website, and it's got that unique string that was generated from the resource group location. If we click to open up the properties of that web application, in the overview blade, we'll see the URL listed over on the right. And if we click that URL, it'll open up the sample web page for our application. So we successfully have deployed our app service from an ARM template. DevOps stands for Development and Operations. It's really the intersection of software development and software operation, as well as software maintenance. That would mean building code and testing it, and also then packaging it up and deploying it and tracking how that code is doing, such as if there are any bugs that need to be addressed. All of this is essentially software development team management. That's really what DevOps is about. The idea is to make sure that we have the best available software product that is delivered as quickly and efficiently as possible. So we can start to manage this in Azure by configuring one or more Azure DevOps organizations, where you can work with boards that might list work items that need to be addressed to make changes to code or to web pages, and you can even automate a lot of items through a pipeline. So an Azure pipeline then allows you to work with your code builds and your code commits, and it could even be automated code testing that gets triggered when code is committed. This is all part of continuous integration and continuous deliveries, CI and CD. So Azure Pipelines is a cloud service that's available within an Azure DevOps organization. Then you've got Azure DevTest Labs. The purpose of DevTest Labs for Azure is it gives you an easy way to deploy a test environment, such as for testing custom software. So you can build lab policies to automate things like virtual machine shutdown. So if the lab is only used during certain times of the day, but you can also use your own custom images that might have your custom code running within them, either as actual code apps or within Docker. DevOps is all about merging the code building, testing, packaging, along with the operational side where we make sure that those code builds are deployed successfully to where they need to go. Now, the great thing about this is that in the Azure portal, we can work with DevOps organizations to manage code projects, code commits, code builds, and code pipelines through which we can automate our testing and our deployment of our code. So to get started here in the Azure portal, in the top center search bar, I'm going to search for DevOps, and I'm going to choose Azure DevOps Organizations. Then I'm going to scroll down a bit, and then towards the bottom left, I'm going to click the My Azure DevOps Organizations link. That's going to open up a new web browser window where I'm going to click the Create New Organization button in the center of the screen, and I'm going to click Continue. So the first thing it wants me to do is to name my Azure DevOps organization. I'm going to call this Quick 24x7. You might have multiple Azure DevOps organizations. Maybe for a large project, you might have a DevOps organization specifically for that project. You might have it by region or by software developer team or by anything like that, or business unit in some cases too. I'm going to leave this hosted in Canada Central. I'm going to click Continue. So after I've entered that in and I've clicked Continue, I've got my new project. I've called it Quick 24x7 Canada to make it unique. And at this point, we can create a project to get started within our Azure DevOps organizations. So let's say I'm going to call this Project 1. Now, if you've set up a DevOps organization based on a project, it would be kind of the top level or parent project, which might have subsidiary projects within it. In this case, I'm just going to call this Project 1, and I can set the visibility to either be private or public to anyone on the internet. I'm going to leave it on the default of private for visibility, and I'll click Create Project. In the upper right, you can click the Invite button to invite users to join this project by specifying multiple email addresses separated by a semicolon, as it says here. So that option we have available. On the left, we can also click on Repos, and we can configure some repositories or repos we want to connect to so that we have some code added to the project that developers can work with. We can also click on Commits over on the left, see if there are any commits. Of course, we don't have any code added yet, so we can't really see a whole lot related to that. We can also go to boards where we can have work items that are listed, or we can add work items to manage the project, such as changes that are required to be made to code or to web pages, that type of thing. We can even go ahead and work with our test plans. The idea with CI/CD, or continuous integration and continuous delivery, is to try to automate as much as possible by using, in this case, an Azure DevOps organization. So a lot of this is more specific to software development teams and the managers that manage those teams and projects, but this is possible using the Azure portal. Software developers are always interested in application programming interfaces, or APIs, whether they're building their own API or writing code that needs to talk to other existing APIs. So, an API is a collection of related functions that allows the control of either hardware or software services. So it exposes functionality, such as the case for virtual machines in Azure. There is a virtual machine API that exposes functions that developers can call upon to automate working with virtual machines. That's just one example. There are many other examples. So APIs are really just another way of creating and managing Azure resources. So Azure services then are exposed via application programming interfaces. Examples of Azure APIs include Content Delivery Networks, or CDNs, the Azure Storage Blob Service, Azure Compute, which would be for things like virtual machines, Azure Network, and so on. So this is not a complete list, just a tiny partial list of essentially Azure services that have API functions that can be called upon. Then there's the notion of representational state transfer, or REST APIs. REST API programming is a software design style where a web service is normally accessible over HTTP. It's not technically limited to that, but that's normally the way it's done. So you can think of REST then as being a programming style that uses specific rules that developers adhere to when they build an API that will be accessed over the network. Again, normally that would be over HTTP or HTTPS. So the Azure CLI and PowerShell commandlets you might use to work with Azure services actually use the Azure REST API under the hood. Another aspect of APIs in Azure is the API gateway. When you configure an API gateway in Azure, it sits between any APIs that might be defined, custom code in Azure, and the caller of that API, which would be another software component. So it provides API packaging, so to make it available, publishing, so it can actually be used, and documentation. So there are a number of benefits to using an Azure API gateway, one of which is throttling. Throttling means being able to monitor incoming requests to an API and controlling or limiting that rate of requests when things get too busy. So that means health monitoring is also a part of this to make sure that APIs are available and that they can be connected to. And also gathering usage analytics over time to determine, for example, if there are APIs perhaps that maybe don't need to be accessed through the API gateway or at all because they're rarely or never used. An important part of working with the Azure API gateway is working with gateway policies. These are XML files, and they are designed to control the API response to an API request. So when we have an incoming request from some code elsewhere through the gateway for one of the APIs hosted behind the gateway, the policies determine what happens after that. You can build a custom response, or you can use one of the many built-in policies. So it might be a policy related to a send request, or checking the HTTP header for a specific value, or requiring authentication with a client certificate, that type of thing. So in this course, we've examined how to utilize Azure DevOps services in planning, creating, and running web applications. We did this by exploring how to plan the application architecture, how the components of the Azure App Service work, how to deploy a web application, and how to use PowerShell to manage an Azure App Service plan. We explored how to deploy a web application using Microsoft Visual Studio, as well as using Azure deployment slots to configure web application staging. We explored Azure Functions and Azure Logic Apps and how to configure custom DNS domain names and how to configure SSL TLS bindings for a web app. We also took a look at how to create a web application using an ARM template. Next, we explored when to use Azure DevOps services for continuous integration and delivery, and how to create an Azure DevOps organization. We explored the purpose of Azure pipelines for software development. And finally, we discussed API management features such as API gateways and policies. In our next course, we'll move on to explore how to minimize the impact caused by disruptions through the use of the business continuity solutions provided by Azure, including recovery services vaults, replication and backup policies, and VM backups and replication. Disaster recovery planning is crucial for business continuity both on premises and in the cloud. As a result, there's some terms that we need to go over to make sure that we accommodate those requirements correctly. The first is the recovery time objective, or the RTO. The second is the recovery point objective, or the RPO. So with the RTO, we're talking about the organization's maximum tolerance for downtime for a given system. It also deals with the amount of time it takes to bring a system back to a functional state. That could also relate to how long it takes to get data recovered such that it's to the point where it's accessible and can be processed normally. It could also include the amount of time it takes to move operations to an alternate site, whether that alternate site is another physical location or the alternate site target is in the cloud. The recovery point objective deals with the maximum tolerance for the amount of data loss in terms of time. So it feeds directly into then how often backups need to be taken of relevant data. So for a finance server, as an example, the RPO would be much shorter than it would be for a file server containing product documentation. So if the RPO is 2 hours for the finance server, that means we need to make sure that we are taking backups at least once every 2 hours. Disaster recovery means having a planning document that deals with the recovery objective, the scope to which it applies. It might be for one server, or it might be for a business process supported by multiple servers. It could also deal with the DRP team member responsibilities, contact information, and in the case that an issue can't be resolved, there might also be escalation details, which could include talking to vendors, or which could also be the cloud service provider in the case of a service level agreement or SLA issue. The incident response plan, or IRP, needs to be in effect before incidents occur in order for it to have a positive impact. So the effects of inadequate incident response could be financial, could be reputation loss, it could affect business partnerships or contracts, and so there needs to be at least an annual review to keep up with threats that change constantly. So while the incident response plan is more about the immediate response when incidents occur, if there's an issue and the problem can't be contained, it can switch over then into the disaster recovery plan. In Azure, we have the concept of an availability zone, or an AZ. Availability zones are contained within Azure geographical regions, and they consist of one or more data centers. So an availability zone then relates to physical locations. Each of those locations has their own power, their own network environment, and their own HVAC. With Azure availability zones, in our example, we've got AZ1 on the left and AZ2 on the right. On the right in AZ2, notice that we've got multiple data centers within that availability zone. There is not a one-to-one correlation between an availability zone and a data center. So there can be replication that occurs within an availability zone. You can also spread out Azure resources to increase availability by replicating between availability zones. So some Azure resources support this, things like virtual machines, managed disks, or storage accounts where you might have enabled zone redundant storage. To keep business workloads available when there are disruptions, you can look to Azure Site Recovery. Azure Site Recovery is all about business continuity and disaster recovery. With Azure Site Recovery, we've got the cloud service model of Disaster Recovery as a Service, or DRaaS. It allows for failing services over and then failing them back. As an example, imagine that we've got an on-premises physical or virtual server that has some kind of a disruption, we could have it configured to fail over into a virtual machine in the cloud. And then when the on-premises system comes back online, fail back to it. Although take note that with Azure Site Recovery, if you fail over from an on-prem physical server to a VM in the cloud, then you won't be able to fail back to that on-prem physical server. Although for an on-prem virtual server, you could fail back to it. This also comes in the form of replicating between primary and secondary sites or Azure regions. So you might have virtual machines within Azure that you're replicating to alternate regions. Now on the failover side, this doesn't happen automatically. You can initiate failovers using the Azure portal, and when you trigger a failover, then it means that the secondary system becomes the primary target, such as for a virtual machine. You can also use the portal in order to configure failback. Now, triggering a failover is possible and doesn't require access to the primary location. That's the whole point. If for some reason the primary location is unavailable, you can initiate the failover to the secondary region. Application snapshots are also supported. That means taking a snapshot that includes the state of the app in terms of what's happening in memory, transactions in a database, disk files, and any modifications. And you can also take snapshots of Azure file shared folder contents. Azure recovery sites provide business continuity. Now, in some cases, it could be a separate physical facility. It could also be the cloud, so an alternate network location for running IT services. In the case of the Azure cloud, then we could have alternate recovery sites considered to be different Azure regions. There are a number of different server types that are supported for Azure Site Recovery, including on-premises physical servers, Azure virtual machines, VMware VMs you might have running on-premises, as well as Microsoft Hyper-V VMs that you might have running on-premises. All of these can be configured for failover into the Azure cloud. Azure Site Recovery is a business continuity solution in the Azure cloud. And to take advantage of it, you need to first begin by creating one or more recovery services vaults. In a large enterprise spread around the world, you might have a recovery services vault per business unit or per location where there are different Azure administrators. In this case, in the portal, I'm going to start by clicking Create a Resource, and I'm going to search for Recovery, and I'm going to choose Backup and Site Recovery. Then I'll click Create. So the Recovery Services Vault is where you configure things like the settings for backup of on-premises servers, SQL database servers, whether they're file servers or on-premises virtual machines into the Azure cloud. It's also where you configure backup of Azure resources to other locations in Azure, where you configure replication policies, and so on. So to get started, I'll deploy my Recovery Services Vault into a resource group, and I'm going to give it a name. I'm going to call it Recovery Vault YHZ. It's going to be in the Canada East region, so I'm just going to click Review and Create because I know I'm not going to tag it, and I'll click Create. Now, it doesn't take very long to deploy a Recovery Services Vault, so our deployment is complete. I'm going to click Go to Resource just so we can take a quick peek at some of the properties. Keep your eye on the overview blade when you work with the Recovery Services Vault because you'll have some new supported items such as Azure File Shares Snapshot Management. You can also go to Backup and get some backup overview information. Now, we've not configured it, so there are no backup alerts, there's no backup job listings, no backup items, but this will be populated over time as we configure our recovery services. Same with Site Recovery. We have no replicated items. We haven't conducted any failover tests yet. However, as I scroll down in the navigation bar for the Recovery Services Vault, under Getting Started, I could choose Backup, and I could start to configure what I want to back up, whether the workload I want to back up is running in Azure already, whether it's a virtual machine, SQL Server, file share, that type of thing. It could also be on premises, so files and folders, virtual machines, different server types. Also, we've got Azure Stack. Azure Stack is a set of services that allows you to run essentially Azure services, but on premises within your own data center. So that might even be the source of what you want to back up. So we've got a number of those items. Once we've configured backup, under backup items, we'll start to get some listings for the backup item count for the various items that are backed up into the cloud through this recovery services vault. So for SQL in Azure VM, for backup servers, backup agents, that's the Mars agent, Azure virtual machines that might be configured, we can configure backup policies over here on the left that deal with things like how long backups are retained, how often backups are taken. We can configure recovery plans, which allow us to configure things like replication between VMs. So that's the purpose of the Recovery Services Vault. You can use PowerShell to manage Recovery Services vaults and also to enable protection or backup for items like virtual machines. Here I've launched the Cloud Shell from the Azure portal. I'm going to start by creating a new Recovery Services Vault with new -AZ Recovery Services Vault, where I'll specify -name. I'm going to call it Recovery Vault 192, and I'm going to deploy that with -resource group name into RG1, and -location is set to Canada Central. So I'm going to press Enter to create the Recovery Services Vault. And after a moment, we get some returned output that indicates it was created successfully. So I'm going to run get-az recovery services vault. I'm going to pipe that to select until I only want to see the names of vaults. And indeed, we have our newly created vault, Recovery Vault 192. Next, I'll run get-az recovery services vault -name, and I'll specify the name of our vault, and I'll pipe it using the vertical bar symbol to set -az recovery services vault context. I'm pointing essentially to our recovery services vault, so subsequent PowerShell commandlets will be in the context of that vault. And I'm going to create a policy variable, $policy. So $policy equals get-az recovery services backup protection policy -name, and I want to store the default policy definition within the recovery services vault in my $policy variable. The default policy, as the name implies, is created automatically when a recovery services vault is created. Now, if I just run $policy, we can verify that it contains the policy definition for the default policy. So now I'm going to run enable-az recovery services backup protection. Resource group name is RG1. -name is the name of a virtual machine I want to enable backup for, and it's case sensitive. So I've specified the name. And the last thing I'll do is specify the policy variable, so -policy, and then our variable $policy. So I'm going to press Enter to enable protection for that virtual machine. So it returns back that the operation for configuring backup has completed. So now I'm going to create a $container variable, and it's going to store the result of running get-az recovery services backup container. The container type is Azure VM. The friendly name, WinServe 2016-1. That's what I've just enabled backup for. So I want to point to that backup item. If I run $container, it now contains the information for our backed up virtual machine, where the status is that it is registered with the Recovery Services Vault for backup purposes. Now I'm going to create a $item variable that's going to store the result of running get-az recovery services backup item -container. I'll refer to our $container variable above, and -workload type is Azure VM. Now I'm going to force a backup of that item with backup-az recovery services backup item. And -item is simply going to be a reference to our $item variable that we've set up above. So I'm enabling backup for that. I'm forcing a backup here in PowerShell. And then we have a listing about the backup status being in progress. So if I run get-az recovery services backup job, we'll have a listing of our configured backup having completed and our backup currently being in progress for that virtual machine, WinServe 2016-1. You can configure site recovery replication policies within a recovery services vault. I'm going to do that here in the portal where I've already navigated to an existing recovery services vault. I'm going to scroll down in the navigation bar until I get to the protected items section where I'll click on replicated items. To add a replication policy, I'm going to click the replicate button at the top. Now for the source, I can select either Azure or on-premises. I'm going to choose Azure. I'm going to set the source location to where I know some virtual machines exist. And then I'm going to scroll down and I'm going to choose a resource group where I know I've got some virtual machines. So I'm going to go ahead and click OK. In step 2, I'm going to put a check mark by my Ubuntu virtual machine, and I'm going to click OK. In step 3, for settings, we have to determine some details about the target location. The default target location selected is Canada East. We could choose something different, but I'm going to leave it on that. For the target subscription, I could click the Customize link. We only have one subscription available here, so there's really no need for us to have done that. And as we look down below, we have the option of choosing to create all of the target resources. I'm just going to scroll down. We have a button with that same name where we have the target resource group name being shown, the target virtual network, a cache storage account to be used for staging. We have the replica managed disk, and we also have a replication policy with a default 24-hour retention policy that we can customize. I can click Customize to configure this replication policy in further detail. So maybe I'm going to create a new replication policy. The name will be 3 days. And I'm going to set the recovery point retention period to 72 hours. I can also set the frequency for application consistent snapshots. Let's say reduce that to every 2 hours. And I'm only dealing with a single virtual machine, so I don't have to configure anything related to multi-VM consistency. So I'm going to go ahead and click OK. So now we've got our replication policy that has been customized. And we've got, for example, 72 hours for the recovery point retention period now listed. I'm going to go ahead and click Create Target Resources. So the target resources will be enabled for this virtual machine, and it's going to be using our custom replication policy settings. Microsoft Azure Backup provides data availability by backing it up into the Azure cloud, and there are many ways that can be done. So from an on-premises standpoint, what's supported are files and folders, so file servers. Any on-prem Hyper-V and VMware virtual machines can be backed up into the Azure cloud. Any on-prem servers like SQL, Exchange, SharePoint, you can back up the system state of a machine. In the example of a Microsoft Active Directory domain controller, the system state would include things like the registry and its configuration settings on that machine, as well as the Active Directory database, the sysvol, and so on. You can also back up a bare metal configuration. Bare metal recovery means you're backing up the operating system and its configuration. You're not backing up data. The idea being that if there's a problem, for example, with the virtual machine that won't start up, you can recover it from bare metal. That way, we could have the server up and running and then place the data back on it. With Microsoft Azure Backup, you need to download, install, and configure the Microsoft Azure Recovery Services Agent, otherwise called the MARS agent. Now, this is an application that you run. It's an agent that allows for the backup between on-premises and the cloud, and the tail end of that MARS agent installation also prompts you to register the server with a Recovery Services Vault. So that way we have our connectivity between on-premises and the Azure cloud for backup purposes. With Azure Backup, we can back up Azure virtual machines. So backing up Azure virtual machines in the cloud to an alternate region in the Azure cloud. That's a possibility. Or you could back up Azure SQL database tables, or the contents of an Azure Files shared folder. So the process for setting up Azure Backup, for example, for an on-prem Windows file server, would be to make sure you first have a Recovery Services Vault. This is a part of Azure Site Recovery. Next, you would download and install the MARS agent. You can even do that as part of the process within the Recovery Services Vault when you are configuring backup. Then you install that agent on the on-prem server And at the tail end of it will allow you to register that server with the Recovery Vault to establish trust. After which, in the case of a file server backup, you could then schedule backup of certain files or folders on that on-prem host to be backed up into the Azure cloud. Within a Recovery Services Vault, you can choose to build a custom backup policy so that you can control things like backup frequency and retention time. To get started here in the portal, I've already gone to the All Resources view, and at the top, I've already filtered by Recovery Services Vaults. So that's the only thing that we're looking at. So I'm going to open up an existing vault called Recovery Vault Y8Z2. When I open up the properties of that vault, I can scroll down in the left-hand navigator here, and under Manage, I can choose Backup Policies. There will be two policies here by default. The first is called Hourly Log Backup, and that applies to SQL servers running within Azure virtual machines. The second policy is called Default Policy, and it deals with Azure virtual machines. So what I'm going to do is add my own custom policy, which I'm going to design for Azure virtual machines. It could also be for SQL Server in a VM, Azure File Share, or SAP HANA running in an Azure VM. I'm going to choose Azure Virtual Machine, and the first thing I'll have to deal with when I create the policy is giving it a name. So I'm going to call this VM Backup Policy 1. The frequency here can be set to daily or weekly. I'm going to leave it on daily, and I can also set the time every day. So maybe if the workday in our time zone ends at 5 p.m., we'll start this at 6 p.m. So we can choose a specific time zone if we want, or we can use UTC, which I'm going to stick with. We can also determine how long we want to retain instant recovery snapshots for. I'm going to change that to a value of 5 days. And then down below, we have the retention of the daily backup point, which is currently set to 180 days. I'm going to leave that. I could also turn on retention of the weekly backup point. I'm going to turn that option on as well. And I'm going to go ahead and click Create. Then I'll click the X in the upper right. And within our list of backup policies in our Recovery Services Vault, we now have our custom backup policy for our virtual machines. So what this means is that when we go to enable virtual machine backup, we will be able to specify that we want to use that specific policy. As an example, here in the Recovery Services Vault in the left-hand navigator, I'm going to click on Backup. And let's say I were to choose that my workload is running in Azure and it's a virtual machine. When I click the Backup button, the next thing I can do is select from the policy drop-down list. And that's where I would see my VM Backup Policy 1. In this demonstration, I'm going to enable Azure Virtual Machine Backup in a Recovery Services Vault. So the first thing I'll do here in the portal is I'm going to open up an existing Recovery Services Vault. Now within the properties of that Recovery Services Vault, in the left-hand navigator, I need to scroll down until I get to the Getting Started section where I will click on Backup. On the right, I'm then asked where the workload is running that I want to back up, whether it be Azure, Azure Stack, or on-premises. In this case, it's going to be Azure. Now, when I make that first selection down below, for what do you want to back up, it can be a virtual machine, SAP HANA in an Azure VM, SQL Server in an Azure VM, or an Azure File Share. In this case, I want to back up in a virtual machine, so I'm going to choose Virtual Machine. And then down below, I'm going to click on the Backup button. So the next thing I have to do is select a backup policy. The default policy, which is automatically created within a Recovery Services Vault, is selected. And I can see below the backup frequency. In this case, it's daily at 10 p.m. And I've got instant restore, recovery snapshots that are kept for 2 days, and so on. From that drop-down list, I'm going to open it up and choose a custom backup policy that I've created that has a different daily backup frequency and a different amount of days for retention of the instant recovery snapshot. Once I've done that, down below, I have to add one or more virtual machines that I want to enable backup protection for. So I'm going to go down and click the Add button in the bottom left. Here I've got a virtual machine named Ubuntu-Serve1, that is in a resource group called EastRG1. So I'm going to go ahead and put a check mark next to that virtual machine, and I will click OK. Then I'll click the Enable Backup button in the bottom left. So after a moment, I'm going to go to the Backup Items blade, where I have a listing for Azure Virtual Machine, which has a backup item count of 1. So that's the virtual machine that we've just enabled for backup. If I click on it, we'll get the identity of it, which indeed is our Ubuntu-Serve1 virtual machine. The backup pre-check is passed, but the last backup status is still warning initial backup pending because it's not yet occurred. Now we could click directly on that entry and we could choose Backup Now. We're then asked how long we want to retain the backup until. I'll accept the default value and I'll click on OK. And in our notification area in the upper right, it has triggered the backup successfully for our Azure virtual machine. And after a few minutes, if we click refresh, we'll have the last backup status of the virtual machine listed as success. At this point, we could click to open up that successfully backed up Linux host. We've got a file system consistent snapshot shown down below. And at the top, we could choose to backup now, which we've already done to trigger the backup. We could restore the entire VM. When I click Restore VM, I then have to select a restore point. So I'll select the restore point and OK. And then I've got to specify some details, such as do I want to create a new virtual machine or replace the existing one? We also have the other option of file recovery up at the top. Now, when we go with file recovery, we can click the download script button, which will generate a script. In this case, because it's Linux, it will be a Python script, and then it will generate a password that we're going to be required to run that script. It'll mount the snapshot so that we can browse it and then copy the files from it that we wish to restore. You can enable backup for on-premises servers so that they are backed up into the Azure cloud. Now, you first need a Recovery Services Vault for that to occur. So here in the portal, I've got a Recovery Services Vault named Recovery Vault YHZ2 that I'm going to click on to open up to enable backup of an on-premises resource to Azure. So to do that, I need to scroll down in the navigation bar for the Recovery Services Vault, and under Getting Started, I'm going to choose Backup. Now on the right, I'm going to have to select where the workload is running. In this particular example, I'm going to choose on-premises. And from the drop-down list below that, I can select Files and Folders, Hyper-V or VMware Virtual Machines, SQL Server, SharePoint, Exchange. I can back up the system state of an on-premises host or perform a bare metal backup to support bare metal recovery. So in this case, I'm going to choose Files and Folders. After which, I'm going to click the Prepare Infrastructure button. Now, the next thing I need to do is to download the Mars agent, the Microsoft Azure Recovery Services agent, on my on-premises Windows Server or Windows client. So on my on-premises file server, I've got the Mars agent installer, which I'm going to right-click on and choose Run as administrator. So I'm installing the Mars backup agent, which at the end will allow me to register this server with the Recovery Services Vault. So I'll accept the defaults for the installation folder and the caching location. For files being backed up, I'll click Next to continue on with the wizard. I don't have a proxy server I need to go through to get to the internet. I'm going to tell it I don't want to use Microsoft Update. I'll click Next, and I'll click Install. And then I will click on Proceed to Registration. Now, in order to register this server with the Recovery Services Vault, I need a Vault Credentials file, and we can acquire this back in the portal. So let's switch back there for a second. Okay, so we had downloaded the agent for Windows Server. Next thing is to download the Vault Credentials. So we'll tell it that we already installed the agent, so I'm going to click the Download button to do just that. And I'm going to go ahead and save the Vault Credentials file in a location where it can be read by my on-premises file server where I've installed the Mars agent. During the installation, you can register the server with the Vault. You can also go into the Azure Backup tool, as I've done here, and click Register Server over on the right. Either way, you'll need to specify the Vault credentials. So you would click Browse and browse your local machine to determine where that Recovery Vault credentials file is. Then you would go through and open it and continue through with registering the server with the vault. You can then either specify a passphrase or generate a passphrase and store it. And this is going to be used to encrypt your backups for safekeeping. Once that's done, in the Azure Backup agent on the on-premises server, in the Actions panel on the right, you can choose to schedule a backup. Now from here, you can go with an existing backup configuration if you've got one, so you can modify it. So I'm going to go ahead and just do that and click Next. So basically, we can click Add Items, and for our on-premises server, we can decide which items we want to choose to back up to the Azure cloud. After which, we can determine the scheduling, in this case at 5:30 p.m. daily, although we could select weekly, and you can have up to 3 backups per day. I can accept the defaults for the weekly, monthly, and yearly retention, and then I'll click Finish. That just configures the backup schedule. At any point in time, you can choose Backup Now over on the far right to follow through and perform an actual backup to the Azure cloud. Now back here in the portal, in the properties of a recovery services vault, if you go to Protected Items in the Navigator and click on Backup Items, you will have an entry for Azure Backup Agent, meaning the backup item count should be at least 1. It would be more than that if you already had other backup agents. And if I click on that, the identity of the server will then be revealed for the backup agent. In this case, it's WinServe 2016-1. The backup item was on drive C. We also have some date and timestamp information for the last backup. So we can click on that to view some details, such as the fact that we have 2 recovery points, which implies that 2 backups have occurred so far. In order to back up an on-premises file server to Azure, you have to have installed the Mars agent on it and registered it with a recovery services vault. Now that's already been done, and a few backups of the file system on the server have already been taken. So we can restore or recover data from the backup in the cloud back to our on-premises server, whether it's physical or virtual. Doesn't make a difference. So here on my on-premises file server, I've got the Microsoft Azure backup icon on the desktop because I've installed the Mars agent. What that's going to do is take me in and show me any backup jobs that have completed. So I also have some details shown down at the bottom about when the next backup will occur. So I have the option in the Actions panel over on the right then to click Recover Data. And when I do that, I specify that it's for this server. So this is the server on which the backup was originally created from. I'll click Next. I can select to recover individual files and folders, or an entire disk volume or system state. In this case, I've backed up individual files, so I'm going to leave it on individual files and folders. And I'll click Next. I have to select the volume. It knows that I backed up files on volume drive C. Then I get a schedule where any days that show up in bold have recovery points on those days. When I select that day on the calendar on the right, I can select from a variety of times if there are multiple backups that were taken. After I've done that, I can then click the Mount button. What's going to happen is it's going to mount that as a temporary file system where I can then go through and copy the files that I want to restore from that backup. So I have a message about the recovery volume having been mounted as a disk, specifically drive F. So if I were to take a look then at the file system on this server, I will now have a drive F, which is my backup volume. If I go into it, I can see I've got a projects folder, and here I could take the appropriate files that I want to restore and copy them and paste them where they need to go. However, after I'm finished with that data restoration, then I can click the Unmount button to unmount, in this case, drive F, because I'm finished with the recovery. And so we then have a listing in our jobs for a recovery job that has completed successfully by recovering data that was backed up into the cloud through Azure Site Recovery. One way to protect important workloads running within Azure virtual machines is to enable Azure Virtual Machine Replication to a secondary region. Then if you've got a problem in the primary region, you can initiate failover to the secondary copy, so to speak, of that replicated virtual machine. In this particular example, I'm going to go into the properties of a virtual machine and enable replication. To do that, let's open up an existing VM Now, what you want to do in the navigation bar for that VM is go all the way down to the Operations section. So I'm going to scroll down, go all the way down to Operations, where I then want to click on Disaster Recovery. When I click on Disaster Recovery, I'm then going to be presented with a geographical map down below. Now, I'll see the source region here shown as a blue locator icon, and I can see the selected target region, although available target regions show up in green. The selected target region that was auto-selected is purple. And if I go ahead, I can choose Review and Start Replication in the bottom left. So I'm going to go ahead and accept that default selection. What it will have done is picked another Azure region that's near the region where the virtual machine is currently deployed. So down below, I've got the target settings for the target virtual machine in the target or secondary region. So the target will create a new resource group and also a new virtual network, and that's expected. We also have to bear in mind that it's also going to replicate any disk that the virtual machine has. So we have the source managed disk reference and the replica managed disk, so a new disk will be created. The default replication policy is a 24-hour retention policy. So having accepted that, I'm not going to make any changes to those settings. I'm going to click Start Replication. So depending on how big the virtual machine is, how many disks it has, and the network latency to the target region will determine how long this process takes. After a few minutes, if you go into the properties of your virtual machine and once again into disaster recovery, you're going to see this screen where we can see that the replication is healthy. The status is that the virtual machine is protected. And we can also click on properties over on the left to get some properties about this. The active location currently, for example, is the Canada Central region, but the target location or target region is shown here as Canada East. If I click on Compute and Network on the left, I have the source settings as well as the target settings for things like the network configuration and the sizing of the virtual machine and the resource group. And if I click disks, in the same way, I've got the source and target disk information. In this case, we only have an operating system disk for our virtual machine. We also see the replica disk name. You can conduct a virtual machine recovery drill in the Azure portal really just to validate that your replication of a virtual machine to a secondary region is working correctly. Now, in order for this to work, you have to have first enabled disaster recovery for the VM. In other words, you have to have enabled replication to a secondary region. So here in my virtual machine properties in the portal, I'm going to scroll down under the operations section and click on disaster recovery. Now, because replication has already occurred, I have the test failover button available up at the top. So you can run a test failover on one virtual machine like I'm doing here, or you could do it for multiple virtual machines by configuring what's called a recovery plan. You would do that in your recovery services vault. So I'm going to go ahead and click test failover. So the failover will be from Canada Central, the active region, to the target of Canada East. I can select a recovery point and an Azure virtual network. So I'm going to go ahead and choose a virtual network, and I'm going to click OK. In the notification bell icon in the upper right, we can see the test failover for our virtual machine has begun. The idea is we want to make sure we can fail over to another region and still maintain connectivity to the virtual machine and any workloads it might be housing. After the failover has completed, the test failover, we're going to get this message that gives us a breakdown down below of the prerequisites for the test failover having completed successfully, creation of the virtual machine, prepping of it, and then actually starting the VM. So I'm going to close out of that, and I'm going to go to the virtual machines view. What we're going to notice in the virtual machines view is the original server, WinServe 2016-1, is still running in the source region, in this case, Canada Central. Now, when we tested failover, what happened is it created a new VM called WinServe 2016-1, and it added -test to the end of it. And that's running in the Canada East location. So we would open up the test virtual machine and do whatever we needed to do to ensure that we had connectivity to it. Now, that might mean configuring a public IP address for it, or simply accessing a workload that might be running inside the VM, even through a private IP address if that's required for internal connectivity in Azure, whatever the case might be. But at any rate, we've got the test failover completed. So I'm going to go back into the original source server, and we're going to go to where we went to originally enable that failover. So that was by going all the way down in the properties of the source virtual machine under operations and going into disaster recovery. So because we've already begun a test failover, the test failover button is grayed out. However, we do have a cleanup test failover option. So once we've ensured connectivity to the target VM in the target region, we can choose to clean up the environment, add notes, turn on the check mark stating testing is complete, and to delete the test failover virtual machines, and I'll click OK. So in this course, we've examined how to plan and use the Azure Business Continuity solutions, such as Azure Site Recovery Services, backups, and replication, to help minimize the impact caused by service disruptions. We did this by exploring disaster recovery terminology and planning the use of Azure Site Recovery Services, how to use the portal and PowerShell to create a recovery services vault, how to configure site recovery policies, looking at the Azure Cloud and backup options, and we also explored how to create a backup policy. Next, we looked at how to back up an Azure VM, back up on-premises files to Azure, and restore backed up files from Azure. We explored how to configure Azure VM replication to a different Azure region, how to run a VM failover test and then execute cleanup of that test, and finally, how to reuse a VMOS disk and attach it to a new VM. In our next course, we'll move on to explore the use of Azure Load Balancer, Application Gateway, and take a look at how to improve application performance and availability using services such as Traffic Manager. The Azure Load Balancer takes incoming app traffic initiated from clients and distributes it to back-end servers. You can configure a public load balancer, such as for a public-facing web application. That means that the load balancer would have a public IP address that DNS names must resolve to. Or you could have an internal load balancer that you might use to load balance an internal line of business app used by employees within the organization. So with the public load balancer, as an example, we would have a DNS name such as www.quick24x7.com. That would need to resolve to the load balancer public IP address, which in turn would then route the traffic to a back-end virtual machine pool. So each of the virtual machines in that back-end pool would be hosting the same web application. Now, the back-end pool could consist of a single virtual machine, which doesn't make a lot of sense for load balancing. The idea is to have multiple VMs serving up the same app, but it could be. Naturally, you would normally use multiple virtual machines. You could point your backend pool to an availability set or to a virtual machine scale set. The other interesting thing to note about this is that each of the backend virtual machines can also be distributed across different availability zones to achieve even higher availability. You already have high availability with the load balancer when you have more than one backend VM, because if one goes down, the other one is still running to service client requests. It could be more than two virtual machines, of course. So to make this work, you need to configure load balancer rules to control the traffic distribution. It really determines how the traffic is sent to the backend VMs. Now, that would control things like the backend listening port number, such as for a web app. So it might be different than what the load balancer is listening on. So for a secured HTTPS public-facing web app, as an example, the public IP for the load balancer would listen perhaps on port 443, since that's the normal HTTPS port. But the load balancer rules might direct that to a different port number in the backend VM pool, maybe port 440 or something different. It doesn't have to be different, but it can be. Also, session IP affinity can be configured. Sometimes the nature of an app is such that once a connection is made to a backend VM hosting that app, for the duration of that session, the same VM must be contacted in the backend pool. So that also can be configured. You can enable inbound NAT rules, essentially for port forwarding from the load balancer IP address with a front-end configured port number on that IP, which allows connectivity to back-end instances or virtual machines. So you would do this, for example, for virtual machine management. So the load balancer would have, for example, a public IP address and a port number that gets port forwarded to a virtual machine back-end port. This would allow you to go through the load balancer to directly manage back-end VMs for management purposes. Otherwise, you could use other solutions like maybe signing in through a VPN before gaining access to the private IP VMs, or maybe even using Azure Bastion as a jump box solution. In this demonstration, I'll be deploying a standard Azure load balancer using the portal. Now, before we jump into that specifically, here in the portal, I've already gone to the All Resources view and filtered it out to show that I already have a virtual machine scale set called Scale Set 1. If I click to open up the properties of that VM scale set, we'll be able to go down and click on Instances, and then we'll get a sense of how many instances are supporting this scale set. On the right, we have 2 virtual machine instances that are listed as running for this scale set. The reason this is relevant is because one of the sources you can select as the back-end pool for your load balancer is a virtual machine scale set. Presumably, each of these virtual machines might have been created from a custom image that has the app software loaded in it that you're trying to load balance. So I'm going to go back to Home, and I'm going to click Create a Resource. And I'm going to type in Load, and I'm going to choose Load Balancer, and then Create. So I'm going to deploy this into a resource group, and I'm going to specify a name for this. I'm going to call it LBYHZ2. I can determine the region where I want this. So in this case, let's say I want this to be in East US. So I'm going to choose that region. It's going to be a public-facing load balancer. In this example, that means we're going to need a public IP address for the load balancer. Down below, it wants us to create a new public IP address resource. Let's call it LBYHC72_pub IP. As I scroll further down, we're going to leave that as a dynamic public IP address assignment. No need for IPv6 in this example. I'm just going to click Review and Create. It's going to validate my choices, and then I can click Create to deploy the load balancer. But we're not finished, because we have to go in and configure it further to point to some kind of a back-end source, some back-end virtual machines. In our case, that's going to be the virtual machine scale set. After a moment, the deployment is complete, so I'm going to click Go to Resource, because we know we have more work to do. So if I click on front-end IP configuration over on the left, this is already taken care of. We've got a public IP address resource associated with our load balancer front end. But the back-end pools we need to deal with. I'm going to click on back-end pools. Nothing is shown. So I'm going to click the Add button. From here, I'm going to specify back-end pool 1. For the virtual network, I'm going to choose my scale set virtual network. When I deployed my virtual machine scale set, I actually put it or placed it into its own VNet. It's using IPv4. So then from the associated to drop-down list, I could choose virtual machines or virtual machine scale set, which is what I want to do. And I can choose the virtual machine scale set from the drop-down list. In this case, it's called Scale Set 1. And from there, I can choose the IP configuration for IP addressing for the scale set. So I'm going to go ahead and click Add to add that as a backend pool for my load balancer. The next thing I need to do is to configure health probes. I'll click Health Probes because we want to make sure our load balancer is periodically checking on the health of the VMs within the backend pool, within the scale set in our case. So I'm going to click the Add button to add a new health probe. I'm going to call it HP1, Health Probe 1. And it's going to use TCP port 80. That's what it's going to try to talk to the backend VMs on. The interval is every 5 seconds, and after 2 consecutive failures of trying to reach a backend VM on TCP port 80, it will be deemed unhealthy, and therefore the load balancer will not route client requests to it. So you have to make sure port 80 then is available on those backend hosts in this particular case for this health probe. I'm going to go ahead and click OK. So after a moment, our health probe will show up in the list. Next thing we have to do is configure a load balancing rule. So I'm going to click Load Balancing Rules over on the left and click Add. We have to tie a link, if you will, between the front-end IP address and listening port and then the back-end port number information on the hosts to support the app. So I'm going to call this Rule 1. It's going to be for IPv4. Our front-end IP address is already selected in the list. And what we're going to do is configure this to be listening on TCP port 80. So just an HTTP-based application. The backend port is on the backend VMs. It doesn't have to be listening on the same port number. It can be. And in this case, we'll just leave that on 80. We've got the backend pool selected from the backend pool list. And of course, we've only got one health probe, so that's automatically selected in the health probe list as well. For session persistence or session affinity, I might choose, for example, client IP, so that once a client session is established with the backend VM and the backend pool, the VM is going to remember that client IP, and so therefore it should be tied to that same VM. You might require that for some applications. Then I'm going to go ahead and click OK. So at this point, we've got a functional load balancer. What we have to bear in mind is if I go to the overview blade of the load balancer, in this case, we want to make sure that the load balancer public IP address, we can see a link to it right here, we want to make sure that that is what gets resolved for whatever name is being used to reference to the app. Now, those virtual machines in the scale set will not show up in your normal list of virtual machines. And that's because they're tied to the scale set and they show up within its properties as instances. One interesting way to deploy an Azure load balancer is from an ARM template. And we can deploy that template using the CLI, PowerShell, or as we're going to see, using the portal. So here in the portal, we're basically going to start off with the basic template deployment. And to do that, I'm going to click Create a Resource, going to search for template, and I'm going to choose template deployment, and then I'll click Create. Now from here, we're going to have some standard template options, such as building our own template in the online editor directly here in the portal, so using JSON syntax, or we can choose from common templates, but there is no load balancer in the list of common templates. So therefore, down at the bottom, in the Load a GitHub Quick Start Template section, I'm going to click to open up the drop-down list. And what I'm going to do is search for the word balance. And we have a number of load balancer templates that we can select from in the list. In this case, I'm going to choose 101 Load Balancer Standard Create. So I'm going to select that template. And down below, I'm going to choose Select Template. We could also edit it if we wanted to tweak it. Now from here, we are presented with some values, parameter values we need to supply. Depending on the ARM template you select will determine how many of these items you have to supply, if any. Sometimes you get an ARM template that might have everything hardwired into it. But in this case, it's not hardwired into it. So notice at the top, we could also edit the parameters or even edit the JSON for the template itself. However, here I'm just going to fill in the blanks. So I'm going to select a resource group for this deployment, existing resource group. I can also go down and specify the name of the project. Now, you may wonder what project name is. Well, if you hover over it, the creator of this template has provided a description here, specifies a project name that is used for generating resource names. So I'm going to use a project name of LB1 for Load Balancer 1. I'll specify a location, and I'll specify an admin username and password to be used for credentials for the backend VMs. And then I'm just going to go ahead and scroll down and agree to the terms and conditions, and I'll click Purchase. And if we open our notification bell icon in the upper right, we have a message about the deployment in progress. So we're deploying a load balancer from our ARM template. And after a few moments, we'll have a deployment succeeded message. So I'm going to click Go to Resource Group. We could also just go back home and also go to the All Resources view. That might be an easier way to look at this and maybe filter for things that have LB in the name. And we've got now a number of items like the load balancer public IP address. These are items that were created from the template. As we look further down, we've also got some virtual machines and network interfaces also using the LB1 prefix for our load balancer. So we've got 3 virtual machines here, and this is what was created from the ARM template. When we specified the project name, that's where that part of the nomenclature came from. So we've successfully deployed our load balancer environment using a template. When you configure a load balancer that sits between clients that request app access and the backend VMs supporting the app, you have to consider how you will remotely manage those backend VMs. And one option is to go directly through the load balancer where you will have configured load balancer inbound NAT rules. Let's check that out. First thing I'm going to do here in the portal is go to the All Resources view, and I'm going to filter by type. So I'll click on type at the top, I'll uncheck select all, and I'm going to check the load balancer option and click outside to apply the filter. So I've got a load balancer here called LBYHZ2. That's the one that we're going to use. So I'm going to click on that load balancer to open up its properties. Now what we want to do is scroll down and then click on inbound NAT rules. Now none have yet been configured, so we're going to go ahead then and click the add button to add an inbound NAT rule. And I'm going to call it inbound NAT rule 1. I'll select the front end IP address for the load balancer. And for the service, I'm going to choose RDP, assuming that we've got backend virtual machines supporting the app behind this load balancer that are running Windows, means we could use TCP port 3389 to make a remote desktop connection to manage them through the load balancer. So from here, we could then choose the target virtual machine. And as we go further down below, we could select the IP config for it. The private IP address is showing up for that virtual machine. The port mapping is set to default. And what that means is the backend Windows VMs that support the app behind this load balancer are listening for RDP connections on port 3389. If I choose custom, it allows me to have a different front-end port, listening port for inbound NAT connections, compared to what's actually being listened on in the backend VM. So I'm going to go ahead and click Add to create this inbound NAT rule. This isn't the only way to do this. If you need a way to remotely manage backend VMs behind a load balancer, which you would over time, you could also opt to use a VPN to get into that VNet in Azure, and then you could just remotely manage the VMs using the private IP addresses. You could also use solutions like Azure Bastion, which is considered to be a jump box solution that you would connect to because it's got a public IP, and from it, connect to the private IP of the backend VMs. The Azure Application Gateway is another load balancing solution, but it is different than a standard Azure load balancer. So while it can load balance web applications, it also has the ability to route incoming HTTP traffic based on configured rules. So for example, let's say that we have a client making a connection to www.quick24x7.com, which gets resolved to the load balancer or application gateway public IP. What can happen is we can configure a rule to examine the URL that was requested by the client. So if it's a request for media, it could be directed to a pool of backend VMs that are optimized to support media, whether it's streaming or allowing uploads, whatever the case might be. Whereas if we have /uploads in the URL, that directs to a specific pool of VMs optimized for that specific purpose. Maybe those VMs use some kind of optimized shared storage in a large capacity sense. So that's what the application gateway can do when it comes to HTTP URL routing decisions that a standard Azure load balancer cannot. The application gateway supports end-to-end SSL and TLS encryption. End-to-end meaning straight from the client all the way back to backend VMs. However, to offload the processing work of dealing with encryption and decryption for SSL and TLS, you can also enable SSL TLS gateway termination at the application gateway. And so what that means is the client traffic to the application gateway is protected over an HTTPS connection, but from the app gateway to the backend VMs, it is not. That's on a protected network that might be acceptable, and it would also reduce the processing workload on those backend VMs. Auto-scaling is supported for scaling out or adding nodes. User session affinity is also supported if you've got an app whereby the nature of it is that connected clients need to maintain a session to the same backend VM. And you can also link up to 100 websites to a single Azure Application Gateway instance. But another aspect of the application gateway, depending on how you configure it, is going to be the Web Application Firewall, or the WAF. This is part of the Azure Application Gateway, and a Web Application Firewall is designed to protect the web-based application from common types of attacks, which are based on OWASP rule sets. OWASP stands for the Open Web Application Security Project. This is a nonprofit international organization that's focused on protecting from common web attacks. So these common web app exploits might come in the form of cross-site scripting attacks or injection attacks, which might reveal more information than was intended by the developer, or directory traversal attacks that might allow access to parts of the web server file system that were not intended, that type of thing. In this demonstration, I'll be using the Azure portal to deploy Application Gateway. Application Gateway is a load balancing solution, but unlike a standard load balancer, Application Gateway can make path-based decisions for routing client traffic to backend hosts. Plus, not only that, it has the ability to protect against common web exploits for web applications because of the Web Application Firewall option available. So to get started here in the portal, I want to first look at the network layout that will be used by Application Gateway. I've got a VNet called ScaleSetRG VNet. If I click on that to open it up and then click on subnets on the left, I've got two subnets, the default subnet and one called subnet 2, which has nothing in it. We need a dedicated subnet for Application Gateway, so I'm going to associate it with subnet 2. So let's go back to home here in the portal and click Create a Resource, and I'm going to search for Application, and then I'll choose Application Gateway, and I will choose Create. We're going to have to do some of the normal stuff here, like specify the resource group into which we want Application Gateway deployed. We also have to specify things like a name. We'll call this App GW1, App Gateway 1. And for the region, let's say we're going to put this in East US. I do want to enable auto scaling, so I'm going to leave the default for the minimum and maximum scale units. That's not the number of VMs, it's just a unit of measurement for auto scaling, where 0 means auto scaling is enabled all of the time. And then down below, I'm going to tie this to an existing virtual network, in this case, ScaleSetRG-VNet. That's the one that has subnet 2 in it, which currently has nothing in it. So that's going to be dedicated for Application Gateway. Now, if we go back up here, notice that the tier defaults to standard v2. We can opt to use a Web Application Firewall tier, such as WAF v2 as well, if we want that capability. And then down below, for the firewall mode, we can determine if we want it just to detect anomalies or detect and take corrective steps to prevent further infiltration. So we have a couple of those options. I'm going to go ahead and use the WAF v2 tier in this particular case, and I'm going to click Next, Front Ends. So I'm going to choose a public IP address for the Application Gateway. Now, any that are available will be shown here, but these are all under the category of cannot be associated with this Application Gateway because they're already being used by something else. So I'm going to click Add New. It's going to be App GW1_pub IP. That's going to be a statically assigned public IP address, so OK. I'll click Next for backends, and I'll click Add a Backend Pool. I'll call it BE Pool 1 for Backend Pool 1. And then for the target type, in this case, I'm going to choose Virtual Machine Scale Set, and I'm going to choose Scale Set 1. Then I'm going to click Add. So that's a pre-existing virtual machine scale set that I've already configured. That virtual machine scale set would have been created from a virtual machine image, perhaps a custom one that has the application files in it that we're trying to serve up through the App Gateway. So I'm going to go ahead and click Next for configuration. So we've got a front end, we've got a back end pool, but what we don't have is a routing rule, and you need one. So I'm going to click Add a Routing Rule. Remember, this is one of the ways that the App Gateway is different from a standard load balancer. It can make routing decisions based on, for example, the URL. Let's call this Rule 1. Let's call this Listener one, and we'll associate our public front-end IP address, let's say HTTP over port 443, HTTPS rather, port 443, or we could use just HTTP port 80, whatever the app is listening on, or we want it to be configured to listen on. So in this case, if there's no requirement for security, if it's just pure documentation, that's public domain, then HTTP 80 is acceptable. So having done that, I'm going to click on backend targets up at the top here, and I'm going to associate this with our backend pool 1. And if I don't have any HTTP settings, I can click Add New. So I'm going to call this HTTP Settings 1. Again, HTTP 80. We've got options whether we want to enable things like cookie-based affinity to link client requests with backend VMs. I'm not going to change anything here, so I'm just going to go ahead and click Add. Now down below, we can also add a path-based rule. So I'm going to click the Add Multiple Targets to create a path-based rule. As an example here, I could put in a path of /vids/*. So if that's part of the request, then the target could be, let's say, we're going to call this target 1. We would then choose our HTTP settings and our backend target, which is going to be our pool, our backend pool. And I'll click Add. So now we've added a path for path-based routing. Now, presumably, you would have multiple backend pools. The one that we've selected here would be optimized to handle, let's say, requests for video media, whereas other ones might be optimized for things like user forms to be filled in on a web application server. I'm going to go ahead and click Add to add the routing rule. So we've got the front end config, the routing rule, and the backend pool. Perfect. Let's go ahead and click Next for tagging. I'm not going to add any tags here. I'll click Next for Review and Create, and we'll let it run a validation based on our configuration. The validation has passed. Azure Traffic Manager is a load balancing solution that lets you distribute app traffic across different regions. So for example, you could have web applications in different geographical locations and load balance it based on a number of different criteria, which we'll examine in a moment. So let's start here in the portal by taking a look at some existing app services or web apps that have already deployed and are up and running. So notice we have 2 of them. One's called East App 1. It's in the East US region. And the second is called West App 1, and it's in the West US region. Let's just click on the East App 1 web application. Let's just test that it's working and take a look at the homepage. I've customized the homepage. So if I click on the URL here in the overview page on the right, we can see when it opens up, it says East Web App. Okay, that makes sense. And if we were to do the same type of thing, if we were to navigate to West App 1, go to the overview blade, and on the right, we want to click the URL because we want to test that web page too. So if I click on it, notice it says West Web App. Now the idea is that we're going to configure the traffic manager with what's called a performance routing type. So the idea is that if we've got people that are in the East region, they're going to be connecting to the East version of that app. So in other words, it should pop up the East Web App page. If people are in the West region and that's closer to them, then they'll be pulling up the West version of that app. West Web App is what the page says. Now, realistically, the web app should be exactly the same in both locations. But in this case, we can easily identify which one we're connecting to. So how do we make this happen? With a Traffic Manager profile. So if I go back to the portal, I'm just going to go home here, click home, and I'll click Create a Resource. And I'm just going to go ahead and search for traffic, and I'm going to choose Traffic Manager Profile. That's what we're building here. So I'm going to click Create. I'm going to call this TM172, TM for Traffic Manager. And notice it's going to append the default .trafficmanager.net DNS suffix. You can use your own custom names if you want to configure CNAME alias records in DNS. But we're just going to stick with this for our test. Then we've got the routing method, which is set to performance here by default. And what this one means, as in our case, we've got a web app in East, we've got a web app in West. So people that are in the Eastern region coming in from that location geographically will be pointed to the East app. Likewise for the West app. However, you can also choose weighted. Now, weighted means that we assign a priority value to each endpoint, And based on that value determines how the traffic is distributed to them. So let's say we've got east and west and we assign them both a priority weight value of 1. Well, then they each get an equal amount of traffic. Or if you want one to have twice as much traffic, double the weight value. We could also use priority. Now, when you use priority, what you're really doing is you're setting one of your endpoints as the primary connection for the app. And if it's unavailable, then the other ones would be used as backups. Then you've got geographic. Now, that might sound a lot like performance, but it's different because what it's doing is it's looking at where the DNS query originates from, not where the IP address of the original client device is, but rather where the DNS query came from. Because you can sometimes have configurations whereby you might be in the south, but when you issue a DNS query, it might go through headquarters, which is in the east. So that would be seen as originating from the east region and not south. We've got multi-value. This one is used when you have backend endpoints that are using IPv4 and IPv6 addresses. And then finally, you have subnet as the last routing method. What this does is let you look at the end user connecting IP address range and then map that to a backend endpoint. So in this case, I'm going to leave it on performance and I'm going to deploy it into an existing resource group. And I'm just going to go ahead and click create. So we're creating the traffic manager profile. But once that's done, we have to add the endpoints to it. Okay, so after a moment, in our notification bell icon in the upper right, we can see the deployment succeeded. So I'm just going to click Go to Resource to open up our Traffic Manager profile. I'm interested in going down to endpoints. When I go down to endpoints, this is where I'm going to add the 2 web app endpoints. So I'm going to click the Add button. And for the type, it can be an Azure-based endpoint, which ours will be because it's an Azure app service, or it might be outside of Azure, so an external endpoint. Or it could be a nested endpoint where you can actually combine routing methods for the benefits of multiple routing method types. However, in this case, I'm going to choose Azure Endpoint. I'm going to call this East, and the target resource type will be an app service. I'll click on the target resource, and it's going to be East App 1, and no custom header information. That's it. Just going to click OK, and I'm going to click Add, and I'm going to do the same thing for the West app. So the type is Azure Endpoint. The name, let's say, is West. Target resource type, app service, and I've already got that West App 1 set up. No custom header, and I'm going to click OK. So we're just going to give it a moment here. I'm going to click refresh. So they're both showing up, but the monitoring status is checking endpoint. So it's going to be checking that it can make a connection to them, a valid connection. So I'm going to click refresh until such point that the monitoring status shows that they are both online. So we can now see that both of our app service endpoints have a monitoring status of online. Now, if we go to the configuration blade, we'll see here that besides being able to change the routing method, but we're going to leave it on performance, down below, we can see how it's monitoring those endpoints. It's using HTTP, it's trying to hit port 80, and it's going to the root of the path to make sure that those hosts are online and healthy. Probing interval is every 30 seconds. It'll tolerate a maximum of 3 failures after 10-second timeouts. So 3 consecutive 10-second timeouts. So at this point, what we're going to do is go to the overview blade. Here we're going to see the default name. It's using the .trafficmanager.net DNS suffix, and it's called TM172. So I'm going to go ahead and copy that full DNS name. Now, of course, you could go to your external DNS registrar if you have a different domain name that you want to use and create a CNAME or an alias record that points to this. But in our example, I'm just going to test it using the DNS name provided here. So we can see that if we go to the tm172.trafficmanager.net URL and we're closest to the East region, it'll pull up the East web app page. Now, we could either test this by deploying a virtual machine in the West region and attempting to connect to that same URL, but what I'm going to do here is scroll down to my endpoints back here in the Traffic Manager profile, and I'm going to click on East to open it up, and I'm going to temporarily disable it. So under Status, I'll click Disabled, and I'll click Save. So what should happen is because it's not there, the West endpoint will be used. So I've opened up a different web browser here because you want to make sure you're not viewing cached information in the web browser. So you could clear the cache and restart it and try the URL. I've just tried a different web browser here. It's the same URL up at the top, but it's now pulling up the West web app page. So in this course, we've examined a number of Azure solutions for improving application performance and availability, including Azure Load Balancer, Application Gateway, and Traffic Manager. We did this by exploring how Azure Load Balancers are implemented, how to deploy an Azure Load Balancer using the portal and an ARM template, as well as how to configure inbound NAT rules to enable back-end server management. Next, we explored the differences between Azure Application Gateway and the Azure Load Balancer. We explored how to use the portal to deploy Application Gateway, and finally, we examined how to configure Azure Traffic Manager for Azure DNS. In our next course, we'll move on to explore various methods for reducing Azure costs, including cost analysis, Azure budget notifications, and resource tagging. Optimizing your Azure monthly costs means taking a look at subscriptions. In Azure, billing occurs at the subscription level. And so within an Azure AD tenant, you could have one or more subscriptions, each of which you could say is kind of like a billing boundary. The other thing to bear in mind is we can also enable resource tagging for chargeback. As an example, when we have a project that's happening, we might flag Azure resources used for that project with the name of the project or an ID for it. That way, we can track the costs, in that example, per project. So we know that billing then is tied to the Azure subscription, where we can perform a cost analysis to get a breakdown of where the charges stem from. We can create a budget with a value so that we can get notification when we are approaching a certain value in our monthly Azure costs. We can look at the advisor for recommendations, such as for resources that are orphaned and unnecessary, an example of which might be a public IP address that's not been assigned to anything, but we're still paying for it. There are invoices that we can view details of. So there are plenty of methods that you can put into motion to save on your monthly Azure bill. You can use cool access tiers for storage if you don't need frequent fast access. You can enable virtual machine auto shutdown if it doesn't need to be running all the time, such as in a sandboxed or testing environment. You can deploy reserved instances. By doing this, you are paying either monthly or upfront for a 1 up to 3 year commitment of the use of compute services. And by doing this ahead of time, by setting up reserved instance usage, you can save 60% of what you would normally pay perhaps using a pay-as-you-go subscription model with your virtual machines. It's important to select the correct VM sizing. The VM size determines the underlying horsepower supported by a virtual machine. That means looking at the number of virtual CPUs, the amount of RAM, the number of supported data disks, and so on. You want to make sure that you size your VMs appropriately so you don't have too much horsepower that isn't required because you're paying for it. Then there's the option of scaling. With auto-scaling, we can not only scale out to add virtual machine nodes to support a busy workload, but we can also configure scaling in to remove virtual machine nodes when they are no longer needed. Each virtual machine that is kept running incurs a charge, and so it's important to remove virtual machines that aren't needed when they are not needed. In Microsoft Azure, billing occurs at the subscription level. And so when you want to analyze your monthly Azure costs, you need to look at it per subscription. Let's go ahead and do that. Let's analyze our Azure costs. So to do that, here in the Azure portal, in the center, I'm going to search for sub and I'm going to choose subscriptions. Any subscriptions that I have will be shown. I've got one pay-as-you-go subscription, and I will get a listing here for the current cost. However, to break that down further, I'm going to click on it to open it up. When I open the subscription, I can look at the overview blade over on the right to get an overall listing of the last billed invoice amount. In my case, it's in Canadian dollars, and I have the invoice time frame shown. And as I go further down in the overview blade, I'll get a listing for recent charges. Along the bottom, or the x-axis, I have the dates. Also, I have a listing of the top services by cost, shown over on the right. In my particular case, by far, most of that cost comes from storage in Azure. Now, we could click the View Details link next to top services by cost to view that in further detail. Because I might wonder, well, what in terms of storage do those charges stem from? Is it storage accounts? Is it some kind of a data lake configuration? So we can learn more by drilling into the detail. So I'm placed into some listings where I can see the breakdown by storage, backup, virtual machines, Azure Firewall, basically all of the resources I've deployed and have been working with, and I have a cost in the far right-hand column. But we could take that further. So at the top where it says View Invoice Details, what I could do is choose Cost by Resource. This way I can get more of a detailed look at exactly where those charges come from. So specifically, my largest cost is $48.12 in Canadian funds, and that stems from a resource called Data Disk 1. The resource type is a disk, a managed disk. I also have a listing for the location or the region where that exists, and the resource group into which it was deployed. If I drill down and expand that resource, so Data Disk 1, I have a listing that tells me that it's premium SSD. So that's why it gets more expensive. Now, if you need the best possible disk access in terms of speeds, then you're going to be using solid-state drives or SSDs. However, if you're just testing and you don't need the fastest disk I/O, you might go with a standard hard disk drive type of selection, which would reduce costs. So it really depends on the workload affected by the resource. If you need the power, you need the power. There's not much you can do about that. So as we drill down further, we'll have a listing for the different types of costs associated with the different classes of resources or resource type. If I click on the resource type column, for example, I can even sort by that type of resource. So I have a listing of a number of app services or web apps and the costs associated with them, which in this case are zero. So I know that's not where my costs are coming from. So that's an interesting way to view this information. We can also select an invoice from the drop-down list. So the current billing period, the last 7 days, this month. So for example, if I switch over to this month, we can see the costs broken down that way. It's always important to track these costs in detail. Firstly, to save on charges. Unnecessarily, we don't want to pay for things we don't need. And secondly, for future budgeting within the organization. We also have the option of clicking the download button at the top where we can download data as an Excel spreadsheet or a CSV, a comma-separated value file. The PNG chart download option is unavailable because of what we're looking at. So let's say we changed our listing, our view from invoice details, let's say, to daily costs. I want to see the costs broken down on a daily basis. That way I can pinpoint where most of the activity occurred to incur charges. So I have a chart up above here from May through to June, the current time frame, and it's color-coded by the resource group. So we can see that listed there. As I scroll down, I have more charts broken down by service name. So storage is where most of the cost comes from. In terms of location, the location chart shows me that most of the charges stem from the Canada Central region. And the resource group name shows me that the resource group where most of those charges stem from is called East RG1. Now, because we have more of a visual listing of charts here, when I click download up at the top, in addition to Excel and CSV, I also have PNG download charts button. So I can download that information as well to manipulate it and maybe manage it and use it for budgeting purposes locally, or maybe to email it to someone in the finance department, whatever the case might be. Azure budgets allow you to specify a ceiling value for monthly charges, whereby you can be notified when that value is reached. To configure this here in the portal, I'm going to start by searching for subscriptions in the top search field, and I'm going to select the subscription in question. I only have one pay-as-you-go subscription, and of course we know the billing occurs at the subscription level in Microsoft Azure. So I'm going to click to open up that subscription, and in the Properties navigation bar, for that subscription, I'm going to click Budgets. Now that will allow me to view any existing budgets on the right. I don't have any, so I can click the Add button at the top to create a new budget. Now when I add a new budget, I have to have a sense of what my past costs were on a monthly basis so that I can make an intelligent decision on what to configure the budget value for. So before we get to that, at the top we have to configure the budget scoping. So currently the scope is pay as you go, which means that we are looking at creating a budget that looks at the costs for all resources in the entire subscription. And that's fine. However, we could click Change Scope. And from here, we could drill down and specify that we want this to happen at a different level. So if I were to click Quick 24x7, that's root, then I've got a management group, MG1. Management groups are used to organize multiple subscriptions. So we have the option of drilling down to the management group, choosing the specific subscription that we are interested in setting this for. Now, it was already set at the pay-as-you-go subscription, but we can drill down even further and specify an individual resource group, for example, RG1. So when I select something like a resource group, it allows me to track my budget costs for only resources deployed within that resource group. We could even take that a step further with the budget scoping by adding a filter. Now, this can be important because I can look at a number of items. For example, if we scroll down, I can look at the resource location and perhaps say that I only want to look at resources within the RG1 resource group in Canada Central. So I can select that region. So my budget then will be based only on resources deployed to resource group 1 in the Canada Central region. So we can go that deep with our budget scoping. I'm going to remove that last filter and just leave it at the RG1 resource group. Going further down, what's the name of the budget? I'm going to call this RG1 monthly spend. And the reset period here, where it's going to reset this and do it again, for example, every month, or it could be done every quarter, or maybe you only want the budget to apply and be analyzed annually. So I'm going to leave it on billing month. I have the creation date and the expiration date 2 years into the future. I'm going to accept those as default values. Then I get to specify the budget amount. Now, this is what we were talking about. What should I put in here? Well, we have some help down below because I have a listing for the previous month's cost, the past 6-month cost, and also the maximum monthly forecast. It's also charted below, where forecast is a light green color. So this will help me decide what I should be putting in for a value. So as an example, I'm going to put in here, let's say $100, and it's going to be in the currency that my subscription is tied to, which in this case is Canadian dollars. So I'm going to set it to $100. Just going to scroll down and then I'll click on Next. So I can then set an alert for this. So when we get to 80% of our budgeted value, which in this case is the amount of $80 Canadian, I can have some kind of an alert or notification sent out. So we could specify an action group. Now, an action group lets you define, for example, targets like webhooks or email addresses or phone numbers that you might want to send text notifications to. So from here, I could click Manage Action Group, and I could even create an action group if I don't already have one. So I'm going to click the Add Action Group button up at the top, because in my example, I want the notification when 80% of our budget value has been reached to be texted to an administrator. So this is going to be called Cost Notifications, and the short name must be specified. It's a required field, so therefore I'm just going to copy the same thing over. And what I'm going to do down below is add an action name. It's going to be text message. And under action type, I'm going to open that up and choose email, SMS message, push voice. This is where I can specify the details, such as email, SMS text messages, and so on. So I'm going to specify the details for a text message. I'll have to put in the country code and the phone number. Now that I've done that, the short name field is giving me a problem, and it's because if I hover over it, that the display name is limited to 12 characters. So I'm just going to go ahead and put in something shorter, click outside the field. It's now validated. We've got a green check mark to the right. I'm going to click OK to build this action group. So once that action group is created, it will show up in the action groups list. So back here in the creation of the budget, now I can choose my cost notifications action group from the list, and it's got one SMS text notification that will be sent. Down below here, as we create our budget notification, we can also have alerts sent to a specific email address. So I'm going to specify an email address here. And after a moment, my budget will have been created. It's shown in the list. It's not yet evaluated my current spend against the budget value because I've just created it. Now you can create multiple budgets for different resource groups or for different subscriptions, and the notifications can go to different text phone numbers or voice mailboxes, email addresses, and so on. In Microsoft Azure, an action group is used as a notification type of mechanism when some kind of an event occurs. To get started with this in the portal, I'm going to search for Monitor in the top search center bar, and I'm going to open the Monitor service, where on the left, I'm going to click on Alerts. Now, any configured alerts that we might have already had created previously will show up here if they were triggered. We have a message stating on the right there are no alerts. Now, I'm not interested in creating an alert rule. Instead here, I'm going to click Manage Actions up at the top. Any existing action groups will be shown, and I've got a couple of them listed here. But I'm going to click the Add Action Group button up at the top, where my goal is to specify a phone number to receive text messages as alert notifications. So I'm going to call this Admin Text Notify. And I'm just going to use a short name here of Admin Notify. It's limited to 12 characters. The short name is, I'll leave the subscription as it is. I can also tie this to a resource group. So I'm going to tie this to resource group 1. And down below, I'm going to put an action name of SMS text. And for the action type on the right, I can choose an automation runbook, an Azure function. These are items that can be triggered. I can also specify emailing a specific Azure role, or just a regular email message, regardless of RBAC role, SMS text message, push, or voicemail, and other things that could be triggered, like a logic app, webhook, and so on. I'm going to choose email, SMS, text message, and I'm going to click on the right for SMS carrier. The country code is filled in. I'm going to fill in a phone number for notifications. And once I've done that, I'm going to click OK. So at this point, I've created a new action group. It's called Admin Text Notify. Now, how is that actually used? Let's take a look at that for a second. So let's close out of our Manage Actions area by clicking the X in the upper right. And back here in the Alerts view, I'm going to click the New Alert Rule button up at the top, where I'm going to use that action group. So the first thing I have to do is specify a resource that I want to monitor. So I'm going to click Select Resource. And let's say in the drop-down list, I'm going to go all the way down to the V's because I'm interested in looking at virtual machines. And I can select a specific virtual machine, let's say one of my Ubuntu Linux servers. I'm going to put a check mark on that. That adds it to the selection over here on the bottom right. And I'm going to click Done. So I've added one of my virtual machines that I want to monitor, but I haven't yet specified a condition for what I want to monitor. So down below in the middle under the Condition section, I'm going to click Select Condition. Now from here, I have a number of signal types or signal names. These are metrics such as CPU, percentage, disk read bytes, disk write bytes, and so on. Let's say I'm interested in the percentage CPU utilization, which is going to be an indicator of how busy that VM is. So I can see it's charted over the last 6 hours, the CPU utilization, so I can have a sense of what's normal, what the baseline is. Let's say I choose over the last week. Here I get a sense of where it might be going in terms of how busy that virtual machine gets. Not very busy. We've got a peak here at just under 2.5%. That is not a busy virtual machine. So I'm going to scroll down. Threshold here is going to use an operator of greater than the average, although I could do maximum, minimum, total, or count. So if we've got an average of, let's say, over 70% of CPU utilization, then I want this alert rule to be triggered. So this will be evaluated every minute against that VM. So I'm going to go ahead and click Done. So we've got the resource selected, the condition. Finally, to put it all together, the action group at the bottom that we created when we started this demonstration. I'm going to choose Select Action Group, and I'm going to choose Admin Text Notify. I want to send an SMS message when that Ubuntu service CPU goes above 70%. So choose Select. That's been done. I have to give this rule a name. So Ubuntu Busy CPU. That's what I'm going to call this. And then down below, I'll just click the Create Alert Rule button. So now if I go to Manage Alert Rules, I'll click that up at the top, I will have my rules listed, including the one we just created. So we've got our rule, Ubuntu Busy CPU. And when that is triggered, not only will we have a text message notification, but if I click the X in the upper right to close this, we'll also see the alert shown here in the Alerts view. One way to save money when using Azure services is to shut down the services that you don't need running, especially if you're using Azure for temporary testing projects. One of those examples comes in the form of virtual machines, as well as things like databases. If you don't need them, do not leave them running since you will be incurring charges. Here in the portal, I'm in the virtual machines view, and the first thing I notice is that in the status column, all of my virtual machines have a status of stopped deallocated. And this is a good thing if it doesn't need to be running. Now, certainly there will be times where you might have virtual machines that you need running all of the time, much like you might have an on-premises server that needs to be available always. And that's fine. But if you don't need it, it should be shut down. We can automate that by using the virtual machine auto shutdown feature. Let's take a look at that as an example. I'm going to open up a virtual machine to get into its properties navigation bar. On the left, what I want to do is scroll down in the bar all the way down under operations where I have an auto shutdown option. That's what I want, so I'm going to click on that. On the right, I can then enable or turn on the virtual machine auto shutdown feature. I'm going to turn it on. This is where I can schedule the shutdown. The default is 12 a.m. Instead, what I'm going to do is specify 6 p.m., assuming that within the time zone, which I can select below, that's when the virtual machine will no longer be required. Now, if it's already shut down, that's great. You could consider this kind of to be a safety net to shut things down in case somebody forgets to do it. This way, we're not paying for the virtual machine running when it doesn't need to be running. Then I have the option to send notifications before the auto shutdown. I'm going to choose yes. And then I could specify either a webhook URL or I could specify an email address. So once I do that, we have notifications that are going to be sent prior to the auto shutdown occurring, just so that there's some knowledge of this occurring. So I'm just going to put in a group email address here, admins@quick24x7.com, just as an example. And I'm just going to go up and click the save button to save this auto shutdown configuration. And after a moment, if I click my notification icon in the upper right, there's a successful message here for the updating of the schedule. So this is one easy way to save on costs when it comes to virtual machines. Yet another way to save money when using Azure is to use reservations. Reservations applies to a few different types of resources, including virtual machines, where you can pay for the use of that compute service upfront or monthly, but with a 1 to up to a 3-year commitment. So by committing to use this compute service for that period of time, you realize savings. And depending on exactly what you choose and how you configure it, you might get 30% savings, 40, maybe 60% savings compared to what you would pay if you were to use metered pricing, pay as you go. So let's take a look at how to work with reservations here in the portal. So the first thing I'll do in the portal in the search bar at the top is search for reservations, and then I'll click to open up the reservations service. Now, currently, there are no reservations to display, so we haven't yet committed to this. So I'm going to click the Purchase Now button at the bottom center. And here I have to select the appropriate category. Do I want reserved virtual machine instances, SQL database, Azure managed disks, app services, Azure Databricks? We get to choose what we want. Here, I want to gain savings by using virtual machines. So in other words, I want to configure reserved instances. So I'm going to choose virtual machine. Now, the way that this works is you will choose the sizing for the virtual machines that you want to reserve, let's say for a year, for 3 years, that type of thing. So what happens then is after we purchase this reserved configuration, the discount will apply automatically to virtual machines that match the sizing and perhaps even the location, the geographical region. So what I'm going to do here then is select the appropriate sizing. Now the scope up here is shared. What we could do is go to a specific resource group, because maybe we want reserved instances only to apply to virtual machines deployed into a resource group. So then we would select the resource group, of course. However, here I might want to apply it to a single subscription or shared multiple subscriptions if we have multiple subscriptions. I'm going to go back to just a single subscription, and then I can select that subscription over on the right. I only have one. So we've got a recommended list of items. So we can select a region. So perhaps we want to choose, let's say, East US. The term, we can choose 1 year or up to 3 years. I'm going to choose 1 year. If we know that we've, for example, got a work contract that will require us to use virtual machines in Azure for up to a year, then it might make sense for us to go through this process. The billing frequency, monthly, or you can pay the entire amount up front. Let's say we're just going to go monthly. Now, this recommendation that we see below for virtual machine sizing is based on my virtual machine usage over the last 30 days. However, we could choose over the last 60 days. Now, we may or may not get something different. Otherwise, if we don't want to look at that, we could just click All Products. This would allow us to select from a large variety of virtual machine sizing that's available. So we need to pay attention, of course, to the virtual CPUs, the amount of RAM, and the idea is that we want to make sure we choose the correct sizing. And as we know, once we've done that, for example, if I choose standard B2MS, any virtual machines that use that size will benefit from a reduced cost. Now you might wonder, what is that reduced cost? When you select sizing here in the bottom right, the monthly price per VM is about $30 Canadian based on my selection. And it's telling me that that's approximately a 62% estimated saving over if I just did pay as you go. So if you know you're going to need this compute power ahead of time, it makes sense to consider this at least. So I would go ahead and choose Select after I've chosen the correct item. And I can determine the quantity. How many of these do we want to buy? So if we wanted this to apply, let's say, to 3 virtual machines, we could select the quantity of 3. The unit price is almost $30 Canadian, but the subtotal is calculated for the quantity amount. And after we've done this, we could then click Next to review and buy. In the bottom right, we have today's charge. We also have the total reservation cost, and we can also view the full payment schedule. So we've got the dates and the amount that will be billed. So remember, when we look at the total reservation cost, that's going to be over the entire time frame. In this case, it would be for 3 years. So if you calculate what you might otherwise pay over 3 years based on your usage, it might be a lot more than that. And certainly if you were going to host physical servers, even virtual machines on premises, so acquiring the hardware, the licensing, and paying for the power to run those would easily perhaps exceed this total reservation cost. So it's something that should be considered in our palette of cost-saving options in Azure. One thing to keep in mind when it comes to saving money when using Azure is somehow identifying resources that are unused and also unnecessary. It's so easy to deploy resources in Azure, such as virtual machines, and over time you can end up with virtual machine sprawl. And that means that because it's so easy to deploy virtual machines, they might be deployed on a large scale, and many of them might be left running without being turned off or deleted. And so you would be paying for that over time. So let's start here in the portal by going to the virtual machines view. The first thing to watch out for, of course, is the status. Is the virtual machine running, and should it be? But we also need to make sure that we understand the role of that virtual machine. In some cases, maybe it does need to be running all of the time. If I click to open up a virtual machine's properties here in the portal, one of the things I can view in the overview blade is monitoring. So if I just kind of scroll down on the right here and click on monitoring, I can get some charts that will provide information on things like CPU utilization, network traffic, and disk I/O activity related to that virtual machine. The default is over the last hour. What I'm going to do is choose over the last 30 days. I need to get a sense overall, is this thing being used or not? As I scroll down over the last 30 days, I do see a spike in activity for the CPU utilization, as well as the network traffic. And as I hover over one of the data points in the chart, it also is showing it to me in the other related charts. So I could see naturally that the activity spikes are all correlated for disk I/O, network traffic, and CPU utilization. Now, if I don't have much activity, or if the activity took place a long time ago, then I might deem that this virtual machine is unnecessary. And so I might, on the left-hand side, scroll down and go under Operations and configure Auto Shutdown, or I might simply delete the virtual machine if I'm sure it's not required. Something else to consider is going into Azure Monitor. So in the top center here in the portal, I'm going to search for Monitor and click on Monitor, open the Monitor service. What I'm primarily interested in here is if I scroll down in the left-hand navigator, going all the way down under Support and Troubleshooting, and selecting Advisor Recommendations. Now this will give me some recommendations on things such as how to save money, but also perhaps on any items that might need to be removed, such as public IP addresses that aren't assigned to any resource. So as I scroll down through the advisor recommendations, I've got a high impact description here that says you might want to buy virtual machine reserved instances to save money because currently you're doing pay-as-you-go. And so there's a listing for the potential benefits over time, in this case for 3 virtual machines. So I've got other cost-saving mechanisms that might also be shown here, depending on what kind of activity I have within my environment. The other thing to consider is PowerShell. Here on my on-premises system, I've launched the PowerShell ISE and opened up a script. Now this script is going to identify any managed disks in my Azure subscription that aren't attached to anything. So I'm paying for that even if the managed disk is not being used. So in line 1, I'm creating a variable, $delete unattached disks. Now this script, by the way, comes straight from Microsoft. I did not create it. So the second line, I'm creating a managed disks variable, which stores the result of running get-az-disk, and then I have a loop, a for each loop, where I process each managed disk. So within the for each loop, I'm creating a temporary placeholder variable that's called $MD to process each item in the loop. And I'm processing all of the disks that happen to be stored in the $managed disks variable from line 2. So if we have 30 managed disks, we're going to be looping through those 30 managed disks. If we have 1, we're looping through 1. What I'm doing is using an if statement to check the managed by property of the currently being processed managed disk to see if it equals null. Now the next thing I'm doing is I'm setting the $delete unattached disks equal to 1. I'm checking that. If we are set to delete the disks, because maybe we just want to identify them in the script, and notice it's set to 0 at the top, we don't want to delete them, then it's going to display a message about deleting the unattached disks, and I've even commented out here the remove AZ disk force statement. Instead, it's just going to write back with write host unattached managed disk with ID, and it's going to display the ID property of the disk. I'm actually going to comment out the write host statement above that's writing back that it's deleting the disk, because it's not going to do that. So at this point, I'm going to save the script. I've already connected using connect-az account, so I've authenticated to my Azure account. Let's go ahead and run this script by clicking the Run button at the top, or alternatively, if you're a keyboard person, just go ahead and press F5 to run the script. So it takes no time to run this script because I don't have very many objects in my Azure subscription, but I have the ID for 2 managed disks that are no longer being used. One of them is a replica disk. So this would be something I would consider then actually removing to save on costs because it's not being used. Now, we don't know for how long it hasn't been used. It's possible that an Azure technician created these managed disks and temporarily they aren't attached to anything, but they will be. So we don't want to just go ahead and delete them without doing a bit more investigative work. But either way, at least we've identified the orphaned managed disks. Resource tagging is an important part of managing your Azure subscriptions. Now, resource tagging really means you're adding metadata to your Azure resources. You might add metadata related to a cost center that a resource should be associated with, or a project manager, a department, or maybe the stage of development for resources, such as testing versus production. There are many reasons to do this, and the great thing about resource tagging is you can also use that to your benefit when you start organizing or filtering your Azure costs. You can view it by the tag value if you really want to. And you might use that for departmental chargeback or project chargeback. So to tag resources in the portal, we simply have to go into the properties of the object. For example, if I open up a virtual machine, it could be any other object, not all, but the vast majority of objects can be tagged in the Azure subscription environment. When you open up the properties, in the navigation bar, you'll have a tags option over on the left. When I click on that, any existing tag values will be shown on the right, but I can add additional items. For example, if I click to add a new tag name, it'll pop up with a list of tag names that were already used somewhere else within the subscription. And the values will as well. So let's say, for example, I create a tag, let's say called project. And the value of that, let's say, is going to be ABC. So I want to track things by project. This virtual machine is associated with project ABC. Now, once you've done that, you will then have added that tag. Once you click the Save button at the top, you can add up to 50 tags per individual Azure resource. So you have quite a bit of flexibility. Over to the right of each tag, you can delete the tag. There's a trash can icon. You've also got a little square, a three-dimensional block icon to show resources with the tag. When you click it, it's going to open up a screen and show you any other resources tagged with the same name and value. Now, I don't have any because I've just created that tag. So I'm just going to go back and I'm going to click Save. Now, you can also define the tags whenever you create a resource. It's usually towards the end of the wizard when you're creating a virtual machine, a storage account, a public IP address, whatever it happens to be if you're using the portal. So if I go to another resource, let's say I'm just going to go home here. Why don't I pick on, it doesn't really matter what it is, a virtual network. Let's say VNet1. If I open up that resource and click on tags on the left, in the exact same way, I will have any existing tags shown on the right. So this virtual network doesn't have any tags. But if I click in the name field, notice that project shows up because I just created that a moment ago for my virtual machine. I can select that from the list, and when I click in the value field, any existing values that have been applied for that name in the subscription will also appear, and I can select it, Project ABC. Or I could type in something completely different. I'm going to leave it on ABC, just going to save that change. Let's just go and open up a third resource. It doesn't really matter what it is. Let's say it's a key vault. What I want to do here is just point out that when I go view the tags, remember that we can click on the little three-dimensional square to show resources with the tag. So let me just add project here for this third resource. And I'm going to use ABC again, so project ABC, and I'm going to click three-dimensional square, show resources with tag. This time when I do it, the existing resources I've already tagged with Project ABC are showing up in the list. And this is important. Now also, if I were to go, let's say to the All Resources view, I'm going to go to All Resources. One of the ways you can filter this list is by tag. So I can click the Add Filter button at the top, and here I'm going to choose under tags the appropriate item I want to filter by. Let's say Project equals, or I could change the operator, not equals, but let's say project equals ABC. And I'll just click outside of there. And that way I will have the resources that I flagged specifically with that tag name and value. Now back here in the portal at the home screen, if I search for subscriptions at the top, I can go into my subscription and filter costs by tags. Let me open up my subscription. And what I'm going to want to do in the properties navigation bar on the left is click on cost analysis. So this is an important aspect of tagging, and it might even be the sole reason you do it, is to organize costs by tag, by project, by department, whatever the case is. So if I click Add Filter at the top, I can scroll down at the bottom of that list and choose Tag, where I can then choose the tag, so let's say Project, and the values. Now, my values aren't up to date yet, so you can't expect to tag resources and immediately go track them for billing purposes right away. It takes time for that to be analyzed, but this is what you can do, and it lends itself to the power of resource tagging. You can use PowerShell commandlets to manage the tags for your Azure resources, to organize your resources, or to facilitate grouping resource billing by tag value. So to get started, I'm going to create a $store account variable that will store the result of running get-az-resource. Resource name is a storage account I've got created already in a resource group called RG1. So I need a pointer to that storage account, essentially. That's what the variable will be for. So if I bring back that variable, $store account, and just press enter, it has been populated with the information for that storage account. So it's got a tag already, cost center, with the value of YHZ. What we're going to do is add another tag here in PowerShell. So to do that, I'm going to refer to my storage account variable, $store account, then .tags, I'll refer to the tags property, .add, the add method, and in parentheses and in quotes, I want to add a tag key called stage, comma, with a value of development. And I'll close the parentheses and press enter. So I'm going to clear the screen and I'm going to check my work. Basically, if I just bring back my variable $store account, I've got the existing cost center tag and the newly added stage tag with the value of development. However, in parentheses, I'm going to use get-az resource -tag. What I want to do is get a list of resources tagged with stage development. So -tag, and I've got an @ symbol in curly braces, stage equals development. So that's what I'm searching for. And I'm going to close my curly brace after that and close my parentheses and then .name. So I want everything in the parentheses executed as one expression first, then I'm calling upon the name property. In other words, show me the name of Azure resources with the stage tag with the value of development. And it doesn't return anything, despite the fact that our variable above appears to have the stage tag. So that seems very strange. It showed up above, but we don't get it down here when we try to retrieve it with get-az resource. The reason is it hasn't been committed. We can run set-az resource -tag $store account .tags. Now the tags here, we've got two tags here that we want to make sure are stored. The first one was already there, cost center, but we want to add the stage one. Then -resource ID is going to be our variable $store account .resource ID. And finally, -force. So what we're doing is forcing that to be written to that resource as opposed to just in our memory variable. And if we clear the screen and then run our get-az resource command again, we'll see that it returns the name of our storage account that's been tagged with stage equals development. So that's what our criteria was. We are now seeing the result of that. So we can work with resource tagging in Azure using the Azure Portal GUI, using PowerShell commandlets, and our current focus using the Azure CLI. I've launched the Cloud Shell from the Cloud Shell button at the top of the portal. That's where I'm going to run the CLI. I'm going to start by running AZ tag list. Now what I could do at this point is I could run -- query space open and close square bracket .tag name. So what I want to do is refer to the tag name property. That's all I want to see with the tags. And what I'm doing here is getting a list of tags in the entire subscription that have been used previously. The name of the property is case sensitive. So the word tag is all lowercase, but the word name as part of that property has a capital N. So bear that in mind. I'm going to go ahead and press enter. Let's see what we've got. So we've got a couple of tags being used throughout the entire subscription, such as cost center, project, client ID, and so on. Now I can also create tags that can be used throughout the subscription. I'm going to do that with AZ tag create -- name, let's say department ID. That's what I want to create. Now, all I've done is added that to the subscription. It could potentially be used, but I actually want to add that to a resource. To accomplish that, I'm going to run AZ tag add -value. And then I have to specify the name of the tag, -- name. In this case, it's department ID, -- value. And I'm going to add, let's say, 1234 as a department ID. So what I haven't done yet is apply this to a resource, but I've added a value to that tag in the subscription. Now we get some returned output that shows us that the tag value indeed is now set to 1234. Let's clear the screen. Now it's time to add this to a resource, AZ network VNet update. I've decided I want to add that tag name and value to a virtual network. I want to tag a VNet. So AZ network VNet update -G for the resource group. The VNet I'm interested in is in a resource group called RG1 -N for name. It's called VNet1 -- set tags.department ID. And I can even specify a different value. I don't have the value that I've set at the subscription level. So I can put in 3, 4, 5, 6, or whatever the case might be as it would be deemed appropriate. So I'm going to press enter to make sure I tag VNet1 with department ID and that value. So after a moment, I have some output, which implies a department ID with a value of 3456 was added. Why don't we check our work in the portal just for fun? I'm going to open up in the left-hand navigator the virtual networks view, since we're talking about a VNet in this example. It's called VNet 1. Why don't we open it up? And in the properties navigation bar on the left, I'll click tags. On the right, any existing tags will be shown, and sure enough, there's department ID with a value of 3456. If I were to go to another resource, so let's go back to the virtual networks view. I'm just going to open up some other VNet. And what I want to do is go to tags. Let's say I want to add the department ID tag. So department, and I can choose it from the list. When I go to the values drop-down list, not only will it show me the value I applied to VNet 1, but remember I also added a value just generally to the subscription, which makes it selectable in a list like this. So in this course, we've examined methods available in Azure for analyzing and reducing the costs of Azure services. We did this by exploring ways to reduce unnecessary Azure charges, how to use the portal to analyze your current costs, how to configure an Azure budget and create an Azure action group for alert notifications. Next, we explored how to enable VM auto shutdown and configure reserved instances, how to identify and remove unnecessary Azure resources, and finally, how to tag resources using the portal, PowerShell, and the CLI. In our next course, we'll move on to explore the Azure migration options available for migrating on-premises workloads, including servers, web apps, and databases, to the Azure cloud. The migration of existing on-premises data and/or IT services requires some upfront planning. One of the reasons for this is to ensure that there is the capability in the Azure cloud to store and accommodate data or run IT services in a way that matches what you're currently doing on premises. It's also important to be compliant with laws and regulations. And we also have to consider if any downtime would be incurred as a result of migrating to Azure. The first thing we have to consider is the Azure Migrate service. This is a centralized tool that allows us not only to migrate our services from on-premises into the Azure cloud, but first to assess it and to check migration readiness. So server assessment and migration is possible, as well as database assessment and migration. There are even some third-party tools, independent software vendor or ISV tools, that you can use with Azure Migrate. An example of this would be Turbonomic, which is used for doing assessments only, where other independent software vendor tools such as Corent Technology provide us the ability not only to perform assessments to take a look at cloud readiness, but also to actually execute the migration itself. With Azure Migrate, we can assess servers and databases on premises. To be a little more specific, on the server side, we can assess VMware, virtual machines, Hyper-V, virtual machines, as well as physical servers. And what will happen is the server assessment will determine what sizing recommendations are applicable, the VM size that would be used in Azure to match the horsepower that's currently being consumed on premises. So in order for this to work, there's an on-site lightweight appliance that you download and run to perform the server assessment. On the database assessment side, we can use the Data Migration Assistant, or the DMA tool. So DMA then allows for the assessment and migration execution of on-premises databases like SQL databases. And we can migrate to IaaS VMs running SQL, so manually deployed virtual machines in the cloud. But we can also migrate to Azure SQL Database, a managed database solution. So the database migration service then allows us to move database workloads from on-prem into the Azure cloud. You have to consider the actual data as it's being moved over the network in terms of its security. So you could move the data through a site-to-site encrypted VPN tunnel or through an express route dedicated circuit. Another aspect of migration is the data that you might have on-prem that you want in the cloud. And for that, we have a couple of options, including the Azure Import-Export service. So we can perform an on-premises data backup into the cloud, or it could be used for migration. That also allows for data recovery from the cloud. So we're talking about getting content sent into an Azure environment, such as blobs being stored in a storage account. So we're going to talk about it from a migration standpoint. So the way it would work is that we would first copy the data to our disks using the WA import export tool. This is a free command line tool that allows you to prepare disk storage devices for being shipped to a Microsoft Azure data center. So after you've copied the data to the disks, using that tool, you can create a storage account import job, then provide the shipping info, and then finally ship the drives to Microsoft. The WA import export tool will protect the data at rest on your storage devices using BitLocker disk volume encryption. You can use the Azure Migrate service to not only discover on-premises items to be migrated to the cloud, but you can also assess them to ensure their cloud readiness. Here in the portal, in the top search bar, I'm going to search for Migrate, and I'm going to choose the Azure Migrate service. Currently, we're in the Overview blade, where on the right, we have some options for assessing on-premises servers, Windows and Linux, as well as SQL databases, and even application web apps that we might have running on-prem. I'm interested in assessing and migrating servers that I have on-premises, whether they're VMware, Hyper-V, or physical. So on the left, I'm going to click Servers. And on the right, in the bottom center, I'm going to click Add Tool. I need to add tools for assessment of the migration and also the actual migration itself. So I'm going to deploy this into a resource group. I'm in the midst of creating a new migration project, and I have to give it a name. So I'm going to call this Canada, and I'm going to select the geography, Canada. I'll click Next, and I have to select an assessment tool. So down below, I have a few of them listed, both from Microsoft and also third party. And it's always important to look at the supported workloads and also the features that are available. So we've got a number of choices here. What I'm interested in is Azure Migrate Server Assessment. So I'm going to select that and click Next. That puts us on the Select Migration tool part of the wizard. So that was the assessment tool. Which tool do we want to use to actually perform a migration? Again, we've got some third-party tools here. We need to look at the supported workloads and the features. So I'm going to choose the Azure Migrate Server Migration option. And I'm going to click Next. And on the Review and Add Tools screen, I've got my selection here for the tools I want to use with this migration project. So I'm going to click the Add Tools button in the bottom left. So we've now got our project set up with our assessment tools. So I'm going to click the Discover link over on the right. The first order of business is to discover machines on-prem that might be suitable for migration to Azure. So I'm going to discover using a virtual machine appliance that I can download and run on-prem, and it's going to be essentially the on-premises agent that discovers servers that we might want to migrate. For the Are Your Machines Virtualized option, I'm going to choose No, not virtualized. I've got physical servers on premises that I want to assess and potentially migrate to the cloud. So I'm going to download the Azure Migrate Virtual Machine Appliance. It's a zip file. It says it's approximately 50 megabytes in size. Next thing I'll have to do is run a PowerShell script to set it up and then configure it by connecting from a web browser. It's a web-based virtual appliance application. So once I've downloaded the installer, it's a zip file. I'll need to extract it before I can actually begin doing an installation. So there are a number of files available in that zip. What I want to do is install this virtual machine. So I'm going to choose to view file name extensions, and we've got a PowerShell script, a PS1 file here for the Azure Migrate installer. That's what I want to execute. I want to run that script. So I'm going to go ahead and start PowerShell and run it as an administrator. And I'm going to change into that directory where I've extracted it. And I'm going to run the script with / and the name of the PowerShell script, Azure Migrate Installer.ps1. So I've done this on my hypervisor host on premises where I'm going to run the virtual machine. So here my on-prem server, I'm connecting to the web app at port 44368. And what I'm going to do is go to the Setup Prerequisites section and accept the license terms. It's going to verify I've got an internet connection and that my time is in sync with the internet. And then it's going to make sure I've got the latest Azure Migrate files. Once it's done that, I'll scroll down and click Continue, and I need to register with the Azure Migrate service in my Azure account. So for that, I'll click Login. After that's been done, I'll select my Azure subscription and my Azure Migrate project that I set up. It's called Canada in their RG1 resource group, and I'm going to enter in an appliance name to configure the virtual appliance. I'm going to call it MIG App 1, and I'm going to click Register. Okay, after it's successfully registered, I will then click Continue. Next thing I have to do is add credentials that will be used to authenticate to on-prem hosts. So it's going to be for Windows, not Linux. And I need to provide a friendly name for the credential set, as well as the credentials themselves. So I'm going to call the credential set Standard Windows Creds, and I've specified admin name and password, and I'll just OK that. So now that we have that, we can start providing server information that we want to start essentially querying, discovering, and checking to see if they are suitable for migration. So I'm going to pop in the IP address, comma, and the name of my credential set here. This is my list of physical servers. Then I'll click Validate. So that's been added to the list down at the bottom now. So once that's ready to go, the status will be set. I can go ahead and click Save and start discovery. It says it initiated discovery and completed the appliance configuration, my virtual machine appliance that's going to be used to actually run the discovery. So I'm going to click Manage the Appliance. And in the appliance configuration, we've got the prerequisites that were all met, the physical server details that we've specified with the credentials, and we've got the server we added. And for appliance services, the discovery agent is up and running, as well as the assessment agent and the management app. So in other words, our Azure Migrate appliance is ready to go. So here in the portal, in the Azure Migrate service, what we can now do is start viewing the results of the appliance doing its discovery. I'm going to click Discovered Items over on the left. Now this can take a bit of time, so I've waited a few minutes. But for my pay-as-you-go subscription, and for the only Migrate project I have, it's called Canada, I'll be able to view my Microsoft tools for Azure Migrate, the Azure Migrate appliance. My appliance name that was registered previously, MIGApp1, is here, and down below I'll have any discovered servers. So I've got the details for my discovered on-premises server. I can click the Create Assessment button up at the top to create an assessment for the discovered servers. So I'm going to click Create Assessment at the top. And I'm going to call this Assessment 1. I'm going to create a group called Group 1 for assessments. And the appliance name is selected. I'm going to put a check mark by the discovered hosts I want to assess for cloud readiness. So we've only got one server that was discovered, and then I'll click the Create Assessment button at the bottom. In my notification area in the upper right, it's now generating the assessment. It says it'll take a few moments for it before it's ready. So if I click Servers over on the left, I'm still in the Azure Migrate service here in the portal. Then I have one discovered server shown. I've got one group for assessments configured, and I've got one assessment. So I'm going to click the link for the one assessment that was just completed. So the status is that the assessment is ready, which is perfect. So I'm just going to click to open that assessment up. In the overview blade, if we look over on the right, we've got one server that's ready for Azure in terms of readiness. And we've got some monthly cost estimates for things like storage and so on, if that were to be moved into the Azure cloud. So I'm going to click the Export Assessment button up at the top. I can basically export an Excel spreadsheet. This is especially useful when you've discovered and have assessed many servers. If I click Azure Readiness in the left-hand navigator, the servers that are ready to be migrated to Azure are shown over on the right. And the suggested tool, in my particular case, is the Azure Migrate tool. That's what I could use to actually perform the migration. So let's open up that server. We've got the details here. It's ready to be moved into Azure. It even suggests an Azure virtual machine size. We have our monthly cost estimates for that server. And down below, we've got the details for the cores and the disks. It knows the CPU core, the memory. It knows the disks that would be required to be created in the cloud to match what's currently available on that physical server on premises. And we have a breakdown of the monthly costs for that. And also, it knows that there's one network adapter, so that would be recreated in the cloud if we were to migrate this server as well. The Azure Migrate service can be used to discover, assess, and migrate not only on-prem servers, but also databases. So here in the portal, I've opened up the Azure Migrate service. So on the left, I'm going to click Databases. On the right, I'll click the Add Tools button. We need to specify a tool both for assessing and then actually performing the migration. So I'm going to go ahead and select the Azure Migrate Database Assessment tool. There is another third-party tool listed here, but I want to use the free Azure Migrate one since it will do the job. So I'll click Next. That takes me to the Select Migration Tool screen, where I'm going to choose the Azure Migrate Database Migration tool, and I'll click Next. And then I'll confirm my selections. I'll click the Add Tools button on the left. So I'm just setting up Azure Migrate for database assessment on premises and ultimately potentially for migration. So the next thing I'm going to do then, I've clicked Databases on the left here in Azure Migrate, is I need to work with the Data Migration Assessment or the DMA tool. This is a tool that I can download and run on premises. So I'm going to go ahead and click the link to download it. On premises, I've got the Data Migration Assistant MSI. I'm going to right-click and install that. And I'll just choose Next. I'll accept the terms in the license agreement and continue on through the installation, accepting defaults. Won't take long for it to do, and then I'll launch the Microsoft Data Migration Assistant, and then I'll click Finish. So that's going to open up the DMA tool, where I'm going to click the plus button on the left. And what we could do is create a project that allows us to perform an on-prem assessment of databases to check for cloud readiness. But we also have the option of specifying a migration project to actually perform a migration. But you can't do that until you've done an assessment, of course. So I'm going to go ahead and perform an assessment. I'm going to call this project HFX Proj 1. The source server type can either be SQL Server. You can actually assess Amazon Web Services, Relational Database Services, or RDS for SQL Server as well. But in this case, we're just going to be taking a look at an on-premises Microsoft SQL Server. So I'm going to select that. The target that we're going to want to potentially migrate this to is going to be Azure SQL Database. So I'll click Create to create the assessment project. Then I'll click Next in the bottom right. We have to specify our source server on premises that we want to assess. So I specify the server name, then the authentication type, which in this case I can select as Windows Authentication if that's how it's configured, and then I'll click Connect. So once I've authenticated, I can then select the data sources that I want to assess. So these are databases available on my server. So I'm going to put the check mark next to one of the databases, and I'll add that. So the database has been added under the server, so I can add and remove sources as required for assessment. And then I'll click Start Assessment in bottom right. So the assessment is currently happening. Once the assessment is complete, I can view the results. What I want to do here is make sure that for my server, and of course ultimately the database that I've assessed, that I know which features may not be supported in the cloud. So I can either make a change, or I might even deploy SQL in Azure manually in a virtual machine if I absolutely require those types of options. So as I scroll down, I can see recommendations based on any unsupported features and what I can do about it to make this work in the cloud. So then I could click the plus button to add a migration project, actually migrate my server from on-premises, my database from my server on-premises into the cloud. You can use the Azure Migrate service to migrate on-premises web applications into the Azure cloud as an Azure app service or an Azure hosted web application. Here in the portal, in the top center bar, I'm going to search for Migrate. I'm going to choose Azure Migrate to open up that service list of options. And on the left, I'll click Web Apps. On the right, I'll then click the Add Tools button. We have to add a tool that will allow us to assess and then ultimately migrate the tool. So under Select Assessment Tool, I'm going to choose Azure Migrate Web App Assessment. Then I'll click Next in the bottom left. On the Select Migration Tool page, we've got one tool available here, the Azure Migrate Web App Migration Tool. So I'm going to go ahead and select that. And I'm going to go ahead and click Next. So on my review page, there's not really much I need to review here. There are only a few selections. I'll click the Add Tools button in the bottom left. Now when I go to Web Apps on the left, it looks a little bit different on the right-hand side because we've just added the tools. So we've got both assessment tools and migration tools available here. We've got a few steps under assessment tools. I can go to click the Assess link, where I can choose to download the App Service Migration Assistant. Then assess on-premises web apps, and then upload the assessment results to Azure Migrate. So I'm going to click the Download button to download the App Service Migration Assistant. Now that opens up a new web page where I have two options available for performing the assessment. I can assess a public URL if I've got a public-facing web app, and then determine whether it's suitable for migration, or I could download the tool, which allows me to assess internal applications. So I'm going to go ahead and do that. I then get a list of the minimum system requirements to run this tool. So that's fine. I'm going to go ahead and go down to the bottom, and I'm going to choose Download. I'll accept the license agreement and then download the installer. So I'm going to go ahead and choose to save the MSI installer. Then I'm going to go ahead and right-click on that MSI and choose to install it. So I'm installing this on a server on premises because I want to scan for and assess on-prem websites. So I'm going to launch the App Service Migration Assistant tool that I've just installed. So down below, it's found two websites available on this host. So I'm going to go ahead and select the default website that's running on this on-premises machine. And in the bottom left, I'll then click Next. So it does a quick little assessment. Now, we don't have any warnings or errors, but we've got 13 success messages, which is fine. So it looks like we're ready to continue with this assessment report to get it into Azure. So I'm going to scroll down, and in the bottom left, I'll click Next. It provides a device code that I can use when I log into Azure to upload this assessment report. So I'm going to click Copy Code and Open Browser, and it will do just that. So I'm going to go ahead and paste in the code, and I'll choose Next. Now back here in the App Service Migration Assistant, I can now specify my subscription in Azure, and I can create a new resource group or deploy my migrated web app into an existing one. I can add a destination site name. It's going to use the Azure Websites.net DNS suffix. As usual, I could always add a custom DNS name after. Let's call this Migrated App 172. I can create a new app service plan or use an existing one that I might already have deployed in Azure. And then I can associate this with an existing Azure Migrate project, which I already have. It's called Canada. And then I'm going to click the Migrate button. And before too long, the web app has been migrated. So I can go to the website, migrate another site, or export this migration as an ARM template. Here in the portal, I've got my migrated app service. It's called Migrated App 172. So I'm just going to go ahead and click to open up the Properties navigation bar for that app, which puts us in the overview blade. It's running, and on the right, I've got a URL. I'm going to go ahead and click on it to make sure it loads up. So here we've got our migrated web app, which is now successfully running in the Azure cloud. When you have large amounts of data on premises, for example, in a data center, and you need to get that into the Azure cloud, there are times that transferring that data over the network is not feasible, even with the fastest network connections. And that's where Azure Data Box comes in. So it allows us to migrate large amounts of data into the cloud without being transferred over the network. Well, how does that work then? Well, what happens is that Microsoft will ship specialized storage devices to your location that you then connect to your network, copy the data to, and then send back to Microsoft for them to put into the cloud. Now, these devices will be wiped clean by Microsoft after being received when you send them back in. So there are a number of options or variations on Azure Data Box. The first being Azure Data Box Disk. This is designed for up to 8 terabytes of data. It uses solid-state drives with either a USB or a SATA interface, and you can use tools such as the RoboCopy command line tool to copy the data to the device. And the device encrypts data, it protects data at rest using AES 128-bit encryption. You then have the Azure Data Box option, which is up to 100 terabytes of capacity. It supports access over SMB or NFS file protocols over the network. It supports AES 256-bit encryption. Finally, you've got Azure Data Box Heavy for very, very large amounts of data. It's got a 1 petabyte capacity. It also supports network-attached storage or NAS, and it supports AES 128-bit encryption. Another variation of this is the Azure Data Box Gateway. It's a gateway that runs as a virtual machine or an appliance that you download and run on premises. And that virtual appliance comes in the form of either Hyper-V or VMware. What this allows is network access using standard file sharing protocols like SMB or NFS to the data. And the data that is stored on the Data Box Gateway also gets transferred into Azure. So what we're talking about is a way to get data migrated into the cloud over time, but also allowing on-premises file access, which is quick access to that data. Migrating to the cloud can include more than just migrating servers and databases from on-premises into Azure. It can also include the migration of data. Here in my web browser, I've gone to the Microsoft.com site and searched up the import-export tool for Microsoft Azure. So this is a free tool that we can download, and we can use it to generate a journal file that is then used with the Azure Migrate service to get data into Azure. Now, you would use this often when you have very large amounts of data where it doesn't make sense to transfer it over the internet into Azure. Instead, you use physical storage devices that will encrypt the data, and then that gets shipped to a physical Azure data center to be put into a storage account. So here in the portal, I've gone into the Azure Migrate service, and on the left, I've clicked Data Box. So from here, we have a number of options available depending on how much data we have on premises that we need to bring into the Azure cloud through migration. So on my on-premises system, I have Drive L. This is a removable drive, so BitLocker to Go is enabled. And what I want to do here is I want to unlock it. I already have data here on this drive that I want to bring into a storage account. So I'm going to click Unlock Drive and enter the password to essentially give me access to the contents of that BitLocker to Go protected drive. So if I flip over to Drive Letter L in Windows Explorer, I've got a projects folder in which I've got a couple of sample project files, project A, B, and C. Here in PowerShell, what I'm going to do is use the manage-bde BitLocker drive encryption command to extract a key or a password that I need to use when I generate a journal file. So I'm going to use the -protectors parameter and -get and then drive letter L, so L colon. What I'm interested in is at the very bottom, the password. Now this is going to be used again when I generate a journal file using the WA import export exe tool. So I'm going to go ahead and copy that. Next, I'm going to use the WA import export.exe with the prep import parameter. -j for the journal file location is going to be a file I'm calling drive-ljournal.jrn, so a journal file. Next thing I'm going to do is give it an ID. So ID, I'm going to call this session1/T. So this is the drive letter L, so no colon after the L, /BK for BitLocker key. And there's the key that I copied from our previous command. And what I'm going to be doing then is I'm going to be then specifying next, the source directory is the root of drive L. So I want to prepare everything here. The destination directory is going to be East Data. That's where I want this to be stored once I put it in a storage account in the Azure cloud. The blob type is a block blob. I'm going to choose /skip write. I don't want to overwrite anything on the drive since I already have data there. And I want to enable content MD5 to generate MD5 hashes for files. So this journal file is now being prepared, which is going to be required for me to submit an import job in the Azure portal. So back here in the portal, in the Azure Migrate service, I've clicked Data Box on the left. So I'm going to specify a resource group. The transfer type is an import job from on-prem to Azure. Source country is Canada. Destination Azure region, let's say, is going to be within Canada. So I'll choose Canada Central and I'll click Apply. Then I'm going to be presented with some options. So data box disk, if I've got, say, 40 terabytes of data, 100 terabytes would be data box. Data box heavy is 1,000 terabytes, which works out to be 1 petabyte. It's a lot of data. However, in this case, I'm going to send my own disks. So for up to 1 terabyte, I'll click the Select button to select that option. That's why we prepared a journal file ourselves on our own device. So under Basics, it's going to be an import job into Azure. So I'll have to supply a name for that. So import job 1 will work. I'll specify a resource group and I'll click OK. Step 2, in the job details. This is where I would upload the journal file that we generated, specify the storage account destination, then in step 3, the return shipping info, and then step 4 is the summary. So in this course, we've examined how to migrate on-premises services and workloads to the Azure cloud using features available in Azure Migrate. We did this by exploring the various migration solutions included in Azure Migrate, how to use server assessment to discover and assess an on-premises server, how to use the Data Migration Assistant to perform a migration assessment of on-premises databases. We explored how to use the Web App Migration Assistant to perform a migration assessment of on-premises web apps. We looked at the use of Azure Data Box, and finally how to use the WA Import-Export tool to generate a Data Box journal file. In our next course, we'll move on to explore Azure monitoring solutions to help improve resource performance and security, including tools such as Log Analytics, Application Insights, and Azure Sentinel. While knowing how to plan for and implement Azure services is critical, equally as important is the monitoring of those deployed services. We want to be able to monitor metrics. Performance metrics will give us the ability to monitor things like availability, CPU utilization, disk I/O, database cache hit ratio, that type of thing. And that can feed into availability. Is the service available? And we might be monitoring availability from a different aspect, such as determining whether virtual machines replicated to a secondary Azure region are available. There are also security events that we should be looking at. Security events you could think of as kind of being related to security recommendations based on our deployed resources, such as the fact that we might not have disk encryption enabled for Azure VMs, and the Azure Security Center might have recommendations related to that. Performance is one of the big reasons for monitoring as well. If we determine that the utilization of resources like CPU, memory, disk I/O is excessive for a set of virtual machines supporting an application, well then maybe we need to resize the virtual machines and or enable scaling to add more virtual machine nodes to handle the workload. Monitoring is used to ensure proper resource governance, to ensure the efficacy of implemented security controls. Monitoring can also be used for accountability, such as viewing the activity log for an Azure resource to see who managed which aspect of a resource. And of course, monitoring can be required sometimes for legal and regulatory compliance, such as for the protection of sensitive data. Azure monitoring can occur for network resources, for individual hosts that are deployed, and of course, for applications as well as storage mechanisms like storage accounts. The Azure Resource Activity Log is a log of administrative tasks performed against Azure resources, like virtual machines being started, stopped, created, modified in some way. Azure Performance Diagnostics can also be enabled so that we can get details about how well a service is performing. We can build custom dashboards where we can pin items of interest, such as CPU utilization for specific virtual machines. Azure Application Insights can be enabled for Azure App Services or web applications, so that we can monitor our web apps to ensure they are functioning correctly and also determine things like certain types of HTTP errors that might be recurring. Another aspect of monitoring is a log analytics workspace. You can actually have multiple log analytics workspaces, which allows for the centralized monitoring of Azure logged data. So it's for configuration changes that might have been made to resources, as well as actual data related to things such as a web application. This all feeds into the Azure Monitor service. You can run log queries, such as determining which web app service resulted in the most HTTP 500 errors. You can configure alert notifications so that you're notified when errors occur or when utilization for a virtual machine, for example, becomes excessive. Log analytics workspaces have data sources. That's how they get their data. This can come from storage account logs, Azure activity logs, so related to Azure Resource Management, physical as well as virtual servers, as well as other tools like System Center Operations Manager or SCOM. In Azure, a log analytics workspace is its own type of resource. You can think of it as being a centralized repository for logged information, both from on-premises items like servers, as well as from Azure services like virtual machines, web applications, storage accounts, and so on. So here in the portal, I've gone to the All Resources view, and I've filtered my resource types, so I'm only looking at log analytics workspaces, of which I have 2. I'm going to click to open one of them up so we can get into the properties of the log analytics workspace. And in the left-hand navigator, I'm interested in scrolling down to the Workspace Data Sources section. It's important to configure the data sources so that you know where the data is coming from and is being fed into this log analytics workspace. So the first thing I have is virtual machines. If I click that, I will have a list of virtual machines in the subscription, some of which may be linked to this workspace. It'll say this workspace under Log Analytics Connection, or it might say Other Workspace. So the great thing about this is I can also click on the left on Storage Account Logs and select other alternate data sources that should be fed into this Log Analytics workspace. So if I go to Storage Accounts, I'll have any storage accounts that have been connected to this Log Analytics workspace. We have an Add button up at the top, and when I click Add, I can go ahead and select other storage accounts whose logged information I want available here in this Log Analytics workspace. We can also go to Azure Activity Log, and from here what we would be doing is we would be making sure our subscription is listed here so that any activity logs related to Azure Resource Management in our subscription, that information will be available through this Log Analytics workspace. Now, if I were to close this out and open a different Log Analytics workspace, we could have different data sources set for this one. So for example, if I go to virtual machines, we have a virtual machine named DC1 that is connected to this workspace. The other virtual machines that we had viewed previously that were connected to the other Log Analytics workspace show up here, but they show up as being connected to another workspace. You can change that affiliation at any time. For example, if I click to open up a virtual machine in this listing, I can choose Disconnect. I'm asked if I want to disconnect this VM from this Log Analytics workspace. I'm going to choose Yes in this case. It only takes a moment and then it's done. That would free me up then so that if I backed all the way out and went back to my first Log Analytics workspace, I could go back down into the data sources, virtual machines, DC1, I could then click on and then connect to this workspace. Now, if it's not refreshed, you won't see the option listed yet. It might take a moment, but you have the ability to disconnect resources from a Log Analytics workspace and then connect them to others. The other thing that's interesting here is that when you start working with your Log Analytics workspace, you can go to the logs view on the left. Now, this is where if you wanted to, you could create log queries. So from here, we have a lot of the query categories shown over here on the left that we could work with. Now, these are all example queries. So I can just scroll over to the right and click X to close that out if I want to work with queries manually. So over on the left, we have a list of categories like log management. We have other categories available here like security and audit, maybe Linux audit log. And then what we're doing here is we're basically browsing through tables and fields or columns within tables that we can start to click on to add over here to our query area where we can then run queries. So that is something else that we can look at as well. In the left-hand navigator down under monitoring, I can also click on alerts to work with alert rules so I get notifications, and I can work with my action groups as well. Azure Monitor is a centralized monitoring service available in the portal. So here in the portal, in the top search center bar, I'm going to search for Monitor, and I'm going to choose Monitor. So that's going to open up the Monitor Service navigation bar on the left. Now, the first thing I want to do here in Azure Monitor is click on Activity Log. Now, if you've got one or more log analytics workspaces in your Azure environment, those log analytics workspaces serve as a data feed into Azure Monitor automatically. So the activity log is related to any admin activity against Azure resources. And we have some items shown over on the right. Now, the thing to watch out for here is that you can filter it. For example, do we really want to see informational messages? Maybe, because you might use that for correlating potential security incidents. However, we can change that. I'm going to change the event severity. So I only want to see, let's say, errors. So I'm going to uncheck the other severity levels. And over the last 6 hours, there's only one error. Something about deleting a virtual machine extension that failed, and I can drill down into that and read more about it. But I can also filter on the time span, let's say the last month. I'll click Apply. And after the filter is updated, we'll see that we have a number of errors over the last month that have occurred. And so we can scroll through that and begin working with it. We can even download this as a CSV or a comma-separated value file, maybe to assign a task to another technician to look into these errors that have occurred over the last month. In Monitor, we can also click Alerts on the left. You can also get into alerts for a specific log analytics workspace, but this is a general feed from all of those workspaces for any alerts. For example, if I go to Manage Alert Rules by clicking that button at the top, any alert rules that have been configured will show up here, such as for a specific virtual machine. I've got a CPU monitoring rule for an Ubuntu Linux server. Now, while you could view that rule for the individual resource, I could go into the virtual machine properties. On a larger scale in the enterprise, it makes more sense to do it this way here through Monitor. So you can create new alert rules from here, as well as view any alert rules, and of course, any ultimate alerts that might result from that configuration. We don't have any alerts, so that's a good thing in this case. We can also click on Manage Actions up at the top and work with action groups, of which I have a few of them. Now, our action groups are used for things like receiving notifications through email or SMS text messages and so on. We can also click on Metrics on the left if we want to use Azure Monitor to monitor performance. So for example, I'm being asked to select a resource. I'm going to drill down under a resource group, let's say RG1. I could select the entire resource group, but I'm only interested in one item within it, specifically a virtual machine named DC1. I'm going to select that and click Apply. Then I'm prompted to choose a metric. So let's say I go down to the P's because I'm interested in the percentage of CPU utilization, which is always a good indicator of how the workload is affecting the resources in that VM. Now, we don't really have much that's been charted here. However, we're looking at the last 24 hours as per the upper right. So I'm going to click right on that. Let's say we select the last 30 days and click Apply. Now we have a different listing for a percentage of CPU utilization with the dates mapped across the bottom. We can also click Add Metrics towards the upper left if we want to view more than just, in this example, percentage utilization of the CPU. So maybe I'm interested in disk write bytes. We can choose the aggregation, whether it's sum, average. Maybe I'm interested in the average for that. So we can have multiple items plotted on our chart at the same time. We can choose the chart type as well. Maybe I'm more interested in a bar chart to represent my data that way. I can even choose drill into logs and click on Activity Logs as a quick way to go into the activity log just for that specific resource, in this case, the DC1 virtual machine. So that's convenient that we have a way to do that as well. We can also pin this to a dashboard. You can click and pin it to the current dashboard or select another one. I'll just choose Pin to Current Dashboard. Now the dashboards we'll look at in a moment, but by pinning important items to a dashboard, you have a quick and easy way to view those dashboards instead of going deep into, for example, Azure Monitor metrics and setting this up every time you want to view it. We can also click Logs over on the left. This is similar to the Logs view that you'll see within a Log Analytics workspace where you've got some example queries shown here. Of course, we can also manually build our own queries by selecting the categories over here on the left and then starting to drill down through these tables and ultimately to the fields and adding them to our query and running them. So we can do that as well. If you want to customize reports from this information in Azure Monitor, you can work with workbooks. I can also get insights about web applications if I have any. I can also enable insight gathering for virtual machines. So currently we don't have anything that's being monitored here for virtual machines. So we could click down where we've got 4 virtual machines not monitored, and I can drill down and select a virtual machine that's up and running. It's got to be running, such as DC1. Currently, Insights is not available, but I could choose to enable the gathering of more health and performance metrics from that virtual machine. So we have that option available as well. We can click Storage Accounts to get a listing of storage accounts and just get a quick glance of what's been going on, such as the transactions timeline column. It's very quick to visually get an idea of how many transactions have been occurring within a specific storage account. We also have the end-to-end latency as well as the server latency when it comes to accessing that storage account. So there are a number of items then that we can work with centrally in Azure Monitor to ensure the optimal and peak performance of our Azure environment. When you want to get the most detailed logging information available within a virtual machine in Azure, you can enable diagnostic logging. So to get started here, I'm going to navigate to the virtual machines view in the Azure portal. And I'm going to go into the properties of a running virtual machine here, DC1. So it needs to be running. Now, when I click on the DC1 virtual machine in the properties bar, I'm going to navigate all the way down towards the bottom under the monitoring section, where I'll then click on Diagnostic Settings. Now, diagnostic settings have not been enabled yet for this virtual machine. So what it wants to do is create a new diagnostics storage account. I'm going to let it do that, and I'm going to enable guest level monitoring. So again, the VM must be running in order for this to work. It can take a little bit of time before the logged information is available for viewing. Before too long, you'll get a notification in your notification area in the upper right in the portal that states that it successfully updated the diagnostic settings for that specific virtual machine. Now, once that's done and you return to the diagnostic settings blade, it's going to look different because it's enabled now. So under Overview, we can configure performance counters, event logs, directories, but we can also do that by going to the links at the top. So if I go to performance counters that we might want to gather from this virtual machine for diagnostic logging, it's set to basic. So performance counters are automatically checked on for CPU, memory, disk, network, but we could turn it on for things like ASP.NET, SQL Server. We could choose custom, and then we could really specify exactly what we wanted. There are numerous pages here worth of different types of counters you may or may not be interested in. The great thing here is you are given the ability to, for example, even remove performance metrics that aren't of any relevance for your current needs. So we can do that. Logs. What about logs for different services running within the VM? Well, we can go to the logs part at the top. The default Windows logs are turned on. So the application log, critical error and warning events, the security log, audit failures. You might want audit successes logs. You could turn that on. All of these things are available, including IIS logs if you've got Internet Information Services running, so the Microsoft Web Server, and even application logs can be enabled, so that is available. We also have crash dumping that can be enabled to collect memory dumps when the VM crashes for further analysis. So let's go back home here, and why don't we take a look at the storage account that was created for this. So I'm going to open up my storage accounts view over here on the left. So we've got a new storage account. It's the RG1 guest diag account that was created to store diagnostic information. So I'm going to open that up. And in the properties of that storage account, I'm interested in going to the blob service containers blade. So once the diagnostic logging kicks in and activity is generated within the virtual machine, we'll start seeing some containers here with our diagnostic data. Application insights can be enabled for an Azure app service or a web application. Now you can do this when you are deploying the app service or at any time thereafter. We're going to do it while we deploy a new app service. So here in the portal, I'm going to click Create a Resource, and I'm going to search for Web App. I'll choose Web App. I'll click Create. And I'll just specify some of the standard details here, such as the resource group this app service will be deployed into. I'm going to call this Web App Test 1723. It's just going to be code. I'll just choose, let's say, .NET Core. And I'm going to keep scrolling down here. I'll specify the region where I want this to work, Canada Central. And it's going to create a new app service plan, which is fine. I'll accept the default for the sizing. I'll click Next for monitoring. Now, this is where we get the Application Insights option. It wants to create a new Application Insights object. So I'm going to go ahead and let it do that. I'll click Next for tags. Not going to add tags. I'm going to click Review and Create. And after it validates, I will click Create to deploy this app service with Application Insights enabled. And after a moment, the deployment is complete. So I'm just going to go home here in the portal, go to All Resources. I'm going to filter out the list of resources here by clicking Type, unchecking Select All, and I'm going to choose Application Insights because that's what was just created, as well as our app service, of course. So I'm going to go ahead and click outside to filter the list. There's our Web App Test 1723 Application Insights item. Why don't we also filter the list to include app services? So there's our app service or our web application, Web App Test 1723. I'm going to click to open that up. Remember, we said that you could enable Application Insights for an existing app service if it hadn't been done during deployment. Well, if you scroll down in the navigation bar under Settings on the left, you will see Application Insights. And when you click on it, if it's not enabled, you'll be able to enable it. Now, of course, if you really want to be able to monitor all of the detailed background components running within a web app, then you might need to do that at the developer level. So software developers will be involved with this potentially. But if you're really looking at monitoring the performance of your application, then this is definitely something that you would consider doing. So let's close out of this. Just going to click the X in the upper right. Let's go into our Application Insights object. In the Overview blade, we'll have some listings or some charts for any failed requests in our application, the overall server response time, server requests availability. Now, that's over the last hour, and we've just deployed this app, but you can also do it, for example, over the last 30 days to get an overall picture of how the application is performing. You can also click Failures over on the left to open the Failures blade, so you can get things like specific HTTP response codes that might have been generated as a result of those errors. You can click Performance on the left to get an overall general sense of how your application is performing. You can also click Live Metrics on the left to get a listing of incoming requests. So the rate of requests, the duration of the requests, any failures. That's for incoming requests, also outgoing requests, and overall health, such as the CPU utilization that is related to that. So when you need to drill down and get a bit more performance details for a web application, you should be enabling Application Insights. In the English language, a sentinel is a guard that stands watch to protect from some type of a threat. And in Azure, Sentinel does the same type of thing. Azure Sentinel is considered a SIEM as well as a SOAR solution. SIEM stands for Security Information Event Management. It's sometimes also called SIEM. SOAR stands for Security Orchestration Automated Response. So Sentinel is all about detecting threats and then doing some kind of a response to mitigate that threat. We'll talk about this in further detail. So security information and event management is really about real-time security alerts. So that means we have to have a data feed from multiple sources to be able to do that. And that data feed needs to be available in a timely fashion. SIAM also allows for event analysis and correlation. As an example of correlation, detecting perhaps that there's been a change in a device on the network could be correlated to a past event where the device all of a sudden appeared on the network where previously it hadn't been there. So we can draw some interesting conclusions from that type of correlation, and that's what SIAM will do automatically. SIAM data sources include web applications, network infrastructure equipment or your VNet configuration, your routing tables in Azure, database deployments, Azure Files shared folders, and also any of your authentication servers that might be configured, which includes Azure AD. Your SIAM configuration needs to be tweaked. It is specific for a given environment to determine what's normal. We also want to make sure that we configure SIAM in such a way as to reduce false positives. We don't want to get alerts for something that appears to be a threat when it's normal for this particular environment. So we need a baseline of normalcy to be able to configure that appropriately then. We also need to make sure that our configuration aligns with specific laws and regulations, which might include things like ensuring certain types of encryption strength are enabled, whether it's over the network or for data at rest, and if not, then we want to get an alert about that. So we can configure alert thresholds for that type of purpose, as well as alert thresholds for things like incorrect login attempts as another example. Security orchestration, automation, and response, or SOAR, is really about responding to potential threats. So that means data needs to be ingested from multiple sources, much like a SIAM system. But what's different here is a workflow playbook can be applied. This means that we can automate security triage, so the assessment of events to determine if in fact they are truly a threat, and then we can automate the response and mitigation. So SOAR can be used to weed out false positives, and also because of automation, reduce security incident response time. We can also have automation contain any incidents and also remediate any incidents. So Sentinel then is a combination of a SIAM and a SOAR solution. In this demonstration, I'm going to deploy an Azure Sentinel configuration for threat detection and response. So to get started, I'm going to click Create a Resource, and I'm going to search for Sentinel. I'll choose Azure Sentinel, and then I'll click on the Create button. That takes me into a view where I am shown any Azure Sentinel workspaces I might have deployed previously. I haven't done that yet, so I don't have any Sentinel workspaces. So I'm going to go ahead and click the Add button to add one. I'll choose Create a New Workspace. I'll specify a resource group where I want this deployed. I can also specify the name for it. I'm going to call it Sentinel 1723. Now I have to then define the region, geographical location or region where I want this deployed. So I'll choose Canada Central, and then I'll choose next for the pricing tier. I'm going to leave it on the pricing tier related to my single subscription. I only have one subscription, pay as you go. I'll click Next for tagging, Next Review and Create, and I'm going to then click Create. And after a moment, the Sentinel workspace will have been deployed. So I'm going to click to open it up. That'll put me in the overview blade for Sentinel. Now we don't have any events or alerts configured at this point. Now it's important that Sentinel be configured with a log analytics workspace. So if I scroll all the way down in the left-hand navigator and go down to Settings, on the right-hand side of the screen, so in the right-hand panel, I'll be able to click Workspace Settings. That's going to take me to a log analytics workspace created for Azure Sentinel. And if I scroll down in that log analytics workspace, I can go into Workspace Data Sources and, for example, select virtual machines that I might want connected to this workspace. So if I click on a virtual machine, I could disconnect it from another workspace and connect it to this one. Of course, the virtual machine has to be running for that operation to succeed. So it's important to make sure We link Sentinel to a log analytics workspace. Not only that, but if we go under configuration in the left-hand navigator for Sentinel and click on data connectors, we can also add a number of different data connectors to get data from other locations, such as from Azure Information Protection or Azure Security Center, or even third-party connectors like Barracuda CloudGen Firewall or Checkpoint Firewalls or Cisco ASA devices, and so on. The idea is that we want to be able to detect anomalies and perhaps even take steps through workbooks to mitigate those issues. So in this course, we've examined ways to monitor Azure resources, including the use of Azure Monitor, diagnostic logging, application insights, and Azure Sentinel. We did this by exploring various methods available for monitoring Azure resources, how to add data sources to a log analytics workspace, how to use Azure Monitor. We examined how to enable Azure Diagnostic Logging, how to enable application insights, and finally, we explored the use of Azure Sentinel and its configuration.